Hello, I'm Timothy Jordan, and you're watching the Google I/O 2016 livestream. The keynote is over, but there are many more developer sessions to come. Stay tuned on all 4 livestream channels throughout the next 3 days. We'll also be on the ground and behind the scenes finding the coolest and most innovative things to share with you right here on the livestream between sessions. Oh, and if you want us to track someone down with your question, use the hashtag AskDevShow.
Right, here we go. Mr. Lewis, how do you feel about roller coasters?
Oh, I like them. Roller coaster of love. Let's roll.
So, I've got a bone to pick with you.
Oh, that's unusual.
So
We normally get on just fine.
Well, because I've been watching you.
No,
and,
that's a bit weird.
I've noticed that you've been engaging in some degree of Babel activity.
Oh,
You've
thank
been
goodness
using
for
a bit
that.
of
Okay.
the
not-
ES6, ES7.
Not quite as terrifying as I thought it might have been this.
But you're the kind of person who says, and I've heard you say this, that you don't like writing code that isn't the code that ends up being executed in the browser.
Correct.
You don't like
Don't
those
like
little middle steps. You're kind of anti-transpiler.
I am sort of anti-transparent. I want to feel like the code I write is the code that runs,
Right.
and I'm happy for a little bit of wool to be pulled over my eyes, but I want to feel like I can back out of it. So I don't think that's changed. I think for me, when I look at something like Babel, or Babelify or any of that, one thing is I feel like I could switch it out for Tracer, or I could switch it out for something else.
Because it's an open standard, I guess there are independent implementations of that standard.
Exactly.
Oh, okay, yeah, that's fair
so it's like, it feels like this is the JavaScript I'm going to be writing, right? So a while from now. So if it's going to get me there, then that's fine. I'm okay with that. And then the other thing is, if you look at the ES5 that it generates, it's like, it makes sense, it's fine. And I feel like when you look at some other things, whether that, I don't know, CoffeeScript or TypeScript, something like that, you can never say that, because it's like, you're always going to be transpiling across.
Yeah, I had this issue actually. I was using a project, npm installing something, using it, and there was a bug, and I thought, as a citizen of the internet, I am going to do a pull request. I'm going to try and fix that. And and when I got onto GitHub and click, CoffeeScript.
Oh,
I was like,
okay, yeah, no, bye-bye.
Now step 1 of making this fix is learn CoffeeScript.
Yeah, and it's like, unless I really, really care about fixing the bug, it's not. For me, it's like JavaScript become, ES6, ES7, ES whatever.
Mm-hmm.
But like you say, this kind of, let's learn TypeScript or CoffeeScript or anything else. It's just like, I've got to really want to go off and do that for some reason, and I don't see what that reason is, because JavaScript for me, for everything, is fine. I actually really liked Babel, if for no other reason than its source maps were just super. So even though I wasn't really sort of aiming for that, when I did get an error, it was like, whatever .js line, whatever, and it was like, yeah, that is the correct line. And
well, so even if you're not using source maps with Babel, the output is actually pretty sensible for the most part.
Yes.
But as you say, source maps just make it completely transparent. It's almost like you're not using a transpiler at all.
Exactly. So I'm happy with the illusion of it, I think. That's probably what it comes down to. But as I say, you're right. If you look at the actual code it generates, for me, I was just like, yeah, that's not necessarily code I'd write, but that's okay. It's just about manageable and readable.
So go on then. What are your big hitters in ES6 and 7 world? What's your favies?
My faves.
Your faves.
Contentious one would be classes. I actually really like classes, because people are like, what's wrong with the prototype? You're turning your back on prototypes.
You're still using a prototype. It's just sugar.
Yes, exactly.
Yeah.
But a nice sugar at that. Very nice.
Yeah, because I don't know. I always mess it
Refined
up.
sugar.
Like if I'm doing like something.prototype equals object.create, the thing I'm extending, and I keep forgetting the .prototype on the end there.
But that's one of about
It's
11
really difficult. It's really awkward compared to class thing extends thing.
And that's the one way you do it in ES6. Like with the ES5, you've got 11 billion ways of doing it, and not all of them are good necessarily, or readable, or what you want to see if you're looking at your own code 6 months from now or somebody else's code. So it kind of felt like it was more like the code I want to write, more like the code I want to read. It's where we're going. It's a feature. It's not like somebody just went off piste and did something that they wanted to do.
And I can barely remember how to spell function now.
Yeah.
Because you can within an object, it's just the name, brackets, off you go.
Yes.
There's arrow.
Fat arrow function
Fat
was
arrow.
something else I really liked.
Yep, we love a bit of fat arrow.
Yeah, because a number of times I use request animation frame, set timeout, set interval, something
Yep.
like that, and it's
Yep.
like, oh, all of a sudden I'm on the window scope, am I? Great, thanks for that. So bind, it's like, don't worry. I don't mind bind. It's better than var that equals this for me.
I don't.
You don't like that.
No, I don't do that equals this. But I will give it a specific, proper variable name.
Like what?
Based on the name of the class.
Like
Well, okay.
Jakey this, var Jakey this equals.
So if it's class vehicle,
yeah.
inside that I will do var vehicle equals this, like lowercase vehicle equals this, and it's yeah, but it makes sense then. I don't like that because it's like, well, that's just because this is a problem in JavaScript, I think.
Yes.
Like so this what like
Yeah.
and that's what one of the things that arrow functions solve is you there tends to only be one option for what the this is, and it's the instance name.
Yeah.
Which that makes way more
So it
sense.
works for me. I really like that.
Destructuring I like.
Beautiful. Beautiful.
Especially for option objects.
Yes.
At the end of a
With defaults,
function.
right?
This is it. It becomes self-documenting. You can say, right, this is optional, but inside this object, here are the properties that I'm looking for, and here are their defaults.
Yep. But in any case, I feel like, going back to your original question, it's like the reason I would use a transpiler today is an if and only if it lets me experience the future now, get used to like the future now. I think it's where we're going.
Which you get with source maps. It feels like you can almost ignore the transpilers
Yeah,
there.
exactly. And as I say, the code that it generates makes sense to me. So I'm all up for that.
Yay for transpilers.
Yay!
Cheers. We need beers.
All right, well, it's getting pretty late. I think that was a pretty good take, so let's just do one more and then we'll be out for the day, okay, Rob?
All right.
3, 2.
Otherwise, as
Hey,
always,
Rob.
oh, hey, what's up, David?
Did I tell you that I got my own YouTube show?
Oh no, dude, that's awesome. What's it gonna be about?
So, like, I was thinking there's, not a lot of screencast content out there, and so I'm gonna go and make a bunch of screencasts on Firebase.
Well, that's sort of exactly what we're doing here for Polycast, a show about.
It's nothing like that, really. Like I said, my show is gonna be on Firebase. Like building real-time cross-platform apps, without any server code.
Well, I have all this equipment. I have this crew. So if you want, I can show you the ropes
So I was thinking of
sometimes.
calling
like how we
it
put the
Firecasts. The Firebase, is for the fire.
the Firebase, yeah.
And like the cast comes from screencast.
Screencasting.
Yeah.
Yeah.
What do you think?
Six lines of code is all it takes to write your first machine learning program. My name's Josh Gordon, and today I'll walk you through writing Hello World for machine learning. In the first few episodes of this series, we'll teach you how to get started with machine learning from scratch. To do that, we'll work with two open source libraries, scikit-learn and TensorFlow. We'll see scikit in action in a minute, but first let's talk quickly about what machine learning is and why it's important. You can think of machine learning as a subfield of artificial intelligence. Early AI programs typically excelled at just one thing. For example, Deep Blue could play chess at a championship level, but that's all it could do. Today we want to write one program that can solve many problems without needing to be rewritten. AlphaGo is a great example of that. As we speak, it's competing in the World Go Championship, but similar software can also learn to play Atari games. Machine learning is what makes that possible. It's the study of algorithms that learn from examples and experience instead of relying on hard-coded rules. So that's the state of the art, but here's a much simpler example we'll start coding up today. I'll give you a problem that sounds easy, but is impossible to solve without machine learning. Can you write code to tell the difference between an apple and an orange? Imagine I asked you to write a program that takes an image file as input, does some analysis, and outputs the type of fruit. How can you solve this? You'd have to start by writing lots of manual rules. For example, you could write code to count how many orange pixels there are and compare that to the number of green ones. The ratio should give you a hint about the type of fruit. That works fine for simple images like these, but as you dive deeper into the problem, you'll find the real world is messy, and the rules you write start to break. How would you write code to handle black and white photos? Or images with no apples or oranges in them at all? In fact, for just about any rule you write, I can find an image where it won't work. You'd need to write tons of rules, and that's just to tell the difference between apples and oranges. If I gave you a new problem, you'd need to start all over again. Clearly, we need something better. To solve this, we need an algorithm that can figure out the rules for us so we don't have to write them by hand. And for that, we're going to train a classifier. For now, you can think of a classifier as a function. It takes some data as input and assigns a label to it as output. For example, I could have a picture and I want to classify it as an apple or an orange. Or I could have an email and I want to classify it as spam or not spam. The technique to write the classifier automatically is called supervised learning. It begins with examples of the problem you want to solve. To code this up, we'll work with scikit-learn. Here, I'll download and install the library. There are a couple different ways to do that, but for me, the easiest has been to use Anaconda. This makes it easy to get all the dependencies set up and works well cross-platform. With the magic of video, I'll fast forward through downloading and installing it. Once it's installed, you can test that everything is working properly by starting a Python script and importing sklearn. Assuming that worked, that's line 1 of our program down. 5 to go. To use supervised learning, we'll follow a recipe with a few standard steps. Step 1 is to collect training data. These are examples of the problem we want to solve. For our problem, we're going to write a function to classify a piece of fruit. For starters, it will take a description of the fruit as input and predict whether it's an apple or orange as output, based on features like its weight and texture. To collect our training data, imagine we head out to an orchard. We'll look at different apples and oranges and write down measurements that describe them in a table. In machine learning, these measurements are called features. To keep things simple, here we've used just 2, how much each fruit weighs in grams and its texture, which can be bumpy or smooth. A good feature makes it easy to discriminate between different types of fruit. Each row in our training data is an example. It describes one piece of fruit. The last column is called the label. It identifies what type of fruit is in each row, and there are just 2 possibilities, apples and oranges. The whole table is our training data. Think of these as all the examples we want the classifier to learn from. The more training data you have, the better a classifier you can create. Now let's write down our training data in code. We'll use 2 variables, features and labels. Features contains the first 2 columns, and labels contains the last. You can think of features as the input to the classifier, and labels as the output we want. I'm going to change the variable type of all our features to ints instead of strings. So I'll use 0 for bumpy and 1 for smooth. I'll do the same for our labels, so I'll use 0 for apple and 1 for orange. These are lines 2 and 3 in our program. Step 2 in our recipe is to use these examples to train a classifier. The type of classifier we'll start with is called a decision tree. We'll dive into the details of how these work in a future episode, but for now it's okay to think of a classifier as a box of rules. That's because there are many different types of classifier, but the input and output type is always the same. I'm going to import the tree, then on line 4 of our script we'll create the classifier. At this point, it's just an empty box of rules. It doesn't know anything about apples and oranges yet. To train it, we'll need a learning algorithm. If a classifier is a box of rules, then you can think of the learning algorithm as the procedure that creates them. It does that by finding patterns in your training data. For example, it might notice oranges tend to weigh more, so it'll create a rule saying that the heavier a fruit is, the more likely it is to be an orange. In scikit, the training algorithm is included in the classifier object, and it's called fit. You can think of fit as being a synonym for find patterns in data. We'll get into the details of how this happens under the hood in a future episode. At this point, we have a trained classifier, so let's take it for a spin and use it to classify a new fruit. The input to the classifier is the features for our new example. Let's say the fruit we want to classify is 150 grams and bumpy. The output will be a 0 if it's an apple or 1 if it's an orange. Before we hit enter and see what the classifier predicts, let's think for a sec. If you had to guess, what would you say the output should be? To figure that out, compare this fruit to our training data. It looks like it's similar to an orange because it's heavy and bumpy. That's what I'd guess anyway, and if we hit enter, it's what our classifier predicts as well. If everything worked for you, then that's it for your first machine learning program. You can create a new classifier for a new problem just by changing the training data. That makes this approach far more reusable than writing new rules for each problem. Now you might be wondering why we described our fruit using a table of features instead of using pictures of the fruit as training data. Well, you can use pictures, and we'll get to that in a future episode, but as you'll see later on, the way we did it here is more general. The neat thing is that programming with machine learning isn't hard, but to get it right, you need to understand a few important concepts. I'll start walking you through those in the next few episodes. Thanks very much for watching, and I'll see you then.
Developing a successful app isn't easy. To reach a broad audience, you'll need to consider your iOS, Android, and mobile web users. And to build for these platforms, you'll need a backend server to store data and support the apps. Of course, you want to get your users logged in, hopefully lots of users, which means your backend will have to scale. Then after you've solved your scaling problems, you'll have to find more ways to spread the word to get new users. But have you found a way to measure all this activity? And oh no, your app is crashing and causing servers to melt down, and you haven't even made a dime yet. Don't you wish this could be easier? This is why we built Firebase. It has all the tools you need to build a successful app. It helps you reach new users, keep them engaged, scale up to meet that demand, in addition to getting paid. From the beginning, with Firebase, you'll have test lab and crash reporting to prevent and diagnose errors in your app. Your backend infrastructure problems are solved with our real-time database, file storage, and hosting solutions. Acquiring new users is easy with invites, AdWords, and dynamic links. And using the authentication component, you can get those users logged in with minimal friction. Once installed, you can keep your users engaged with notifications, cloud messaging, and app indexing. Then, with Remote Config, you'll have the freedom to experiment with new features and optimize the user experience in real time. And of course, you can earn money with the same AdMob component that's been monetizing great apps for years. Last, but certainly not least, our all-new Analytics component, designed uniquely for Firebase, brings insight into how well these components are working for you and your users. With Firebase Analytics, you can measure and optimize your advertising campaigns, discover who are your most valuable users, and understand exactly how they are using your app. Now, all these components work great on their own and provide a solid infrastructure to build out your app, but they work even better when combined in creative ways. So let Firebase handle the details of your app's backend infrastructure, user engagement, and monetization, while you spend more time building the apps your users will love. To get started right now with Firebase on Android, iOS, or the web, follow these links for more information. Then, to manage and monitor your apps connected to Firebase, there's a web console to view crashes, set up experiments, track analytics, and a whole lot more. And to learn more about Firebase and all of its components, you can read the documentation right here. We can't wait to see what you build.
Let's be honest, you're an awesome engineer with an awesome app and you are using threading to the max. Sadly though, managing all those individual threads and assigning work between them is causing you to lose your hair. My name is Colt McCandless, and please, don't join the Bald Club. Instead, use the thread pools class, which is an ideal primitive for breaking up lots of work into little buckets. See, historically, it was commonplace that applications would use a dedicated thread model. That is, one thread that only deals with database rights, while a separate thread only handles streaming of music, and a third one only handles networking. These setups are okay because the amount of work per thread isn't that large, and it's okay to handle this work in sequential order. But there reaches a point where this model starts to fall over. Say, for example, that you've got 40 bitmaps to decode, and each decode takes like 4 milliseconds or something. Putting all of this work on a single dedicated thread is a bad idea, since it'll take 80 milliseconds total to get all that work done in a sequential fashion. On the other hand, if you created 10 threads and let each one decode 4 bitmaps, then you'd end up only taking 16 milliseconds total. But then, of course, you run into the problem of how to properly pass the work around between those threads, schedule that work, and then managing of those threads. Before you start stressing out about writing all that code, don't worry. This is exactly what Thread Pool Executor primitive is for. Basically, this class will just let you spin up a number of threads and toss blocks of work to execute on it. Thread Pool Executor handles all of the heavy lifting of spinning up the threads, load balancing work across those threads, and even killing those threads when they have been idle for a while. Basically, it handles all the heavy lifting of super parallel processing on your behalf. All you have to do is split up the work. But there's a small caveat here. How many threads should your thread pool have? I mean, technically speaking, you have the ability to create as many threads as you want, but that's not ideal. See, CPUs can only execute a certain number of threads in parallel. Once you get above that number, then the CPU has to start deciding which threads get the next free block of processor time based on how important they are. Which means that if you keep eventually adding threads, you'll hit a break-even point where your computation isn't getting any faster, even though the number of threads that you have has increased significantly. And it's also important to note that each of these threads aren't free. Each thread costs you about 64K of memory in minimum, and that adds up quickly, especially in situations where the call stacks can start growing pretty large. As such, your app needs to find a sweet spot between the number of cores and the point of diminishing return with the number of threads. Thankfully, once again, the thread pool executor class has got you covered. When creating your thread pool, you can specify the number of initial threads and the number of maximum threads. As the workload in the thread pool changes, it'll scale the number of alive threads to match. Oh, and a quick note, the value returned from get available processors may not reflect the number of physical cores in the device. Now, see, some devices have CPUs that will deactivate one or more cores depending on the system load to save battery. So if your device has 2 CPUs, but one of them is asleep, this value could return 1. And of course, thread pools won't solve all of your threading problems. As mentioned earlier, unless you're dealing with lots and lots of work packets all the time, this thing's kind of overkill. It's best to use things like handler threads or async task loaders for specific types of work blocks and only throw the massive computing problems at the thread pool. And for you power users out there, remember that render script might be a better alternative to large-scale parallel work on Android devices, but that's a whole separate set of videos that we haven't gotten into yet. And don't forget that systrace is an amazingly powerful tool that lets you visualize how work is flowing through the threads in your application. It's a great way to validate that things are working as intended and also see all the other crazy threads that are being worked on by other parts of your app. And that's the trick with performance, isn't it? I mean, you can make assumptions, but things don't always work the way you think, which is why you need to check out the rest of the Android Performance Patterns videos, and don't forget to join our Google Plus community to ask a lot of hard threading questions as well. So keep calm, profile your code, and always remember, perf matters.
Hey folks, welcome to Totally Tooling Tips Season 3.
Come check us out. We're going to be talking about progressive web apps, some of the tooling around them.
On first visit, we've got a relatively fast time to first meaningful paint.
Module bundling, accessibility.
Do you know what the top 4 things to look at when it comes to web accessibility are?
No, I can only think of 2. I only think of audio and then visual.
So there's visual, hearing, mobility, and cognition.
The first episode will be out on April the 27th. So subscribe to the YouTube channel, check out Season 1 and 2 before Season 3 starts, which will be happening soon.
We promise that Season 3 is going to be equally as mediocre as Seasons 1 and 2.
Welcome to the Googleplex. This is an incredible place with lots of great stuff being worked on every single day. Before I worked here, I always wondered what it would be like to come to the Googleplex, meet up with a Googler, and have coffee with them, and just chat about what they do, how they do it, and why they do it. And today we're going to do exactly that. Welcome to this episode of Coffee with a Googler, and if you, like me, love games and love 3D games and all that kind of stuff, then this show should be a treat for you. Because today I'm chatting with Shannon Woods, who's a technical program manager, and she works on our rendering teams at Google, and she's got lots of great stuff to talk about in the 3D space. So welcome, Shannon. How are you?
I'm doing all right. How are you?
Really good. I have to say I'm really envious of your job, but could you tell us what you do?
So I work with a couple of rendering teams here at Google, both Android and Chrome. And we sort of plumb code from user space down to your GPU.
Wow. Can you translate that?
Basically, our job is to get a bunch of triangles from applications down to the GPU as fast as possible.
Cool. And all graphics are ultimately made up of triangles, right?
Basically.
Now, recently you announced Vulkan. Right, and this is this like new and improved 3D rendering API. Could you tell us a bit about it?
Historically, Android and all mobile phones really have used OpenGL ES to communicate to the GPU within the phone to tell it how to draw scenes. But unfortunately, over time, the API has become less and less of a good match for what the hardware is actually doing beneath. So what would happen is you would use this API to communicate a lot of the details about your scene, and the GPU has to reorganize all of that so that it can consume it efficiently and draw it on the screen. So what Vulkan is it's another API from the same open standards group that makes OpenGL. And it's designed to be a lot closer to what the hardware actually does beneath the covers.
Okay.
So if you provide the data via Vulkan, it should be able to draw a lot quicker. Sort of the flip side of that is that it gives you all of this control, but it means that you have to be pretty good at making sure that your code is doing exactly what you wanted it to do.
Vulkan and OpenGL are both from the same standards body, right?
Yes.
So that's Kronos?
Yes, Kronos.
Kronos, sorry. So you work with the standards body at Kronos?
I do. I get to travel all around the world and see beautiful conference rooms. But it's actually really interesting getting to see how the API is made from the ground up.
Cool.
Android is going to support both OpenGL ES and Vulkan. So developers can choose which API is right for what they're doing. Like if they need to render a FPS game or first-person shooting game that has to run really fast at a high frame rate, then they're going to probably want to choose Vulkan so that they can closely control exactly what's being drawn and when.
Cool.
But if they just want to get a couple of shapes on screen, then OpenGL ES is probably still the right choice for them.
Cool. So it's just really nice to have both.
Yes.
Cool. So, and from my understanding, what you're saying with Vulkan, like just being able to get down to the chipset level effectively allows you to squeeze a lot more performance out of the machine.
Yeah, it does. And one of the other things that it does is that it allows for greater parallelization.
Okay.
There's a lot of work in OpenGL ES that it's blocking work. You make a call into OpenGL ES, into the driver code, and it has to stop and perform the task that you asked it to do, and doesn't return control to the application until it finishes that task. And what this means is that if you have multiple threads, only one of them can really be talking to the driver doing these things at the same time. Vulkan is designed more for multi-threaded applications, so you can have multiple threads doing things like constructing buffers full of commands at the same time.
You're getting onto like programming and skills, and like from a skills perspective, and is the things that developers will need to learn that they don't do already, for example, if they're doing 3D games in OpenGL ES?
So the skill sets are going to be largely the same. As a Vulkan developer, you're going to have probably a tighter handle on things like, synchronization, careful tracking of memory allocation, because a lot less of that is going to be done for you by the driver. The upside of this is that the driver won't be doing these things when you don't expect it to. But you're going to have to really hone your skills at things like multi-threaded synchronization, memory allocation. Make sure that you are closely keeping an eye on what your code is doing and what it's asking the GPU to do, because the driver is going to do a whole lot less of that for you. It's not going to clean up after you. It's not going to check that you are making legal calls. So you're basically going to have to be a bit of a ninja.
It's almost like driving stick versus driving manual, right?
That's probably a really good analogy.
So people can learn about Vulkan on the Kronos site?
Yes.
You mentioned. So that's Kronos.org?
Kronos.org, www.kronos.org. And Kronos is spelled Khronos. And they have a Vulkan landing page where you can find the latest news about Vulkan and also see some of the presentations that were given, for example, at SIGGRAPH this year and at GDC about the shape of the API.
Okay. Now you were at SIGGRAPH, right?
I was at SIGGRAPH.
How did it go?
It was a lot of fun, actually. We did some demos, showed some spinning teapots.
Teapots?
So there's a little bit of history behind the teapot.
Okay.
The teapot is canonically called the Utah teapot, and it's because way back in the history of computer graphics, it's one of the first models that was digitized and shared. And interestingly, so the teapot, everybody knows that they've seen here and there over the years, it looks short and squat.
Okay.
But the reason for that is actually that on the original display system, the pixels were not square. So they had a different
ones from
TVs.
TVs.
The aspect ratio is a little bit different. So in real life, the teapot's actually a little taller.
Now you're saying that the pixels are like elongated, they were rectangular pixels, because this was done so long ago?
Oh yeah, it was, oh gosh, I guess it was the 70s.
Wow. So the first 3D model that was formed in cyberspace or whatever you want to call it back in the 70s, and you're still using the same model today to... I think Pixar also use the teapot, don't they?
Yeah, actually the teapot appears in every Pixar film. One of the ones I know off the top of my head is they use it in the Tea Party scene in Toy Story.
Okay, naturally that's where a teapot would fit.
Yeah, but there's one in every Pixar film.
Thank you so much, Shannon.
Thank you.
And thanks everybody for watching this episode of Coffee with a Googler. I don't know about you, but I've learned a lot about the kind of things that can be done with 3D graphics. And I'm really, really excited about Vulkan coming to Android. If you've got any questions for me, or if you've got any questions for Shannon, just please leave them in the comments below. We'll also link to the websites in the description of this video so that you can follow those links. And if you want to learn anything else about great stuff that Google has to offer for Android developers, Chrome developers, and everybody else, please subscribe to the Google Developers channel. Thank you.
With Android Lollipop, material design changed the way that apps look and feel to create more magic moments. But devices running earlier versions of Android don't have all of the same options. I'm Joanna Smith, and one of the coolest things that material design gave us were toolbars, which are now even more magical because they're backwards compatible as well. A toolbar is a view that is richer and more flexible than the traditional action bar. In fact, toolbars are part of your view hierarchy, so they can be animated or even react to scroll events. Because it's a view, you can use the toolbar as a standalone element anywhere in your app, providing the user with options and controls that don't need to span the entire layout width at the very top of the screen. You can even have multiple toolbars if the structure depends on the content of your layout, or if you're providing the user with many differing controls. To populate your toolbar with actions and options, you can inflate a menu onto the toolbar to display those actions to the user. You can also create your own controls, like adding a navigation button to go up to the parent activity. While toolbars can be used in any part of your layout, you can also choose to use the toolbar instead of the action bar whenever you simply want more control over the appearance and functionality of that action bar. So to use a toolbar in the place of the standard action bar, you first need to disable the action bar. The easiest way to do this is to have your theme extend from theme appcompat no action bar, or its light variant. Then create your toolbar the way you would create any other layout in your app, and call setActionBar to designate it as the action bar in the activity or fragment. By calling this method, the system will add the standard action bar options for you, so you don't need to inflate a menu. Now, you may be convinced of how awesome toolbars are, but how can you use them in versions of your app targeting older SDKs? Well, toolbars were added to the support library for appcompat v21, so now it's as easy as calling setSupportActionBar instead of setActionBar to replace action bars on older devices. So check the documentation for all of the support options available so that you can bring more magic moments to your users. And for more tips on making sure that your app is at its best, check out the rest of our Android Development Patterns content or consider joining our G+ community. But most importantly, just continue to build better apps.
As a lot of developers know, there's more to having an app succeed than just building a great app. You want your app to be dynamic and responsive by delivering fresh content to users and quickly reacting to their changing needs. You want to test out major decisions to make sure you're doing the right thing before you push them to your entire audience. And ideally, you want to provide a tailored experience for each user, so your VIPs feel like, well, VIPs. But let's be honest, that can be a lot of work. And if you're a developer without a ton of resources, that's time you'd rather spend on other things, like building your app. That's where Firebase Remote Config comes in. Firebase Remote Config is a simple key value store that lives in the cloud. But don't let that simplicity fool you. Because it lives in the cloud, it means you're able to deploy changes that your app can read within a matter of minutes. For instance, say you've just pushed your app out to the world and you suddenly discover that your Swedish text contains some offensive language. How are you supposed to know? You don't speak Swedish. I don't blame you. But fixing that text the old-fashioned way would mean creating a new build and going through the entire publishing process again. That's something that could take days, which is an awfully long time to have 9.2 million people cursing your name. But if your app uses Firebase Remote Config, you could change that text in the cloud through the Firebase console. Kind of like this. The next time your users fire up their app, Remote Config will grab the latest values, update your app's text, and just like that, you've averted a major international crisis. Or, let's say you've got a puzzle game and you're hearing complaints from your players that level 5 is too hard. If you've configured your app using Remote Config, you could tweak those settings to give your players a few more turns and push out that change to the world. But hang on, are you sure that's the right thing to do? What if the silent majority of your users actually enjoy the challenge of a more difficult level? And by making it easier, you're going to turn away your most hardcore and potentially highest paying customers. How could you test whether or not this change is a good one? Sounds like you need an A/B test. That's where Remote Config's audience segmentation feature comes in. This allows you to deliver different configurations to different groups of users simultaneously. So you can try out your new level settings with half your users while keeping the old settings with the other half. But audience segmentation isn't just great for A/B testing. Maybe you've got a feature change that could have a major impact on your in-app economy. Or maybe you just want to double check that some new networking code isn't going to set your servers on fire. You can use Firebase Remote Config to gradually roll out these changes, trying them first with a small percentage of your users before pushing them out to your entire audience. Remote Config can also deliver different configuration sets to your users based on all sorts of different factors, from device type or locale to any audience segment you've defined in Firebase Analytics. So you can send out one welcome message to your New Zealand customers and another to your Australian ones, or only show your Review This App button to people who use your app every day, or you can change your home screen experience for your customers who have spent large amounts of money on in-app purchases, so they feel special. Remote Config is backed by a client library on iOS and Android that handles important tasks like caching, dealing with flaky connections, and keeping network requests lightweight, which is always a good thing. To give Remote Config a try, check out our documentation here. We can't wait to see what you build.
Here's an old school tip for you. If you can animate something based on user input, you probably don't want to have it update immediately to track the input event, because it can often feel very jittery. Instead, what you should do is use the oldest easing equation in the book, which looks like this. Value plus equals target minus value all over strength. Here we're changing the value based on how close it is to the target. The closer it is, the less it gets moved, making it look way nicer. So there you have it, a little tip to make your input-based animations a teeny bit smoother.
Another day, another journey.
I know indeed, right? How's your aim?
Well, not great in the middle of the night, but I sometimes just sit down.
No, actually I meant your snooker, your pool, or in this case, your billiards.
Ooh, we're going to a billiard hall.
That we are, sir.
So, I made a thing.
That's unusual for you.
I know.
You're like 2 in as many months or something.
Yeah, it's a new thing. It's
what is
really,
it?
It's a little.
Is it a web app?
Yes, it is a web app.
Is it a website? What's the difference, Jake?
Shut up. We're not doing web apps. This is a website. I would say it's an app.
Would you?
I
an app with content.
Flipped a coin. It's an app. No, it's not. It's a site. It's a Wikipedia article viewer.
Okay.
Which I realise is what Wikipedia does already.
Yes.
But this was more of an exercise in looking at like performance, like page load time performance.
But you think you can beat Wikipedia at a server-side render, do you?
I did.
You did?
Well, so this is the thing. I was hosting on GitHub, so I was doing a client-side render.
I know. After all you said.
It seemed like a nice, simple way to get into it. And I was serving it just, JavaScript down the wire, then JavaScript's getting the content and putting it on the page. And I was looking at my official figures, 2.6 seconds for first render.
Okay.
And 4.7 seconds for content, which even at that point was faster than Wikipedia's actual official site.
Oh.
But, I knew it could be better than that.
Okay. What was in that first render?
First render was just like the top toolbar that said like Wikipedia and a spinner.
Okay, but from a user's point of view, they've got something, they know they're on the way. Okay.
Yeah, and then I think it was 4.7 seconds till the actual Wikipedia article came down.
So you've actually got a good couple of seconds there where you're spinning up, where your app doesn't seem to be it's idle, essentially.
Yeah, I know you're pulling your sad face, but don't worry, that's not the end of the
story. I'm pulling a mulling face. I'm mulling over.
Okay. Well, pulling your mulling face, I can tell you what I did to fix it. There's a happy...
Better than my other faces.
You okay? You're having a stroke. So yeah, I made the JavaScript async.
Okay.
And put some markup on the page for that first render.
Yes.
And I inlined the CSS for that first render.
Good.
Normal, all normal.
Well, you say normal. When I first heard that rule, it's like, oh, take some of your CSS out and put it in the head. I was like, oh, that's a big ask for developers, really.
Whoa, big what? You said big ask.
Okay.
You keep saying, it's a request, pal.
Yeah, I know. Oh my God, I hate it when people...
You've become that person. You've become that
people
person.
say that.
Yeah. Next up, you'll be asking to reason about things, or using modulo.
To reason about, I hate that one, because it is just developers not wanting to say they don't understand.
I actually do like modulo, but...
So, I do agree that it's too hard to async load CSS. This is something that we have a problem with on the platform, right?
I actually tried it. It's rubbish.
Yeah, we've got load CSS from the filament group, but it's more script than you should need. It should just be async on the link element.
It should be declarative. Yeah.
But moreover, I think what Firefox and IE do at the moment is actually really good. It's a bit of non-standard behavior, but I really like it. Put the link element on the page, in the body, just before the content that needs it. Ooh. And it will block the rendering, wait for it, it'll block the rendering of the subsequent content until that CSS loads. It's not blocking all page rendering.
Okay.
It's just the elements after don't go into the render tree.
Okay, fair enough.
We should do that. Yes. We should take that on. And we should also have async as well.
Okay, so where am I? We had a parallelizable thing, last I understood, of where you had the JavaScript that went off to get the Wikipedia page, and I was saying that's bonkers.
And so, yes, I came to the same conclusion. I thought, this needs server rendering.
Wise man.
Yep, thank you. Let's do a
cheers
to server rendering.
Well, this is the nerdiest cheer that ever went up.
So, like, looking at my calculations, once I introduced server rendering, things got slower.
Right.
That's
a bit annoying.
My content render actually sort of came down a little bit, not much, but my first render skyrocketed.
Why?
It was slower because connection goes off to my server.
Yes.
My server goes off to Wikipedia, gets the data, comes back, constructs the page, sends it on. You're looking at a white screen for longer now because you've got the bottleneck of your third-party service. But it was by taking that just the JavaScript CSS, the basic page shell, down to 0.1 seconds, like as good as instant for that first render, because it's all offline. But here's an interesting thing that happened, is my content render went, because I'm now back to doing client-side rendering, content render's gone up again. Because even though it's coming from the cache, there was two problems. There's one that it was the request to Wikipedia is a little bit delayed because it has to parse the JavaScript
to Wikipedia.
To Wikipedia.
It's delayed. I like that. It's almost like I
didn't do that on purpose.
Really?
But yeah, so I cut that delay by as soon as the request went to the service worker, had the service worker go off and fetch the stuff for Wikipedia.
Oh, okay. So how do you then? Because you still want to send your response back with the app shell stuff.
Yep. What you're talking about there is chunked encoding.
Ah, okay.
So this is the art of being able to quickly send data back, like without knowing your whole page content. So I was able to send back like the header and the first render stuff essentially. So now the browser knows about the extra CSS and JavaScript it needs. Meanwhile, or like at the first possible opportunity, my server's gone off to Wikipedia and it's gathering that. And then as it arrives, it just streams it through, and that slashed the rendering time. We got down to so we were at 1.4 seconds for first render, and when I get the official figures up, so that was it was down to 2.4 seconds for the content, and that's like a 2-second saving compared to JavaScript.
That's good.
Yeah, it's pretty huge, and
you can't really get any better than that, can you?
Oh, you can, sir, by using a little technology you might not have heard of before. Service worker.
Yay!
But yeah, as soon as you take the content, the page shell offline, that's it. You can get to that first render in like 0.1 seconds. Like the measurement came out, but it's instant, really.
Yeah.
But it took 9K of the content down the wire, and once I had that, wrote it to the page, and then wrote again once I had the rest. And it was a total hack to do that. And this is why my next wish for the internet, for the web standard, is streams. Because I want to be able to just take some content that we're downloading, pipe it into an element, and it appears as it. And I think once we have that, that kind of rendering as it goes along, I think that's when we can see client-side rendering apps become competitive with server-rendered apps.
We'll drink to that.
Cheers.
Hello, I'm Timothy Jordan, and you're watching the Google I/O 2016 livestream. The keynote is over, but there are many more developer sessions to come. Stay tuned on all 4 livestream channels throughout the next 3 days. We'll also be on the ground and behind the scenes finding the coolest and most innovative things to share with you right here on the livestream between sessions. Oh, and if you want us to track someone down with your question, use the hashtag AskDevShow.
Right, here we go. Mr. Lewis, how do you feel about roller coasters?
Oh, I like them. Roller coaster of love. Let's roll.
So, I've got a bone to pick with you.
Oh, that's unusual.
So
we normally get on just fine.
Well, because I've been watching you.
No,
and,
that's a bit weird.
I've noticed that you've been engaging in some degree of Babel activity.
Oh,
You've
thank
been
goodness
using
for
a bit
that.
of the ES6, ES7.
Not quite as terrifying as I thought it might have been this.
But you're the kind of person who says, and I've heard you say this, that you don't like writing code that isn't the code that ends up being executed in the browser.
Correct.
Like you don't like those little middle steps. You're kind of anti-transpiler.
I am sort of anti-transpile. I want to feel like the code I write is the code that runs,
Right.
and I'm happy for a little bit of wool to be pulled over my eyes, but I want to feel like I can back out of it. So I don't think that's changed. I think for me, when I look at something like Babel, or Babelify or any of that, one thing is I feel like I could switch it out for Tracer, or I could switch it out for something else.
Because it's an open standard, I guess there are independent implementations of that standard.
Exactly.
Oh,
And
okay, yeah, that's fair
so it's like, it feels like this is the JavaScript I'm going to be writing, right? So a while from now. So if it's going to get me there, then that's fine. I'm okay with that. And then the other thing is, if you look at the ES5 that it generates, it's like, it makes sense, it's fine. And I feel like when you look at some other things, whether that, I don't know, CoffeeScript or TypeScript, something like that, you can never say that, because it's like, you're always going to be transpiling across.
Yeah, I had this issue actually. I was using a project, npm installing something, using it, and there was a bug, and I thought, as a citizen of the internet, I am going to do a pull request. I'm going to try and fix that. And and when I got onto GitHub and click, CoffeeScript.
Oh,
I was like,
okay,
well,
yeah, no. Bye-bye.
Now step 1 of making this fix is learn CoffeeScript.
Yeah, and it's like, unless I really, really care about fixing the bug, it's not. For me, it's like JavaScript become, ES6, ES7, ES whatever.
Mm-hmm.
But like you say, this kind of, let's learn TypeScript or CoffeeScript or anything else. It's just like, I've got to really want to go off and do that for some reason, and I don't see what that reason is, because JavaScript for me, for everything, is fine. I actually really liked Babel, if for no other reason than its source maps were just super. So even though I wasn't really sort of aiming for that, when I did get an error, it was like, whatever .js line, whatever, and it was like, yeah, that is the correct line. And
well, so even if you're not using source maps with Babel, the output is actually pretty sensible for the most part.
Yes.
But as you say, source maps just make it completely transparent. It's almost like you're not using a transpiler at all.
Exactly. So I'm happy with the illusion of it, I think. That's probably what it comes down to. But as I say, you're right. If you look at the actual code it generates, for me, I was just like, yeah, that's not necessarily code I'd write, but that's okay. It's just about manageable and readable.
So go on then. What are your big hitters in ES6 and 7 world? What's your favies?
My faves.
Your faves.
Contentious one would be classes. I actually really like classes, because people are like, what's wrong with the prototype? You're turning your back on prototypes.
You're still using a prototype. It's just sugar.
Yes, exactly.
Yeah.
But a nice sugar at that. Very nice.
Yeah, because I don't know. I always mess it
Refined
up.
sugar.
Like if I'm doing like something.prototype equals object.create the thing I'm extending, and I keep forgetting the .prototype on the end there.
But that's one of about
It's
11
really difficult. It's really awkward compared to class thing extends thing.
And that's the one way you do it in ES6. Like with the ES5, you've got 11 billion ways of doing it, and not all of them are good necessarily, or readable, or what you want to see if you're looking at your own code 6 months from now or somebody else's code. So it kind of felt like it was more like the code I want to write, more like the code I want to read. It's where we're going. It's a feature. It's not like somebody just went off-piste and did something that they wanted to do.
And I can barely remember how to spell function now. Because you can within an object, it's just the name, brackets, off you go. There's arrow.
Fat arrow function
Fat
was
arrow.
something else I really liked.
Yep, yeah, we love a bit of fat arrow.
Yeah, because a number of times I use request animation frame, set timeout, set interval, something like that, and it's
Yep.
like, oh, all of a sudden I'm on the window scope, am I? Great, thanks for that. So bind, it's like, don't worry. I don't mind bind. It's better than var that equals this for me.
I don't.
You don't like that.
No, I don't do that equals this. But I will give it a specific, proper variable name.
Like what?
Based on the name of the class.
Like
Well, okay.
Jakey this, var Jakey this
So
equals.
if it's class vehicle,
yeah.
Inside that I will do var vehicle equals this, like lowercase vehicle equals this, and it's yeah, but it makes sense then. I don't like that because it's like, well, that's just as because this is a problem in JavaScript, I think.
Yes.
Like this, so this what like, and that's what one of the things that arrow functions solve is there tends to only be one option for what the this is, and it's the instance name.
Yeah.
Which that makes way more sense.
So it works for me. I really like that.
Destructuring I like.
Beautiful.
Especially for option objects.
Yes.
At the end of a
with defaults,
function.
right?
This is it. It becomes self-documenting. You can say, right, this is optional, but inside this object, here are the properties that I'm looking for, and here are their defaults.
Yep. But in any case, I feel like, going back to your original question, it's like the reason I would use a transpiler today is an if and only if it lets me experience the future now, get used to like the future now. I think it's where we're going.
Which you get with source maps. It feels like you can almost ignore the transpilers there.
Yeah, exactly. And as I say, the code that it generates makes sense to me. So I'm all up for that.
Yay for transpilers.
Yay.
Cheers. We need beers.
All right, well, it's getting pretty late. I think that was a pretty good take, so let's just do one more and then we'll be out for the day, okay, Rob?
All right.
3, 2.
Otherwise, as
Hey,
always,
Rob.
Oh, hey, what's up, David?
Did I tell you that I got my own YouTube show?
Oh no, dude, that's awesome. What's it gonna be about?
So, like, I was thinking there's, not a lot of screencast content out there, and so I'm gonna go and make a bunch of screencasts on Firebase.
Well, that's sort of exactly what we're doing here for Polycast, a show about.
It's nothing like that, really. Like I said, my show is gonna be on Firebase. Like building real-time cross-platform apps, without any server code.
Well, I have all this equipment, I have this crew, so if you want, I can show you the ropes
So I was thinking of
sometimes.
calling
like
it
put the
Firecasts. Like the Firebase, is for the fire.
Yeah, the Firebase, yeah.
And like the cast comes from screencast.
Screencasting.
Yeah.
Yes.
What do you think?
Six lines of code is all it takes to write your first machine learning program. My name's Josh Gordon, and today I'll walk you through writing Hello World for machine learning. In the first few episodes of this series, we'll teach you how to get started with machine learning from scratch. To do that, we'll work with two open source libraries, scikit-learn and TensorFlow. We'll see scikit in action in a minute, but first let's talk quickly about what machine learning is and why it's important. You can think of machine learning as a subfield of artificial intelligence. Early AI programs typically excelled at just one thing. For example, Deep Blue could play chess at a championship level, but that's all it could do. Today we want to write one program that can solve many problems without needing to be rewritten. AlphaGo is a great example of that. As we speak, it's competing in the World Go Championship, but similar software can also learn to play Atari games. Machine learning is what makes that possible. It's the study of algorithms that learn from examples and experience instead of relying on hard-coded rules. So that's the state of the art, but here's a much simpler example we'll start coding up today. I'll give you a problem that sounds easy, but is impossible to solve without machine learning. Can you write code to tell the difference between an apple and an orange? Imagine I asked you to write a program that takes an image file as input, does some analysis, and outputs the type of fruit. How can you solve this? You'd have to start by writing lots of manual rules. For example, you could write code to count how many orange pixels there are and compare that to the number of green ones. The ratio should give you a hint about the type of fruit. That works fine for simple images like these, but as you dive deeper into the problem, you'll find the real world is messy, and the rules you write start to break. How would you write code to handle black and white photos? Or images with no apples or oranges in them at all? In fact, for just about any rule you write, I can find an image where it won't work. You'd need to write tons of rules, and that's just to tell the difference between apples and oranges. If I gave you a new problem, you'd need to start all over again. Clearly, we need something better. To solve this, we need an algorithm that can figure out the rules for us so we don't have to write them by hand. And for that, we're going to train a classifier. For now, you can think of a classifier as a function. It takes some data as input and assigns a label to it as output. For example, I could have a picture and I want to classify it as an apple or an orange. Or I could have an email and I want to classify it as spam or not spam. The technique to write the classifier automatically is called supervised learning. It begins with examples of the problem you want to solve. To code this up, we'll work with scikit-learn. Here, I'll download and install the library. There are a couple different ways to do that, but for me, the easiest has been to use Anaconda. This makes it easy to get all the dependencies set up and works well cross-platform. With the magic of video, I'll fast forward through downloading and installing it. Once it's installed, you can test that everything is working properly by starting a Python script and importing sklearn. Assuming that worked, that's line 1 of our program down, 5 to go. To use supervised learning, we'll follow a recipe with a few standard steps. Step 1 is to collect training data. These are examples of the problem we want to solve. For our problem, we're going to write a function to classify a piece of fruit. For starters, it will take a description of the fruit as input and predict whether it's an apple or orange as output, based on features like its weight and texture. To collect our training data, imagine we head out to an orchard. We'll look at different apples and oranges and write down measurements that describe them in a table. In machine learning, these measurements are called features. To keep things simple, here we've used just 2, how much each fruit weighs in grams and its texture, which can be bumpy or smooth. A good feature makes it easy to discriminate between different types of fruit. Each row in our training data is an example. It describes one piece of fruit. The last column is called the label. It identifies what type of fruit is in each row, and there are just 2 possibilities, apples and oranges. The whole table is our training data. Think of these as all the examples we want the classifier to learn from. The more training data you have, the better a classifier you can create. Now let's write down our training data in code. We'll use 2 variables, features and labels. Features contains the first 2 columns, and labels contains the last. You can think of features as the input to the classifier, and labels as the output we want. I'm going to change the variable type of all our features to ints instead of strings. So I'll use 0 for bumpy and 1 for smooth. I'll do the same for our labels, so I'll use 0 for apple and 1 for orange. These are lines 2 and 3 in our program. Step 2 in our recipe is to use these examples to train a classifier. The type of classifier we'll start with is called a decision tree. We'll dive into the details of how these work in a future episode, but for now it's okay to think of a classifier as a box of rules. That's because there are many different types of classifier, but the input and output type is always the same. I'm going to import the tree, then on line 4 of our script we'll create the classifier. At this point, it's just an empty box of rules. It doesn't know anything about apples and oranges yet. To train it, we'll need a learning algorithm. If a classifier is a box of rules, then you can think of the learning algorithm as the procedure that creates them. It does that by finding patterns in your training data. For example, it might notice oranges tend to weigh more, so it'll create a rule saying that the heavier a fruit is, the more likely it is to be an orange. In scikit, the training algorithm is included in the classifier object, and it's called fit. You can think of fit as being a synonym for find patterns in data. We'll get into the details of how this happens under the hood in a future episode. At this point, we have a trained classifier, so let's take it for a spin and use it to classify a new fruit. The input to the classifier is the features for our new example. Let's say the fruit we want to classify is 150 grams and bumpy. The output will be a 0 if it's an apple or 1 if it's an orange. Before we hit enter and see what the classifier predicts, let's think for a sec. If you had to guess, what would you say the output should be? To figure that out, compare this fruit to our training data. It looks like it's similar to an orange because it's heavy and bumpy. That's what I'd guess anyway, and if we hit enter, it's what our classifier predicts as well. If everything worked for you, then that's it for your first machine learning program. You can create a new classifier for a new problem just by changing the training data. That makes this approach far more reusable than writing new rules for each problem. Now you might be wondering why we described our fruit using a table of features instead of using pictures of the fruit as training data. Well, you can use pictures, and we'll get to that in a future episode, but as you'll see later on, the way we did it here is more general. The neat thing is that programming with machine learning isn't hard, but to get it right, you need to understand a few important concepts. I'll start walking you through those in the next few episodes. Thanks very much for watching, and I'll see you then.
Developing a successful app isn't easy. To reach a broad audience, you'll need to consider your iOS, Android, and mobile web users. And to build for these platforms, you'll need a backend server to store data and support the apps. Of course, you want to get your users logged in, hopefully lots of users, which means your backend will have to scale. Then after you've solved your scaling problems, you'll have to find more ways to spread the word to get new users. But have you found a way to measure all this activity? And oh no, your app is crashing and causing servers to melt down, and you haven't even made a dime yet. Don't you wish this could be easier? This is why we built Firebase. It has all the tools you need to build a successful app. It helps you reach new users, keep them engaged, scale up to meet that demand, in addition to getting paid. From the beginning, with Firebase, you'll have test lab and crash reporting to prevent and diagnose errors in your app. Your backend infrastructure problems are solved with our real-time database, file storage, and hosting solutions. Acquiring new users is easy with invites, AdWords, and dynamic links. And using the authentication component, you can get those users logged in with minimal friction. Once installed, you can keep your users engaged with notifications, cloud messaging, and app indexing. Then, with Remote Config, you'll have the freedom to experiment with new features and optimize the user experience in real time. And of course, you can earn money with the same AdMob component that's been monetizing great apps for years. Last, but certainly not least, our all-new Analytics component, designed uniquely for Firebase, brings insight into how well these components are working for you and your users. With Firebase Analytics, you can measure and optimize your advertising campaigns, discover who are your most valuable users, and understand exactly how they are using your app. Now, all these components work great on their own and provide a solid infrastructure to build out your app, but they work even better when combined in creative ways. So let Firebase handle the details of your app's backend infrastructure, user engagement, and monetization, while you spend more time building the apps your users will love. To get started right now with Firebase on Android, iOS, or the web, follow these links for more information. Then, to manage and monitor your apps connected to Firebase, there's a web console to view crashes, set up experiments, track analytics, and a whole lot more. And to learn more about Firebase and all of its components, you can read the documentation right here. We can't wait to see what you build.
Let's be honest, you're an awesome engineer with an awesome app and you are using threading to the max. Sadly though, managing all those individual threads and assigning work between them is causing you to lose your hair. My name is Colt McCandless, and please, don't join the Bald Club. Instead, use the Thread Pools class, which is an ideal primitive for breaking up lots of work into little buckets. See, historically, it was commonplace that applications would use a dedicated thread model. That is, one thread that only deals with database rights, while a separate thread only handles streaming of music, and a third one only handles networking. These setups are okay because the amount of work per thread isn't that large, and it's okay to handle this work in sequential order. But there reaches a point where this model starts to fall over. Say, for example, that you've got 40 bitmaps to decode, and each decode takes like 4 milliseconds or something. Putting all of this work on a single dedicated thread is a bad idea, since it'll take 80 milliseconds total to get all that work done in a sequential fashion. On the other hand, if you created 10 threads and let each one decode 4 bitmaps, then you'd end up only taking 16 milliseconds total. But then, of course, you run into the problem of how to properly pass the work around between those threads, schedule that work, and then managing of those threads. Before you start stressing out about writing all that code, don't worry. This is exactly what Thread Pool Executor primitive is for. Basically, this class will just let you spin up a number of threads and toss blocks of work to execute on it. Thread Pool Executor handles all of the heavy lifting of spinning up the threads, load balancing work across those threads, and even killing those threads when they have been idle for a while. Basically, it handles all the heavy lifting of super parallel processing on your behalf. All you have to do is split up the work. But there's a small caveat here. How many threads should your thread pool have? I mean, technically speaking, you have the ability to create as many threads as you want, but that's not ideal. See, CPUs can only execute a certain number of threads in parallel. Once you get above that number, then the CPU has to start deciding which threads get the next free block of processor time based on how important they are. Which means that if you keep eventually adding threads, you'll hit a break-even point where your computation isn't getting any faster, even though the number of threads that you have has increased significantly. And it's also important to note that each of these threads aren't free. Each thread costs you about 64K of memory in minimum, and that adds up quickly, especially in situations where the call stacks can start growing pretty large. As such, your app needs to find a sweet spot between the number of cores and the point of diminishing return with the number of threads. Thankfully, once again, the thread pool executor class has got you covered. When creating your thread pool, you can specify the number of initial threads and the number of maximum threads. As the workload in the thread pool changes, it'll scale the number of alive threads to match. Oh, and a quick note, the value returned from get available processors may not reflect the number of physical cores in the device. Now, see, some devices have CPUs that will deactivate one or more cores depending on the system load to save battery. So if your device has 2 CPUs, but one of them is asleep, this value could return 1. And of course, thread pools won't solve all of your threading problems. As mentioned earlier, unless you're dealing with lots and lots of work packets all the time, this thing's kind of overkill. It's best to use things like handler threads or async task loaders for specific types of work blocks and only throw the massive computing problems at the thread pool. And for you power users out there, remember that render script might be a better alternative to large-scale parallel work on Android devices, but that's a whole separate set of videos that we haven't gotten into yet. And don't forget that systrace is an amazingly powerful tool that lets you visualize how work is flowing through the threads in your application. It's a great way to validate that things are working as intended and also see all the other crazy threads that are being worked on by other parts of your app. And that's the trick with performance, isn't it? I mean, you can make assumptions, but things don't always work the way you think, which is why you need to check out the rest of the Android Performance Patterns videos. And don't forget to join our Google Plus community to ask a lot of hard threading questions as well. So keep calm, profile your code, and always remember, perf matters.
Hey folks, welcome to Totally Tooling Tips Season 3.
Come check us out. We're going to be talking about progressive web apps, some of the tooling around them.
On first visit, we've got a relatively fast time to first meaningful paint.
Module bundling, accessibility.
Do you know what the top 4 things to look at when it comes to web accessibility are?
No, I can only think of 2. I only think of audio and then visual.
So there's visual, hearing, mobility, and cognition.
The first episode will be out on April the 27th. So subscribe to the YouTube channel, check out Season 1 and 2 before Season 3 starts, which will be happening soon.
We promise that Season 3 is going to be equally as mediocre as Seasons 1 and 2.
Welcome to the Googleplex. This is an incredible place with lots of great stuff being worked on every single day. Before I worked here, I always wondered what it would be like to come to the Googleplex, meet up with a Googler, and have coffee with them, and just chat about what they do, how they do it, and why they do it. And today we're going to do exactly that. Welcome to this episode of Coffee with a Googler, and if you, like me, love games and love 3D games and all that kind of stuff, then this show should be a treat for you. Because today I'm chatting with Shannon Woods, who's a technical program manager, and she works on our rendering teams at Google, and she's got lots of great stuff to talk about in the 3D space. So welcome, Shannon. How are you?
I'm doing all right. How are you?
Really good. I have to say I'm really envious of your job, but could you tell us what you do?
So I work with a couple of rendering teams here at Google, both Android and Chrome. And we sort of plumb code from user space down to your GPU.
Wow. Can you translate that?
Basically, our job is to get a bunch of triangles from applications down to the GPU as fast as possible.
Cool. And all graphics are ultimately made up of triangles, right?
Basically.
Now, recently you announced Vulkan. Right, and this is this like new and improved 3D rendering API. Could you tell us a bit about it?
Historically, Android and all mobile phones really have used OpenGL ES to communicate to the GPU within the phone to tell it how to draw scenes. But unfortunately, over time, the API has become less and less of a good match for what the hardware is actually doing beneath. So what would happen is you would use this API to communicate a lot of the details about your scene, and the GPU has to reorganize all of that so that it can consume it efficiently and draw it on the screen. So what Vulkan is it's another API from the same open standards group that makes OpenGL. And it's designed to be a lot closer to what the hardware actually does beneath the covers.
Okay.
So if you provide the data via Vulkan, it should be able to draw a lot quicker. Sort of the flip side of that is that, you know, it gives you all of this control, but it means that you have to be pretty good at, making sure that your code is doing exactly what you wanted it to do.
Vulkan and OpenGL are both from the same standards body, right?
Yes.
So that's Kronos?
Yes, Kronos.
Kronos, sorry. So you work with the standards body at Kronos?
I do. I get to travel all around the world and see beautiful conference rooms. But it's actually really interesting getting to see how the API is made from the ground up.
Cool.
Android is going to support both OpenGL ES and Vulkan, so developers can choose which API is right for what they're doing. Like if they need to render a FPS game or first-person shooting game that has to run really fast at a high frame rate, then they're going to probably want to choose Vulkan so that they can closely control exactly what's being drawn and when.
Cool.
But if they just want to get a couple of shapes on screen, then OpenGL ES is probably still the right choice for them.
Cool. So it's just really nice to have both.
Yes.
Cool. So, and from my understanding, what you're saying with Vulkan, like just being able to get down to the chipset level effectively allows you to squeeze a lot more performance out of the machine.
Yeah, it does. And one of the other things that it does is that it allows for greater parallelization.
Okay.
There's a lot of work in OpenGL ES that it's blocking work. You make a call into OpenGL ES, into the driver code, and it has to stop and perform the task that you asked it to do, and doesn't return control to the application until it finishes that task. And what this means is that if you have multiple threads, only one of them can really be talking to the driver doing these things at the same time. Vulkan is designed more for multi-threaded applications, so you can have multiple threads doing things like constructing buffers full of commands at the same time.
You're getting onto like programming and skills, and like from a skills perspective, and is the things that developers will need to learn that they don't do already, for example, if they're doing 3D games in OpenGL ES?
So the skill sets are going to be largely the same. As a Vulkan developer, you're going to have probably a tighter handle on things like, synchronization, careful tracking of memory allocation, because a lot less of that is going to be done for you by the driver. The upside of this is that the driver won't be doing these things when you don't expect it to. But you're going to have to really hone your skills at things like multi-threaded synchronization, memory allocation. Make sure that you are closely keeping an eye on what your code is doing and what it's asking the GPU to do, because the driver is going to do a whole lot less of that for you. It's not going to clean up after you. It's not going to check that you are making legal calls. So you're basically going to have to be a bit of a ninja.
It's almost like driving stick versus driving manual, right?
That's probably a really good analogy.
So people can learn about Vulkan on the Kronos site?
Yes.
You mentioned. So that's Kronos.org?
Kronos.org, www.kronos.org. And Kronos is spelled Khronos. And they have a Vulkan landing page where you can find the latest news about Vulkan and also see some of the presentations that were given, for example, at SIGGRAPH this year and at GDC about the shape of the API.
Okay. Now you were at SIGGRAPH, right?
I was at SIGGRAPH.
How did it go?
It was a lot of fun, actually. We did some demos, showed some spinning teapots.
Teapots?
So there's a little bit of history behind the teapot.
Okay.
The teapot is canonically called the Utah teapot, and it's because way back in the history of computer graphics, it's one of the first models that was digitized and shared. And interestingly, so the teapot, everybody knows that they've seen here and there over the years, it looks short and squat.
Okay.
But the reason for that is actually that on the original display system, the pixels were not square. So they had a different
ones from
TVs. The aspect ratio is a little bit different. So in real life, the teapot's actually a little taller.
Now you're saying that the pixels are like elongated, they were rectangular pixels, because this was done so long ago?
Oh yeah, it was, I guess it was the 70s.
Wow. So the first 3D model that was formed in cyberspace, or whatever you want to call it, back in the 70s, and you're still using the same model today to... I think Pixar also use the teapot, don't they?
Yeah, actually the teapot appears in every Pixar film. One of the ones I know off the top of my head is they use it in the Tea Party scene in Toy Story.
Okay, naturally that's where a teapot would fit.
Yeah, but there's one in every Pixar film.
Thank you so much, Shannon.
Thank you.
And thanks everybody for watching this episode of Coffee with a Googler. I don't know about you, but I've learned a lot about the kind of things that can be done with 3D graphics. And I'm really, really excited about Vulkan coming to Android. If you've got any questions for me, or if you've got any questions for Shannon, just please leave them in the comments below. We'll also link to the websites in the description of this video so that you can follow those links. And if you want to learn anything else about great stuff that Google has to offer for Android developers, Chrome developers, and everybody else, please subscribe to the Google Developers channel. Thank you.
With Android Lollipop, material design changed the way that apps look and feel to create more magic moments. But devices running earlier versions of Android don't have all of the same options. I'm Joanna Smith, and one of the coolest things that material design gave us were toolbars, which are now even more magical because they're backwards compatible as well. A toolbar is a view that is richer and more flexible than the traditional action bar. In fact, toolbars are part of your view hierarchy, so they can be animated or even react to scroll events. Because it's a view, you can use the toolbar as a standalone element anywhere in your app, providing the user with options and controls that don't need to span the entire layout width at the very top of the screen. You can even have multiple toolbars if the structure depends on the content of your layout, or if you're providing the user with many differing controls. To populate your toolbar with actions and options, you can inflate a menu onto the toolbar to display those actions to the user. You can also create your own controls, like adding a navigation button to go up to the parent activity. While toolbars can be used in any part of your layout, you can also choose to use the toolbar instead of the action bar whenever you simply want more control over the appearance and functionality of that action bar. So to use a toolbar in the place of the standard action bar, you first need to disable the action bar. The easiest way to do this is to have your theme extend from theme appcompat no action bar, or its light variant. Then create your toolbar the way you would create any other layout in your app, and call setActionBar to designate it as the action bar in the activity or fragment. By calling this method, the system will add the standard action bar options for you, so you don't need to inflate a menu. Now, you may be convinced of how awesome toolbars are, but how can you use them in versions of your app targeting older SDKs? Well, toolbars were added to the support library for appcompat v21, so now it's as easy as calling setSupportActionBar instead of setActionBar to replace action bars on older devices. So check the documentation for all of the support options available so that you can bring more magic moments to your users. And for more tips on making sure that your app is at its best, check out the rest of our Android Development Patterns content or consider joining our G+ community. But most importantly, just continue to build better apps.
As a lot of developers know, there's more to having an app succeed than just building a great app. You want your app to be dynamic and responsive by delivering fresh content to users and quickly reacting to their changing needs. You want to test out major decisions to make sure you're doing the right thing before you push them to your entire audience. And ideally, you want to provide a tailored experience for each user, so your VIPs feel like, well, VIPs. But let's be honest, that can be a lot of work. And if you're a developer without a ton of resources, that's time you'd rather spend on other things, like building your app. That's where Firebase Remote Config comes in. Firebase Remote Config is a simple key value store that lives in the cloud. But don't let that simplicity fool you. Because it lives in the cloud, it means you're able to deploy changes that your app can read within a matter of minutes. For instance, say you've just pushed your app out to the world and you suddenly discover that your Swedish text contains some offensive language. How are you supposed to know? You don't speak Swedish. I don't blame you. But fixing that text the old-fashioned way would mean creating a new build and going through the entire publishing process again. That's something that could take days, which is an awfully long time to have 9.2 million people cursing your name. But if your app uses Firebase Remote Config, you could change that text in the cloud through the Firebase console. Kind of like this. The next time your users fire up their app, Remote Config will grab the latest values, update your app's text, and just like that, you've averted a major international crisis. Or, let's say you've got a puzzle game and you're hearing complaints from your players that level 5 is too hard. If you've configured your app using Remote Config, you could tweak those settings to give your players a few more turns and push out that change to the world. But hang on, are you sure that's the right thing to do? What if the silent majority of your users actually enjoy the challenge of a more difficult level? And by making it easier, you're going to turn away your most hardcore and potentially highest paying customers. How could you test whether or not this change is a good one? Sounds like you need an A/B test. That's where Remote Config's audience segmentation feature comes in. This allows you to deliver different configurations to different groups of users simultaneously. So you can try out your new level settings with half your users while keeping the old settings with the other half. But audience segmentation isn't just great for A/B testing. Maybe you've got a feature change that could have a major impact on your in-app economy. Or maybe you just want to double check that some new networking code isn't going to set your servers on fire. You can use Firebase Remote Config to gradually roll out these changes, trying them first with a small percentage of your users before pushing them out to your entire audience. Remote Config can also deliver different configuration sets to your users based on all sorts of different factors, from device type or locale to any audience segment you've defined in Firebase Analytics. So you can send out one welcome message to your New Zealand customers and another to your Australian ones, or only show your Review This App button to people who use your app every day, or you can change your home screen experience for your customers who have spent large amounts of money on in-app purchases, so they feel special. Remote Config is backed by a client library on iOS and Android that handles important tasks like caching, dealing with flaky connections, and keeping network requests lightweight, which is always a good thing. To give Remote Config a try, check out our documentation here. We can't wait to see what you build.
Here's an old school tip for you. If you can animate something based on user input, you probably don't want to have it update immediately to track the input event, because it can often feel very jittery. Instead, what you should do is use the oldest easing equation in the book, which looks like this: value plus equals target minus value all over strength. Here we're changing the value based on how close it is to the target. The closer it is, the less it gets moved, making it look way nicer. So there you have it, a little tip to make your input-based animations a teeny bit smoother.
Another day,
Yes.
another journey.
I know indeed, right? How's your aim?
Well, not great in the middle of the night, but I sometimes just sit down.
No, actually I meant your snooker, your pool, or in this case, your billiards.
Ooh, we're going to a billiard hall.
That we are, sir.
So, I made a thing.
That's unusual for you.
I know.
You're like
quite proud
2
of
in as
myself.
many months or something.
Yeah, it's a new thing. It's
What is
really,
it?
it's a little
Is it a web app?
Yes, it is a web app.
Is it a website? What's the difference, Jake?
Shut up. We're not doing web apps versus websites. I would say it's an app.
Would you?
I
An app with content?
Flip the coin. It's an app. No, it's not. It's a site. It's a Wikipedia article viewer.
Okay.
Which I realise is what Wikipedia does already.
Yes.
But this was more of an exercise in looking at like performance, like page load time performance.
But you think you can beat Wikipedia at a server-side render, do you?
I did.
You did?
Well, so this is the thing. I was hosting on GitHub, so I was doing a client-side render. I know.
After all you said.
It seemed like a nice, simple way to get into it, and I was serving it just JavaScript down the wire, then JavaScript's getting the content and putting it on the page, and I was looking at my official figures, 2.6 seconds for first render,
okay,
and 4.7 seconds for content, which even at that point was faster than Wikipedia's actual official site.
Oh.
But I knew it could be better than that.
Okay. What was in that first render?
First render was just like the top toolbar that said like Wikipedia and a spinner.
Okay, but from a user's point of view, they've got something, they know they're on the way. Okay.
Yeah, and then I think it was 4.7 seconds till the actual Wikipedia article came down.
So you've actually got a good couple of seconds there where you're spinning up, where your app doesn't seem to be it's idle, essentially.
Yeah, I know you're pulling your sad face, but don't worry, that's not the end
I'm pulling
of the
a mulling
story.
face. I'm mulling over.
Okay, well, pulling your mulling face, I can tell you what I did to fix it. There's a happy...
Better than my other faces.
You okay? You're having a stroke. So yeah, I made the JavaScript async.
Okay.
And put some markup on the page for that first render.
Yes.
And I inlined the CSS for that first render.
Good. Normal, all normal.
Well, you say normal. When I first heard that rule, it's like, oh, take some of your CSS out and put it in the head. I was like, oh, that's a big ask for developers, really.
Whoa, big what? You said big ask.
Yeah, okay.
You keep saying, it's a request, pal.
Yeah, I know. Oh my God, I hate it when people...
You've become that person. You've become
when
that
people
person.
say that.
Yeah. Next up, you'll be asking to reason about things, or using modulo.
To reason about, I hate that one, because it is just developers not wanting to say they don't understand.
I actually do like modulo, but...
So, I do agree that it's too hard to async load CSS. This is something that we have a problem with on the platform,
yes.
right?
I actually tried it. It's rubbish.
Yeah, we've got load CSS from the filament group, but it's more script than you should need. It should just be async on the link element.
It should be declarative. Yeah.
But moreover, I think what Firefox and IE do at the moment is actually really good. It's a bit of non-standard behavior, but I really like it. Put the link element on the page in the body just before the content that needs it, and it will block the rendering, wait for it, it'll block the rendering of the subsequent content until that CSS loads. It's not blocking all page rendering.
Okay.
It's just the elements after don't go into the render tree.
Okay, fair enough.
We should do that.
Yes.
We should take that on. And we should also have async as well.
Okay, so
here where am I?
We had a parallelizable thing last I understood of where you had the JavaScript that went off to get the Wikipedia page, and I'm saying that's bonkers.
And so, yes, I came to the same conclusion. I thought, this needs server rendering.
Wise man.
Yep, thank you. Let's do a proper cheers.
Cheers to server rendering. Well, this is the nerdiest cheer that ever went up.
So, like, looking at my calculations, once I introduced server rendering, things got slower.
Right.
That's
a bit annoying.
My content render actually sort of came down a little bit, not much, but my first render skyrocketed.
Why?
It was slower because connection goes off to my server.
Yes.
My server goes off to Wikipedia, gets the data, comes back, constructs the page, sends it on. You're looking at a white screen for longer now because you've got the bottleneck of your third-party service. But it was by taking that just the JavaScript CSS, the basic page shell, down to 0.1 seconds, like as good as instant for that first render because it's all offline. But here's an interesting thing that happened is my content render went, because I'm now back to doing client-side rendering.
Yeah.
Content render's gone up again. Because even though it's coming from the cache, there was two problems. There's one that it was the request to Wikipedia is a little bit delayed because it has to parse the JavaScript
to Wikipedia.
To Wikipedia.
It's delayed. I like that. It's almost like I
didn't do that on purpose.
Really?
But yeah, so I cut that delay by as soon as the request went to the service worker, had the service worker go off and fetch the stuff for Wikipedia.
Oh, okay. So how do you then? Because you still want to send your response back with the app shell stuff.
Yep. What you're talking about there is chunked encoding.
Ah, okay.
So this is the art of being able to quickly send data back, like without knowing your whole page content. So I was able to send back like the header and the first render stuff essentially. So now the browser knows about the extra CSS and JavaScript it needs. Meanwhile, or like at the first possible opportunity, my server's gone off to Wikipedia and it's gathering that. And then as it arrives, it just streams it through, and that slashed the rendering time. We got down to so we were at 1.4 seconds for first render, and when I get the official figures up, so that was it down to 2.4 seconds for the content, and that's like a 2-second saving compared to JavaScript.
That's good.
3G. Yeah, it's pretty huge. And
you can't really get any better than that, can you?
Oh, you can, sir, by using a little technology you might not have heard of before. Service worker!
Yay!
But yeah, as soon as you take the content, the page shell offline, that's it. You can get to that first render in like 0.1 seconds. Like the measurement came out, but it's instant, really.
Yeah.
But it took 9K of the content down the wire, and once I had that, wrote it to the page, and then wrote again once I had the rest. And it was a total hack to do that. And this is why my next wish for the internet, for the web standard, is streams. Because I want to be able to just take some content that we're downloading, pipe it into an element, and it appears as it. And I think once we have that kind of rendering as it goes along, I think that's when we can see client-side rendering apps become competitive with server rendering
apps. We'll drink to that.
Cheers.
Hello, I'm Timothy Jordan, and you're watching the Google I/O 2016 livestream. The keynote is over, but there are many more developer sessions to come. Stay tuned on all 4 live stream channels throughout the next 3 days. We'll also be on the ground and behind the scenes finding the coolest and most innovative things to share with you right here on the live stream between sessions. Oh, and if you want us to track someone down with your question, use the hashtag AskDevShow.
Right, here we go. Mr. Lewis, how do you feel about roller coasters?
Oh, I like them. Roller coaster of love. Let's roll.
So, I've got a bone to pick with you.
Oh, that's unusual.
So
we normally get on just fine.
Well, because I've been watching you.
No,
and,
that's a bit weird.
I've noticed that you've been engaging in some degree of Babel activity.
Oh,
you've
thank
been
goodness
using
for
a bit
that.
of the ES6, ES7.
Not quite as terrifying as I thought it might have been this.
But you're the kind of person who says, and I've heard you say this, that you don't like writing code that isn't the code that ends up being executed in the browser.
Correct.
Like you don't like those little middle steps. You're kind of anti-transpiler.
I am sort of anti-transpile. I want to feel like the code I write is the code that runs,
Right.
and I'm happy for a little bit of wool to be pulled over my eyes, but I want to feel like I can back out of it. So I don't think that's changed. I think for me, when I look at something like Babel, or Babelify or any of that, one thing is I feel like I could switch it out for Tracer, or I could switch it out for something else.
Because it's an open standard. I guess there are independent implementations of that standard.
Exactly.
Oh,
And
okay, yeah, that's fair
so it's like, it feels like this is the JavaScript I'm going to be writing, right? So a while from now. So if it's going to get me there, then that's fine. I'm okay with that. And then the other thing is, if you look at the ES5 that it generates, it's like, it makes sense, it's fine. And I feel like when you look at some other things, whether that, I don't know, CoffeeScript or TypeScript, something like that, you can never say that, because it's like, you're always going to be transpiling across.
Yeah, I had this issue actually. I was using a project, npm installing something, using it, and there was a bug, and I thought, as a citizen of the internet, I am going to do a pull request. I'm going to try and fix that. And and when I got onto GitHub and click, CoffeeScript.
Oh,
I was like,
okay,
well,
yeah, no. Bye-bye.
Now step 1 of making this fix is learn CoffeeScript.
Yeah, and it's like, unless I really, really care about fixing the bug, it's not. For me, it's like JavaScript becomes, ES6, ES7, ES whatever.
Mm-hmm.
But like you say, this kind of, let's learn TypeScript or CoffeeScript or anything else. It's just like, I've got to really want to go off and do that for some reason, and I don't see what that reason is, because JavaScript for me, for everything, is fine. I actually really liked Babel, if for no other reason than its source maps were just super. So even though I wasn't really sort of aiming for that, when I did get an error, it was like, whatever .js line, whatever, and it was like, yeah, that is the correct line. And
well, so even if you're not using source maps with Babel, the output is actually pretty sensible for the most part.
Yes.
But as you say, source maps just make it completely transparent. It's almost like you're not using a transpiler at all.
Exactly. So I'm happy with the illusion of it, I think. That's probably what it comes down to. But as I say, you're right. If you look at the actual code it generates, for me, I was just like, yeah, that's not necessarily code I'd write, but that's okay. It's just about manageable and readable.
So go on then. What are your big hitters in ES6 and 7 world? What's your favies?
My faves.
Your faves.
Contentious one would be classes. I actually really like classes, because people are like, what's wrong with the prototype? You're turning your back on prototypes.
You're still using a prototype. It's just sugar.
Yes, exactly.
Yeah.
But a nice sugar at that. Very nice.
Yeah, because I don't know. I always
refined
mess it up.
sugar.
Like if I'm doing like something.prototype equals object.create the thing I'm extending, and I keep forgetting the .prototype on the end there.
But that's one of about
It's
11
really difficult. It's really awkward compared to class thing extend thing.
And that's the one way you do it in ES6. Like with the ES5, you've got 11 billion ways of doing it, and not all of them are good necessarily, or readable, or what you want to see if you're looking at your own code 6 months from now or somebody else's code. So it kind of felt like it was more like the code I want to write, more like the code I want to read. It's where we're going. It's a feature. It's not like somebody just went off piste and did something that they wanted to do.
And I can barely remember how to spell function now.
Yeah,
because you can within an object, it's just the name, brackets, off you go.
Yes.
There's arrow.
Fat arrow function was something else I really liked.
Yep, we love a bit of fat arrow.
Yeah, because a number of times I use request animation frame, set timeout, set interval, something like that, and it's
Yep.
like, oh, all of a sudden I'm on the Windows scope, am I? Great, thanks for that. So bind, it's like, don't worry. I don't mind bind. It's better than var that equals this for me.
I don't.
You don't like that.
No, I don't do that equals this. But I will give it a specific, proper variable name.
Like what?
Based on the name of the class.
Like
well, okay.
Jakey this, var Jakey this equals...
So if it's class vehicle,
yeah.
Inside that I will do var vehicle equals this, like lowercase vehicle equals this. And it's, yeah, but it makes sense then. I don't like that, because it's like, well, that's just as... Because this is a problem in JavaScript, I think.
Yes.
Like this, so this, what? Like, yeah. And that's what one of the things that arrow functions solve is there tends to only be one option for what the this is, and it's the instance name.
Yeah.
Which, that makes way more sense.
So it works for me. I really like that.
Destructuring I like.
Beautiful. Beautiful.
Especially for option objects.
Yes.
At the end of a
With defaults,
function.
right?
This is it. It becomes self-documenting. You can say, right, this is optional, but inside this object, here are the properties that I'm looking for, and here are their defaults.
Yep. But in any case, I feel like, going back to your original question, it's like the reason I would use a transpiler today is an if and only if it lets me experience the future now, get used to like the future now. I think it's where we're going.
Which you get with source maps. It feels like you can almost ignore the transpilers there.
Yeah, exactly. And as I say, the code that it generates makes sense to me. So I'm all up for that.
Yay for transpilers.
Yay.
Cheers. We need beers.
All right, well, it's getting pretty late. I think that was a pretty good take, so let's just do one more, and then we'll be out for the day. Okay, Rob?
All right.
3, 2.
Otherwise, as
Hey,
always,
Rob.
Oh, hey, what's up, David?
Did I tell you that I got my own YouTube show?
Oh, no, dude, that's awesome. What's it gonna be about?
So, like, I was thinking there's, not a lot of screencast content out there, and so I'm gonna go and make a bunch of screencasts on Firebase.
Well, that's sort of exactly what we're doing here for Polycast, a show about...
It's nothing like that, really. Like I said, my show is gonna be on Firebase, like building real-time cross-platform apps, without any server code.
Well, I have all this equipment, I have this crew, so if you want, I can show you the ropes
So I was
sometimes.
thinking of calling
like
it Firecasts, like the Firebase, it's for the fire.
Yeah, the Firebase, yeah.
And, like the cast comes from screencast.
Screencasting.
Yeah.
Yes.
What do you think?
Six lines of code is all it takes to write your first machine learning program. My name's Josh Gordon, and today I'll walk you through writing Hello World for machine learning. In the first few episodes of this series, we'll teach you how to get started with machine learning from scratch. To do that, we'll work with two open source libraries, scikit-learn and TensorFlow. We'll see scikit in action in a minute, but first let's talk quickly about what machine learning is and why it's important. You can think of machine learning as a subfield of artificial intelligence. Early AI programs typically excelled at just one thing. For example, Deep Blue could play chess at a championship level, but that's all it could do. Today we want to write one program that can solve many problems without needing to be rewritten. AlphaGo is a great example of that. As we speak, it's competing in the World Go Championship, but similar software can also learn to play Atari games. Machine learning is what makes that possible. It's the study of algorithms that learn from examples and experience instead of relying on hard-coded rules. So that's the state of the art, but here's a much simpler example we'll start coding up today. I'll give you a problem that sounds easy, but is impossible to solve without machine learning. Can you write code to tell the difference between an apple and an orange? Imagine I asked you to write a program that takes an image file as input, does some analysis, and outputs the type of fruit. How can you solve this? You'd have to start by writing lots of manual rules. For example, you could write code to count how many orange pixels there are and compare that to the number of green ones. The ratio should give you a hint about the type of fruit. That works fine for simple images like these, but as you dive deeper into the problem, you'll find the real world is messy, and the rules you write start to break. How would you write code to handle black and white photos? Or images with no apples or oranges in them at all? In fact, for just about any rule you write, I can find an image where it won't work. You'd need to write tons of rules, and that's just to tell the difference between apples and oranges. If I gave you a new problem, you'd need to start all over again. Clearly, we need something better. To solve this, we need an algorithm that can figure out the rules for us so we don't have to write them by hand. And for that, we're going to train a classifier. For now, you can think of a classifier as a function. It takes some data as input and assigns a label to it as output. For example, I could have a picture and I want to classify it as an apple or an orange. Or I could have an email and I want to classify it as spam or not spam. The technique to write the classifier automatically is called supervised learning. It begins with examples of the problem you want to solve. To code this up, we'll work with scikit-learn. Here, I'll download and install the library. There are a couple different ways to do that, but for me, the easiest has been to use Anaconda. This makes it easy to get all the dependencies set up and works well cross-platform. With the magic of video, I'll fast forward through downloading and installing it. Once it's installed, you can test that everything is working properly by starting a Python script and importing sklearn. Assuming that worked, that's line 1 of our program down, 5 to go. To use supervised learning, we'll follow a recipe with a few standard steps. Step 1 is to collect training data. These are examples of the problem we want to solve. For our problem, we're going to write a function to classify a piece of fruit. For starters, it will take a description of the fruit as input and predict whether it's an apple or orange as output, based on features like its weight and texture. To collect our training data, imagine we head out to an orchard. We'll look at different apples and oranges and write down measurements that describe them in a table. In machine learning, these measurements are called features. To keep things simple, here we've used just 2, how much each fruit weighs in grams and its texture, which can be bumpy or smooth. A good feature makes it easy to discriminate between different types of fruit. Each row in our training data is an example. It describes one piece of fruit. The last column is called the label. It identifies what type of fruit is in each row, and there are just 2 possibilities, apples and oranges. The whole table is our training data. Think of these as all the examples we want the classifier to learn from. The more training data you have, the better a classifier you can create. Now let's write down our training data in code. We'll use 2 variables, features and labels. Features contains the first 2 columns, and labels contains the last. You can think of features as the input to the classifier and labels as the output we want. I'm going to change the variable type of all our features to ints instead of strings. So I'll use 0 for bumpy and 1 for smooth. I'll do the same for our labels, so I'll use 0 for apple and 1 for orange. These are lines 2 and 3 in our program. Step 2 in our recipe is to use these examples to train a classifier. The type of classifier we'll start with is called a decision tree. We'll dive into the details of how these work in a future episode, but for now it's okay to think of a classifier as a box of rules. That's because there are many different types of classifier, but the input and output type is always the same. I'm going to import the tree, then on line 4 of our script we'll create the classifier. At this point it's just an empty box of rules. It doesn't know anything about apples and oranges yet. To train it, we'll need a learning algorithm. If a classifier is a box of rules, then you can think of the learning algorithm as the procedure that creates them. It does that by finding patterns in your training data. For example, it might notice oranges tend to weigh more, so it'll create a rule saying that the heavier a fruit is, the more likely it is to be an orange. In scikit, the training algorithm is included in the classifier object, and it's called fit. You can think of fit as being a synonym for find patterns in data. We'll get into the details of how this happens under the hood in a future episode. At this point, we have a trained classifier, so let's take it for a spin and use it to classify a new fruit. The input to the classifier is the features for our new example. Let's say the fruit we want to classify is 150 grams and bumpy. The output will be a 0 if it's an apple or 1 if it's an orange. Before we hit enter and see what the classifier predicts, let's think for a sec. If you had to guess, what would you say the output should be? To figure that out, compare this fruit to our training data. It looks like it's similar to an orange because it's heavy and bumpy. That's what I'd guess anyway, and if we hit enter, it's what our classifier predicts as well. If everything worked for you, then that's it for your first machine learning program. You can create a new classifier for a new problem just by changing the training data. That makes this approach far more reusable than writing new rules for each problem. Now you might be wondering why we described our fruit using a table of features instead of using pictures of the fruit as training data. Well, you can use pictures, and we'll get to that in a future episode, but as you'll see later on, the way we did it here is more general. The neat thing is that programming with machine learning isn't hard, but to get it right, you need to understand a few important concepts. I'll start walking you through those in the next few episodes. Thanks very much for watching, and I'll see you then.
Developing a successful app isn't easy. To reach a broad audience, you'll need to consider your iOS, Android, and mobile web users. And to build for these platforms, you'll need a backend server to store data and support the apps. Of course, you want to get your users logged in, hopefully lots of users, which means your backend will have to scale. Then after you've solved your scaling problems, you'll have to find more ways to spread the word to get new users. But have you found a way to measure all this activity? And oh no, your app is crashing and causing servers to melt down, and you haven't even made a dime yet. Don't you wish this could be easier? This is why we built Firebase. It has all the tools you need to build a successful app. It helps you reach new users, keep them engaged, scale up to meet that demand, in addition to getting paid. From the beginning, with Firebase, you'll have test lab and crash reporting to prevent and diagnose errors in your app. Your backend infrastructure problems are solved with our real-time database, file storage, and hosting solutions. Acquiring new users is easy with invites, AdWords, and dynamic links. And using the authentication component, you can get those users logged in with minimal friction. Once installed, you can keep your users engaged with notifications, cloud messaging, and app indexing. Then, with Remote Config, you'll have the freedom to experiment with new features and optimize the user experience in real time. And of course, you can earn money with the same AdMob component that's been monetizing great apps for years. Last, but certainly not least, our all-new Analytics component, designed uniquely for Firebase, brings insight into how well these components are working for you and your users. With Firebase Analytics, you can measure and optimize your advertising campaigns, discover who are your most valuable users, and understand exactly how they are using your app. Now, all these components work great on their own and provide a solid infrastructure to build out your app, but they work even better when combined in creative ways. So let Firebase handle the details of your app's backend infrastructure, user engagement, and monetization, while you spend more time building the apps your users will love. To get started right now with Firebase on Android, iOS, or the web, follow these links for more information. Then, to manage and monitor your apps connected to Firebase, there's a web console to view crashes, set up experiments, track analytics, and a whole lot more. And to learn more about Firebase and all of its components, you can read the documentation right here. We can't wait to see what you build.
Let's be honest, you're an awesome engineer with an awesome app and you are using threading to the max. Sadly though, managing all those individual threads and assigning work between them is causing you to lose your hair. My name is Colt McCandless, and please, don't join the Bald Club. Instead, use the thread pools class, which is an ideal primitive for breaking up lots of work into little buckets. See, historically, it was commonplace that applications would use a dedicated thread model. That is, one thread that only deals with database writes, while a separate thread only handles streaming of music, and a third one only handles networking. These setups are okay because the amount of work per thread isn't that large, and it's okay to handle this work in sequential order. But there reaches a point where this model starts to fall over. Say, for example, that you've got 40 bitmaps to decode, and each decode takes like 4 milliseconds or something. Putting all of this work on a single dedicated thread is a bad idea, since it'll take 80 milliseconds total to get all that work done in a sequential fashion. On the other hand, if you created 10 threads and let each one decode 4 bitmaps, then you'd end up only taking 16 milliseconds total. But then, of course, you run into the problem of how to properly pass the work around between those threads, schedule that work, and then managing of those threads. Before you start stressing out about writing all that code, don't worry. This is exactly what Thread Pool Executor primitive is for. Basically, this class will just let you spin up a number of threads and toss blocks of work to execute on it. Thread Pool Executor handles all of the heavy lifting of spinning up the threads, load balancing work across those threads, and even killing those threads when they have been idle for a while. Basically, it handles all the heavy lifting of super parallel processing on your behalf. All you have to do is split up the work. But there's a small caveat here. How many threads should your thread pool have? I mean, technically speaking, you have the ability to create as many threads as you want, but that's not ideal. See, CPUs can only execute a certain number of threads in parallel. Once you get above that number, then the CPU has to start deciding which threads get the next free block of processor time based on how important they are. Which means that if you keep eventually adding threads, you'll hit a break-even point where your computation isn't getting any faster, even though the number of threads that you have has increased significantly. And it's also important to note that each of these threads aren't free. Each thread costs you about 64K of memory in minimum, and that adds up quickly, especially in situations where the call stacks can start growing pretty large. As such, your app needs to find a sweet spot between the number of cores and the point of diminishing return with the number of threads. Thankfully, once again, the thread pool executor class has got you covered. When creating your thread pool, you can specify the number of initial threads and the number of maximum threads. As the workload in the thread pool changes, it'll scale the number of alive threads to match. Oh, and a quick note, the value returned from get available processors may not reflect the number of physical cores in the device. Now, see, some devices have CPUs that will deactivate one or more cores depending on the system load to save battery. So if your device has 2 CPUs but one of them is asleep, this value could return 1. And of course, thread pools won't solve all of your threading problems. As mentioned earlier, unless you're dealing with lots and lots of work packets all the time, this thing's kind of overkill. It's best to use things like handler threads or async task loaders for specific types of work blocks and only throw the massive computing problems at the thread pool. And for you power users out there, remember that render script might be a better alternative to large-scale parallel work on Android devices, but that's a whole separate set of videos that we haven't gotten into yet. And don't forget that systrace is an amazingly powerful tool that lets you visualize how work is flowing through the threads in your application. It's a great way to validate that things are working as intended and also see all the other crazy threads that are being worked on by other parts of your app. And that's the trick with performance, isn't it? I mean, you can make assumptions, but things don't always work the way you think, which is why you need to check out the rest of the Android Performance Patterns videos. And don't forget to join our Google Plus community to ask a lot of hard threading questions as well. So keep calm, profile your code, and always remember, perf matters.
Hey folks, welcome to Totally Tooling Tips Season 3.
Come check us out. We're going to be talking about progressive web apps, some of the tooling around them.
On first visit, we've got a relatively fast time to first meaningful paint. Module bundling, accessibility. Do you know what the top 4 things to look at when it comes to web accessibility are?
No, I can only think of 2. I only think of audio and then visual.
So there's visual, hearing, mobility, and cognition.
The first episode will be out on April the 27th. So subscribe to the YouTube channel, check out Season 1 and 2 before Season 3 starts, which will be happening soon.
We promise that Season 3 is going to be equally as mediocre as Seasons 1 and 2.
Welcome to the Googleplex. This is an incredible place with lots of great stuff being worked on every single day. Before I worked here, I always wondered what it would be like to come to the Googleplex, meet up with a Googler, and have coffee with them, and just chat about what they do, how they do it, and why they do it. And today we're going to do exactly that.
Welcome to this episode of Coffee with a Googler, and if you, like me, love games and love 3D games and all that kind of stuff, then this show should be a treat for you. Because today I'm chatting with Shannon Woods, who's a technical program manager, and she works on our rendering teams at Google, and she's got lots of great stuff to talk about in the 3D space. So welcome, Shannon. How are you?
I'm doing all right. How are you?
Really good. I have to say I'm really envious of your job, but could you tell us what you do?
So I work with a couple of rendering teams here at Google, both Android and Chrome. And we sort of plumb code from user space down to your GPU.
Wow. Can you translate that?
Basically, our job is to get a bunch of triangles from applications down to the GPU as fast as possible.
Cool. And all graphics are ultimately made up of triangles, right?
Basically.
Now, recently you announced Vulkan. Right, and this is this new and improved 3D rendering API. Could you tell us a bit about it?
Historically, Android and all mobile phones really have used OpenGL ES to communicate to the GPU within the phone to tell it how to draw scenes. But unfortunately, over time, the API has become less and less of a good match for what the hardware is actually doing beneath. So what would happen is you would use this API to communicate a lot of the details about your scene, and the GPU has to reorganize all of that so that it can consume it efficiently and draw it on the screen. So what Vulkan is it's another API from the same open standards group that makes OpenGL. And it's designed to be a lot closer to what the hardware actually does beneath the covers.
Okay.
So if you provide the data via Vulkan, it should be able to draw a lot quicker. Sort of the flip side of that is that it gives you all of this control, but it means that you have to be pretty good at making sure that your code is doing exactly what you wanted it to do.
Vulkan and OpenGL ES are both from the same standards body, right?
Yes.
So that's Kronos?
Yes, Kronos.
Kronos, sorry. So you work with the standards body at Kronos?
I do. I get to travel all around the world and see beautiful conference rooms. But it's actually really interesting getting to see how the API is made from the ground up.
Cool.
Android is going to support both OpenGL ES and Vulkan, so developers can choose which API is right for what they're doing. Like if they need to render a FPS game or first-person shooting game that has to run really fast at a high frame rate, then they're going to probably want to choose Vulkan so that they can closely control exactly what's being drawn and when.
Cool.
But
Yeah! Google I/O 2016, right? Oh, come on, we're done clapping now? Is that it? All right, we're done. Hello, everyone. How are you doing today? Good? Staying out of the sun? Yes, fantastic. Hey, I want to thank everybody for being here. My name is Colt McCandless, and I got to tell you, I love Google I/O. I love Google I/O because this is the one time during the whole year that the crazy Googlers get to talk to all of you all about the weird stuff we do that we can't talk about the rest of the year. And that is fantastic, right? And today we're talking about something that's so near and dear to my heart, and that's data compression. It is by far one of my favorite, most obsessive things that I ever get involved with. And I'm so happy that all of you are here and all the people standing outside. I'm sorry there's capacity issues. We'll give them a t-shirt or something later. But really quick, before we begin, I gotta tell you, we've only got 45 minutes today. And that is just not enough time to get through all the awesome, crazy image compression content that we need to get done. So over the past couple weeks, I've been trying to diffuse some of this stuff to some other places. First off is my medium.com page. Has anyone been reading these articles? Yeah, round of applause if you've been reading the Medium articles, yeah? We're live, folks. You gotta make them hear it, yeah? If you read these articles, we get into a lot more depth on how some of these image formats work and how to make them a lot smaller. Second off, of course, is the Android performance patterns videos. Anybody watch these? Thank you, thank you. Thank you. That's fantastic. Now, if you've ever been interested in data compression, if you've ever tried to make an attempt to understand the algorithms, but found that the math is really weird, or it's too gnarly of a concept, or maybe it's not presented in the right way, then good news for you, because Alex Hackey and I have actually got together, and we've actually written a data compression book. And we took a different approach to it. We threw out all the math. All of that crazy, gnarly stuff that makes your brain melt, we got rid of it, and we reapproached how we should be teaching data compression to modern developers and engineers. So if you're interested in deep, fundamental understanding of how to make your apps smaller for users, check out this book. Deal? Deal? All right, business is out of the way. Let's get started. So when we talk about reducing the data sizes of your applications for your users, there's generally two buckets that I like to think of. On one side is your APK size. And this includes all of the stuff like code sizes, language information resources, image resources. We've got layout data, config, blah, 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 blah. All of the information that's zipped up into a single APK file and downloaded when users install your application. Now, on the other side of things is all of the other stuff that your app downloads once it's installed from the internet, right? So this could be many, many, many things, but it mostly boils down to images and serialized data. Now, I got to say that the APK stuff, making your APK smaller, is a whole deep and crazy domain that we're not going to get into today. However, if you stay in your seats, the next session will go very, very deep into that subject. So make sure you stick around for that. One thing you notice here, though, is that images actually show up in both of these categories. And that's why we're focusing on images today. Because quite frankly, images are awesome, right? Round of applause for images? Yeah? I promise you I will ask you to applaud weirder and weirder stuff as the talk goes on. Right? Like, who likes gummy bears? Yeah, there we go. We have to have an understanding as an audience and a presenter. That's how this works, right? Images are fantastic. We use them in our applications. We convey emotion and power and information and all this other great stuff. But images also have a problem, is that they're easy to bloat. They're easy to get too big and too many resolutions and too many pixels, and that causes problems for your users. Because bigger images take longer to download, which means that there's more bits on the wire, which cost your users more money to download them because they're on metered plans. And their cellular radio is on longer downloading the larger images, so you're eating their battery more. All of these little things add up when you start bringing these images down, which is why making sure that your images are compressed as good and as small as possible is super important to make sure that your users are having the best experience. And in general, there's a lot of different things you could do with images, but as Android developers, there's really only 4 data formats we care about: PNGs, vector drawables, JPEGs, and WebP. Now, the rest of the talk that we're going to go into today is going to be opening up each one of these formats, taking a look at how it works internally, and how you can squeeze out every bit of data from these things possible. Sound good? Sound good? Yes. Don't worry, you'll get the hang of the applause cues. They took down the sign that I asked for later. That's okay. All right, so let's start at the top with PNG files. PNGs have to be one of the most amazing formats in terms of Android development. They've been here as long as anybody has seen. They provide amazing quality and actually pretty good data compression. So let's figure out what's going on under the hood. So let's say we have an image. The way PNG compression works is that we take every row of pixels in that image, one at a time. We process each row individually, and what we do is we apply something called a filter to it. Now, the filter itself is basically a modified delta processor, right? So basically, it's going to try to subtract the current pixel in the row from the previous pixels or the one above it and do all this weird math. The point of the filter is simple. It wants to produce the most number of zeros and duplicate values possible. That's it. That's all it wants to do. The output of that is then fed into a very common, super everywhere encoding system called deflate. Anybody familiar with deflate? Get him a t-shirt. That's right, we'll get it to you later. Deflate is actually comprised of 2 main compression algorithms. The first one is called LZ77. If you've watched my compressor head video, then you'll know that LZ77 is a dictionary algorithm that tries to match runs of duplicate characters multiple times in a stream of data. The output of that is then tossed to a Huffman encoder, which is a statistical encoder. If you've ever been to CS 101, you've probably dealt with Huffman in some form. Now, this is done on a single line, and the output of deflate is then kicked out to disk. Now, what these 2 stages mean is very important. In areas of your image where there's very similar pixels, or there's a lot of duplicate pixels, that filtering stage is going to produce a lot of zeros. It's going to produce a lot of duplicate symbols, which means the LZ77 and the deflate stage are going to come through and basically make that stuff disappear. So areas of similarity are going to get great compression. However, areas of noise where there's not a lot of similar pixels, where there's different colors that may not be adjoined to each other, are actually going to have worse compression. And that's what you get with this trade-off of the filtering stage with the deflate stage, right? Now, with this in mind, we can obviously see a couple places that PNGs can be optimized a little bit more, right? The first, of course, is less input colors. If we've got less input colors coming into the filtering stage, that means that we're going to have less unique colors coming out, and we're going to get better compression. The other thing is actually smarter filtering. I won't get into it right now. There's a different post on it, but there's like 5 different filtering modes that the encoder can choose on and all that other stuff. And there's a lot of math and accelerations that go into finding that in a way that's not going to take 10 years to compute it. The other thing is a better deflate algorithm. Believe it or not, deflate isn't the best version of deflate. There's actually more modern deflates out there, and applying those to the algorithm actually produce smaller files. And finally, removing chunks. And that's actually a tricky one that I'll get to in a minute. But I know what you're saying, like, hey, wait a minute. All of that stuff should be happening for me, right? I mean, there's this really cool tool in the Android toolchain called AAPT. Anybody heard of that? Round of applause, yeah? Yeah. I mean, in reality, this should be doing all that for you, right? It should be crunching your PNGs down as small as possible. Anyone seen that happen? Nobody? Some people? Someone's asleep already. 1 applause. Get that guy a t-shirt. T-shirts for every clap. So I want to point out that while the AAP tool is there to actually try to make your PNG files smaller, it doesn't do everything it could. AAPT tool does 3 things specifically, no more, no less. The first thing it does is analyze your PNG files to see whether or not you're only using grayscale colors. So for example, if your red, green, blue channels are all the same color, it will actually make your entire image into single 8-bit alpha channel. That's it. Goes right down to grayscale. The second thing it'll look for is whether or not you're actually using your transparency channel. If you've got a fully opaque image that's not using any transparency bits, it'll actually get rid of that entire channel and save it out to be smaller. And the final thing, and this is the one that's pretty awesome, it'll actually scan your entire image and determine whether or not you're using 256 unique colors. If you're using 256 unique colors, it'll save your image in a paletted format, which basically decreases the size by some insane amount. Right? Basically, all of the 32-bit per pixel data gets quantized into a little table like that we call a palette, and it's replaced with an 8-bit pointer into that palette. So instead of 32 bits per pixel, you're now down to 8. Good savings, right? So the question that I have, though, is, okay, AAPT is really good, but how good is it? And to answer that, I had to open up an application and take a look at how AAPT was impacting and affecting that application to see whether or not it was doing a really good job or if there's some improvements to be made. So being I/O, I felt maybe we should do a callback to last year's I/O Shed application and see how well AAPT was doing with that. So anyone look through the source code of the I/O scheduler application from last year? Round of applause. Yeah? Good. Did anyone find the hidden Easter egg in the source code? No? Oh. Then forget I said anything. So when we open up this file, there's a lot of assets. Now, there's 2 things to compare here. Of course, first is the source code files in GitHub, and then there's the APK that you can actually download from the Play Store, unzip, and take a look at the assets, right? So I wanted to look between these 2, because if AAPT is doing a great job, I should see a big change between those 2 file sizes, right? So I opened up the file, and I just picked some random graphic. This was the one I happened to look at. That's a 144 by 144 pixel PNG file, and that's 6K. That's huge, right? Sorry, this is in the source code repo, right? Now, when I open up the APK and take a look at it, it's actually only 2K, which is better, but still way too big for 144 by 144 pixels. Like, that's massively huge, right? And so I said, well, hold on, something's missing here. Obviously, we got some optimization. Let's figure out what's going on. So I opened up this image in Photoshop, and I saved it for the web. There's a difference between file save and file save for web. There's a whole different process in there. In that process, I actually quantized it to only use 256 colors. And you can see when I did that, we got about the same size as was in the APK. So we can see that, hey, the AAPT did its job. It probably quantized this to an indexed image, right? But here's the problem. Take a look at that image. Does it look like it's using 256 colors? No. So let's crank it down a little bit. Here's what 64 colors looks like. Anybody see a change? Let's go even more. 32 or 16 colors. Still don't see a change. 8 colors. Still don't see a change. Or if you do, your eyes are better than mine. The point here is that we went from 256 unique colors down to 8 unique colors and didn't see a change in visual perception. The difference in file size, though, was huge, right? Because we were able to find a smaller color size. So let's look at a different example here. So this is one of the big banners, big banner images that you see inside of the application. That's 49.5K in the GitHub repo and 32K inside of the APK. So again, there's some smaller modifications going on here to the AAP tool, but still, let's see if our trick works here too, right? So let's actually down-res it to 32 colors. This one isn't that good, right? I mean, you can see some banding in the gradients there. You can see that some of the colors just aren't looking as true as you can. So let's bump that up to exactly 256 colors. Here, you can't actually see any visual difference, right? But notice the difference in the file size. This is only 18K instead of the 36K, right? So this image actually only needed 256 colors, but maybe the source image didn't have that. And this is the problem with the AAP tool. It does a great job of those exact 3 things and no more than that. So in the first case, we had an image that obviously needed less colors, right, and could have been optimized more. And in the second case, we had an image that had maybe just over 256 colors, that if we set it to 256, it still would have looked fine, right? AAPT does neither of these for you, which means that it's your job as a developer to step past that and start doing additional methods to reduce the size of your PNG files. So let's take a look, as I said before, how easy it is to mess this up. So you've actually just take a 16 pixel by 16 pixel all red PNG file save as from Photoshop. You look at 2K. That's 64 pixels. That's 2K. The funny thing right now is everyone in the room is doing a gut check about whether or not their designers are using file save as from Photoshop to save their PNGs, right? Right? When you save it for web, though, you end up at 121 bytes, which is better, which is obviously better. That's the thing we want to see. This is how easy it is to mess up this problem. Now, the good news is, though, that you don't have to go into crazy town with trying to optimize all those things we talked about before with the different stages of PNG. PNG optimization is an old problem. Old meaning the 90s, right? I mean, some of you were alive in the 90s, right? OK, yeah. Well, who wasn't alive in the 90s? OK, all right, yeah. Old people, nice. Sorry, professional people. Yeah. The truth is that there is a plethora of tools out there that have already been solving this problem for almost 2 decades. You don't got to do the heavy lifting. Just Google it and pick any one of these. Really, they all do different stuff and have different algorithms and different needs and different settings and whatnot. But if you just add any one of these to your existing asset chain, you're going to get an immediate reduction and an immediate improvement in file size. Now, that being said, there are some things that you can do to make it even better in terms of file sizes. And I only mention these 2 things because I'm seeing them a lot in applications that I'm opening and taking a look at. AKA, here's the things you are all doing that you need to stop. So first off is, if you can, in every single way, try to make your image 256 colors or less. It's a pretty simple quantization step. You just test it, you take a look at it. Here is one of our Google Doodles that we actually put on our main page here. You can see it came down as 24 bits per pixel. It wasn't indexed at 197K. When we exported it, the index mode is only 73K. Again, visual difference here, imperceptible. But the difference in file size was huge, just by trying to take into account hitting that indexed mark. And you can see the palette here is actually pretty simple. I mean, there's nothing crazy going on. By the way, that diamond down there on that white actually represents the transparent pixel color for that. And you can actually do a bunch of those. So, read the article. There's more stuff on that there. Here's another one. Can anybody tell me why one of these images is 139 and one of these is 214? Alpha channel, good. What about the alpha channel? Wait, did you read the article? Oh, wait, never mind. Cheater. No, I'm kidding. So it's absolutely right. Alpha channel. So here's what's happening. I've seen this quite a bit in a lot of the files I've opened. So visually, you can see that the last frame is what the user sees here. But when you open this thing up and you take a look at the RGB channels and the A channels separately, you can see that the RGB actually has a ton of data that gets masked out by the alpha value. The end result is the same visual image to the user, But to the compressor, we still have to compress all of that RGB data. The filtering stage still has to be run on it. The output of that still has to be run through a deflate algorithm. And because there's a lot of non-uniform pixels there, the result is going to be a lot of bloat in your compressor, right? However, if we try to pre-multiply this stuff and mask out the pixels that we know are never going to be seen, we end up with a much smaller file size. I've been seeing this in applications popping up lately a lot more than I'd like to say. So take a look at this. Now, one of the final things I need to point out, if you're going to go down this path and you're going to add in some of these awesome pre-processing tools to your chain and get it all working with Gradle, and you're going to tell your designers to not do that thing I just said and try to make index files, you may run into a really weird issue. So let's say we've got this great image. It's about 216K, and we actually run it through Zoffly PNG, which is a fantastic open source tool that is a better deflate algorithm compressor for PNG files. And we get it down to about 185K. But when you build it, it actually goes through AAPT and it bloats to 201K. The reason for this is that the AAPT tool doesn't know that you've pre-processed your image, right? Again, it's only checking for those three things. And so it's going to look at your image and it's going to try to make it into A, B, or C format, and then it's just going to save it right to disk. The problem with that, though, is that you may have made modifications, and obviously your version is smaller and their version may not be. To get around this in your application, you need to specify the option Gradle cruncher enabled equals false. This will disable AAPT optimization for all of your PNG files that are coming through your pipe. Now, the problem, though, is that once you do this, it's kind of on you to make sure that all of your images are awesome at that point, right? Which you're all going to do. All right, now the back row. All right, let's try the front row again. That was good. That was good. I'm sorry, the front row's winning. Back row, you want to try again? Oh! Oh! They added whistling. Come on, front row. We'll try again later. All right, the live stream's getting antsy. All right, so make sure that you actually set this file, or this configuration inside of your Gradle file so that you don't end up actually bloating images that you've already taken the time to compress. Now, probably one of the biggest things that you can do, though, in terms of file savings, is actually consider replacing your PNGs altogether with vector drawables instead. Now, for those who don't know, PNG files are raster files. They have a big problem in that you need multiple of them in a file to actually get your images. So, we need one at this resolution, and one at this resolution, and one at this resolution. Which means in our APK, we're actually ending up at 55K footprint to represent the same visual image at different resolutions. And there's some tricks you can play here with split APKs and upsampling and all this other stuff, but this is the gist of the problem. There's another way to approach this issue, and it's the concept of actually drawing your images with code. So that same picture, what if we took a stab at it saying this? Let's emit a bytecode that actually draws a white background, and then another code that actually draws a red circle. Now, if we could create our custom DSL language and whatnot, we could actually get this into 1 byte per instruction, and actually end up at about 15 bytes to represent the same thing. The result of this is that we can generate those same 3 images at any of these 3 sizes using only 15 bytes of our scheme instead of the 55K that we were using before. This is the concept of vector image formats, right? Basically, we take some sort of stream that represents how to draw primitives on a screen. We actually execute those, rasterizing those primitives to a bitmap in CPU memory. We upload that to the GPU, and then we end up actually drawing that to the screen. The benefit you get here is much smaller file sizes. The downside, though, is you actually trade off time. It takes longer to rasterize these images and get them into memory than it does to actually, say, use the hardware decoder and decode a JPEG. So there's a little bit of a trade-off you have to deal with there. But this is the whole idea behind Google or the Android's vector drawable format. It's a series of instructions that define how to draw paths and colors and gradients and all other sorts of stuff so that you can draw these images at the sizes you need on demand. But the question is, okay, this is fine, this is fancy, I've already got a pipeline of awesome PNGs, and my artists know how to make PNGs, they don't know how to do this vector drawable thing. Come on, bald guy, let's get to the point here. What's really going on? Don't worry. So I decided to run a test. How much could vector drawables actually save me as a developer? To figure this out, though, I needed to take the IOShed application and actually convert all of my images to vector drawables. Well, there's 270 of those things, totaling up to 926K in size. I don't have the time to hand customize all 270 of those images. Thankfully, there's a tool to the rescue. There's a great tool on the internet called PO Trace, and this tool's been around a long time. It'll take a bitmap image, which is literally a image with 1 bit per pixel, and actually turn it into a vector format. Raster image to vector format. So I decided to run this on every asset inside the IOShed application, and the results were actually a lot better than I expected, to be honest with you, right? So you can see the top row here is the source, and the bottom row here is the result of the PO Trace application. We're pretty close. The first one looks identical. The second one, you can see some rounding. The third one, pretty good. The fourth one, you can see that we're only dealing with shapes, so we lose some color there. And the hexagon is perfect. The hexagon is actually a really cool example here, because that hexagon actually absorbed 6K of our file size at different resolutions. However, the vector drawable vector version was only 961 bytes. So even just running it through here, we saw some wins. The downside, though, is that this is an automated tool, right? I mean, this is only a test. We're just trying to figure out how all this stuff works together. And obviously, there were some failures. We missed some interspersion detail. Obviously, we're not getting the exact font representation, and it just fell over and died on the I/O algorithm, right? The result, though, I think was a good test to figure out what you could save. So running things through PO Trace, we actually ended up with only 153 files, because we didn't have to have one for each resolution. And the result was actually 149K. That's 84% reduction in asset sizes by just moving everything to be a vector drawable, which is a pretty good savings. Yes, let's clap. Yes, this man. Yes. You started the clap, sir. You are awesome. Fantastic. Yeah, so 84% smaller, that's a pretty good deal, right? Now, it's worth noting this was just a test. You can't just go run PO Trace and convert everything over. I mean, it spits out EPS files, and that's not the same as VD files. And oh, by the way, there's actually a chance that you could optimize stuff further, right? Instead of just importing from SVG, if you did stuff by hand, you may actually be able to get stuff down even smaller than that. So, but the main point is, you can get a lot of savings here by moving to vector drawables, so make sure you take a look at it. All right, now let's talk about the big images. The big, big images. JPEGs. Who loves JPEGs? Yeah? Yep. I didn't hear anybody in the back. I love the begrudging pause, right? Like, oh, fine. We're just here to stay out of the heat. Pass me some water. This is great. Okay, JPEG files. I gotta tell you, JPEGs they're crazy. One of the most impressive algorithmic systems I've ever encountered. It's impressive, the math that goes into this. Not just from an algorithm perspective, but just the raw math of the situation. Take a look at this. So when you encode a JPEG, here's what's going on. You take your source RGB image, and the first thing that happens is we actually convert it to a separate color space. The reason for this is the human eye, the psychovisual differences in the human eye are less susceptible to the YCBCR color space, or the chroma lumens color space, right? We're actually more tuned, the human eye is more tuned to see differences in RGBs than we are YCBCR. So the first thing that JPEG does is convert us to that space. The next thing is we actually reduce the size of the CB, the chroma channels, CB and CR channels. Again, the human eye doesn't notice as much changes in that spectrum, so it doesn't worry about it. After that, we actually go through and block up our image and apply the discrete cosine transform. This is magical. If you get a chance to check out the blog post on this, basically the idea of the discrete cosine transform is that any signal can be represented by a sum of cosines. What? It's a thing. It's a thing. Like, these mathematicians sat down and worked that out on paper before computers were awesome. Like, discrete cosine transform is one of the most amazing things I have ever seen. Basically, they can represent any 8x8 block of pixels by summing cosine transforms across a 2D space. That is awesome, right? The output of that is then ran into a quantization phase. The quantization phase just basically takes the output of the basis coefficients and quantizes them down to integers in a subspace that we can actually encode more. They get spent out to the statistical encoding phase, which may be Huffman or arithmetic or whatever your particular flavor of the month is. And then finally, of course, we go to the output JPEG file. Now here's the weird thing. This is awesome. This is totally crazy, right? Way harder than PNG. Then why, when you export an image, you're given like one slider? All of this chaos is hidden behind one slider when you export an image. That's impressive on its own right. Now the question is, what should this value be? This is the JPEG quality. When you export a JPEG, we ask you what quality you want it output at, right? And so the question is, what should this be? Right? So let's take a visual look at what the Photoshop would actually output as. So here's PS12, so this would be 100% JPEG quality, right? 263K. Let's drop down to 11, 10, go to 8. You can start seeing some blocking here. Look right above the red parrot's head. You can start seeing some ringing artifacts. The gradients in the background aren't as solid there. Let's go down to 4. So this is quality 4. You see a lot more ringing artifacts here, right? You can start seeing the quantization artifacts in each 8x8 block, right? And 0. Obviously some color bleeding going on. We're seeing some big stuff there. So the question is, though, what value should I choose? Right? I mean, you can't open every single image and take a look at it and choose the right value. There's just no way we can support that in any sort of real pipeline. The solution is to not. It's to automate the whole process. And for that, I'll get to in another slide. The real solution here is to automate this process and figure it out, but that's actually not what most people are doing. What most people are actually doing here is choosing some value and exporting all of their images at that. The ImageMin project, which is an open source project on the internet, started downloading a bunch of images from all of these social networks and figuring out what their exported quality was, and then put it together in a table. So you can actually see what everyone is exporting things at. Now, the ones with ranges are actually really impressive because it means that they're trying to actually find the right range of things. The weird thing is it's not as scalable as you'd think, right? Like if something happens to be brighter, it's given these values. If it's darker, it's these values. It's a little bit more quantized than dynamic. But the question for your project is, how do we figure this out algorithmically? And for that, I want to introduce Buturgali. This is an open source project made by the compression team in Zurich who loves naming things so that I can't Google for them. Or spell them or pronounce them. So to make sure that you all can pronounce it, we're going to say it together here, okay? This is going to be Bu, Tur, Ag, Li. Buturagli. Okay, now you all can Google this later. In the native language, it means a sweet bread to eat with coffee, but in the GitHub project, it means a way to compare the psychovisual similarity of two images. This is basically a way for us to say, let me take a source image and compress it and see how the human eye responds to the differences between these two. How much error can we actually notice? You may have heard some other terms in the past, like PSNR. Anybody hear that one? Yeah? SSIM? Yeah, these are common. Yeah, nice. These are very common things. Think of Buturgali in the same fashion of that. The ability to measure two different psychovisual changes as an image changes. Now, the real use of Buturgali, the intention that it was made for, was to actually figure out how much we can compress an image before the human eye notices anything. Right? How far can we go before even the smallest perceived visual change occurs? And when you actually use the Buturgali library, you'll notice that that actually occurs at the 1.0 level. So when you export at Buturgali 1.0, that is where, or when you test it and you get 1.0, that is where the human eye starts to notice artifacts. Anything above 1.0 is chaos land. Anything below 1.0, the human eye can't decipher. Right? So your goal would be like, hey, we have a lot of high-res images, we want high-res images, and we want to find the ideal export. This will help you. But sometimes I don't want perfection, right? Sometimes I want a little bit of compression artifacts in there. Sometimes someone's loading something on a 2G network, or they're sitting on roaming, or they're in the middle of India, and they don't have the right connectivity. I want to give them a worse quality image so it doesn't take them 6 hours to download the thing, right? They don't have to pay for it. So maybe I'm okay going above 1.0. So how would we go about doing something like this? How would we find the right level for some other statistic? And it's actually pretty easy. If we actually take a little Python script here and we run ImageMagick, we can convert a PNG to a JPEG file at some quality, right? We convert that JPEG back to a PNG, so we know we're actually comparing apples to apples here. And then we run those two PNG files through Buturgali. And if the score is above some random metric that we've decided based upon artificial intelligence and machine learning for this person in this area on this device, let's just say it's 2.0, randomly, then we return that quality value. So what does this look like? So I ran this on the parrots images, and you can see really quickly we found that about quality 60, we passed the 2.0 threshold, right? And then it actually was able to dive in a little bit more and get single-step quantization. And actually found that at quality 62, we broke the 2.0 threshold. Let's look at this side by side. This is the 1.0 score and the 2.0 score. The difference is 60K. right? But the Bootergolly image metric is so nice that you can see very small changes in the 2.0 version. And of course, this is blown up on a screen and on the live stream and all this other stuff. But the main point that I'm trying to get to here is that you don't have to choose one image compression quality for everything. You can actually dynamically choose this and move on. So beyond that, though, there's a couple things that you can do by hand. JPEG, unfortunately, has the same problem that PNG does, right? Files save as from Photoshop, 11K for that 16 by 16 pixel block. 11K! Oh. Are you sure your designers aren't doing that? Are you really sure? Think about it. Maybe send a text real quick. Yeah. Save as gets us to 1.1K. Still, that's a 16 pixel by 16 pixel image. The funny thing is, you want to know what's going on here? Extra data, metadata. JPEGs and PNGs have the ability to add block data to your image. So when I'm standing on the Google campus, wandering around because it's Google I/O, and I take a picture of the gator, this is how my image sharing service know that where I was standing. There's blocks that they can insert into your JPEG files that have this location-based information. And that bloats your image. And if you're not properly removing this stuff as an image-serving application, that means every other user who's downloading it is grabbing this extra bloated data. Obviously, that's not a good idea. So let's talk about, that's obviously block removal, but there's a bunch of other places that we can optimize here, right? We can change how we're downsampling. We can improve the way that the DCT coefficients are handled. We can improve the way we quantize, and we can just apply a better statistical encoder, right? Great news, folks. You don't got to worry about any of that. Everybody's already got it solved. Googling for this brings you a pretty good handful of algorithms and tools that you can put right into your tool chain. The first two here, JPEG Mini and MozJPEG, actually go to find another lossy compression variant. So they'll degrade the image quality of your image to get you just a little bit farther and a little bit more savings, right? On the other two, CJPEG and PACJPEG are lossless. They're going to try to improve those quantization and statistical encoding stages so that you don't actually lose any bits. The interesting thing is that PACJPEG actually works more as a post format than anything. It'll actually take your JPEG and encode it in its own format so we can get it even smaller than that. And of course, you've got a lot of web solutions that you can find too, where you upload your image to some API or some service. It'll do everything on the back end and send it to you. I don't care what you use, pick one, right? So, and don't let your designers hit save as from Photoshop, right? Any of these will work. Pick one, test it out, see how it works. Send me a tweet, let me know how it happened, right? One thing though, I gotta say, this one's really cool to do by hand, and I've only got a couple minutes, so I'm gonna try to go through this fast. Two images here, top one 175, Colt modified 82K on the bottom. What we're doing here, remember that the first thing that JPEG does is split your image into a different color space, right? Because the human eye is more perceptible to some loss than others. So what we do here is we actually, in Photoshop, split this to lab color mode, right? Which is luminance and then AB channels. We select the areas of high contrast inside of the AB channels, and we actually just go File, Blur. What we're doing here is we're actually reducing the number of unique colors, the amount of noise in these chroma channels, so that when the JPEG codec comes back through, there's less information there that it has to find unique, and you're actually going to get better compression as a result. So this simple technique, going through, hand optimizing some of this stuff, can actually save you, what was this, 2x or 50% savings on a file? That's if you're still serving 1 million files a day, that's huge, right? All right, let's get to the final one here. WebP. Fans of WebP? Yeah? Yeah. WebP, I gotta say, is as impressive as JPEG is, WebP it's in its own league. I've done compression for a long time. It's in its own league. I mean, on one side, you've got a whole suite of algorithms that applies so it can keep up with the lossy type of compression that JPEG does. On the other side of it, it's got this whole separate filtering and prediction policy so it can do lossless encoding, just like PNG. It's even got some LZ77 and dictionary encoding in there so it can do that. The result is pretty simple. Across the board, all of these optimizations and techniques make it competitive with both PNG and JPEG everywhere, and it supports all of these features as well. And in most time, it's actually winning if you check out those. So you get smaller file sizes, you get more features in those file sizes, and it's supported natively on Android, which is awesome. Round of applause for that, right? Okay, now let's get real for a minute. I know we laughed at gummy bears and had a clapping war, but let's get real. Can we get real? Round of applause for getting real. Yeah? weirdest applause request ever. If there's one thing you remember, if some bald guy got on stage at Google I/O, I was hiding in a tent trying to get out of the sun, and he yelled at me for an hour, but I remembered one thing. It's this. This is one thing. This is all I'm asking you to remember. That's it. Nothing else, just this, okay? This diagram. When you're choosing what kind of image to make, the decision on the format is super important. The first thing you have to ask yourself is, can this image be a vector drawable? If yes, make it a vector drawable. Done. Easy. Go to lunch. If no, ask yourself, do I support WebP? If yes, make it a WebP. Go to lunch. You're done for the day. Good job. Peer bonus. Sweet. If you don't support WebP, ask yourself, does it need transparency? If yes, obviously you got to use PNG for that. If no, you got to ask yourself, is it simple or complex? Remember, PNG optimizes and compresses better in areas of very self-similar pixels. So the more photorealistic an image, the worse PNG is going to compress it. The more simpler an image, the better PNG is going to compress it, right? If it's complex, we're going to go to JPEG. Now, if we end up at PNG, we want to make sure that we're running a tool on it, reducing colors, trying to make it indexed, and hand optimizing it in places where we need to for hero assets. Same thing with JPEG. Use a tool, correct the quality, and hand optimize where you can. I love that everyone's taking pictures. This is live streamed. You can get this later. In fact, if you check out the Spaces application, I'll put this up later. Put your phones down, you're good. I'm flattered that you're taking a picture of me, but I can pose. Anyone want a picture of the pose? No? Nobody? Oh, some. Awesome. I need to be over here? Okay, no, we gotta get back to it. The AV people are getting mad at me. Sorry. Okay, most importantly though, this one simple thing. Profile your code. Profile your code. Profile your code. Before you make any decisions, before you make any performance changes, before you change your format, before you put bits on the wire that your users are going to have to pay to download, profile it. Make a decision based upon evidence and data and the best thing for your users. Do not go lazily into these decisions because they have huge ramifications for the people who love you and your applications. Profile it. In some cases, JPEG is going to be better than PNG. In some cases, WebP is going to be the best option. In some cases, it's going to load too slow, and you're going to want to use a JPEG. In every single situation, profile your code. Find the sweet spot. Optimize for your users in every case. And thank you so much for coming to this session. My name's Cole McCandless.
Hi, I'm Timothy Jordan, and this is The Developer Show. I'm standing here with Purnima Kochikar, Director for Google Play Apps and Games. Purnima, welcome to the show.
Thank you, Timothy. Thanks for having me.
Hey, it's great to have you here. First, I'd like to learn a little bit about your history and what brought you to Google Play. I know that you used to be VP at Nokia for developer communities. What is it that you learned about developers there that brought you to this role?
What I loved about working with developers is that they are always optimistic. I don't think there's any job in the world that you're working with more optimistic people who are trying to solve amazing problems. Every day I talk to people who are saying, this is a new way of doing taxis, or a new way of doing education, or a new way of supplying food. So there's always a new way, and that's exciting. The second thing, what I love about developers, is that they'll take the technology or a platform that you have built and completely use it in ways that you have never imagined would happen. And so the two aspects of it, the surprises and the solutions, is what makes me excited about working with developers.
That's one of my favorite things too, is that working with platforms, we always kind of have an idea of how developers are going to use it, and then they always find a way to surprise us, especially with Google Play, because the landscape is so huge. There's always something every week where you're like, that's amazing, and I never would have thought of that.
Yeah, exactly. And so it's amazing to be able to do this. Plus, you realize that you're actually making a difference in people's lives, both for the developer as well as for the user. Yeah. And so that helps too.
It's interesting to talk about Google Play because developers building Android already know about Google Play. But sometimes I wonder if they know all of the kind of nooks and crannies and some of the best features. Do you have like maybe some of your favorite lesser-known features of Google Play that are great for app developers and publishers?
Well, I don't know whether it's about lesser-known features, but maybe we should talk about the things that people may not think about. Number one thing I believe that people should really think about is that your users really want your app to get better. And you should tap into them. I think a lot of times we think, I hear developers say, there's a really bad review, can you make it go away? And I'm like, no, harness it. Your user really cares. So what can you do about it? But they're also telling you positive things. So on Google Play, one of the things we've really focused on is to how to get developers harness all the intelligence of the users to make better products. So everything from alpha beta testing to stage rollouts, and now we just introduce A/B testing, which we call store listing experiments. So harnessing the intelligence of your users, who are your biggest advocates, and your users to make apps better, I think is something people don't use enough.
Well, and we just mentioned an article on the show about ratings and reviews in the Google Play Developer Console. And I think we've done a lot of work there to bring that intelligence into a format that's actionable and really intelligible at the same time.
Absolutely. One of the big things developers told us is that we love the fact that we can reply to reviews and that we can have a direct channel of communication to our users. However, there are so many reviews. How do I find the themes? How do I know areas that I should focus on? And what I find interesting is that there are folks who view it as something as a problem to fix, but a lot of people are now looking at as strengths that they need to leverage. So they're looking at it as a way to measure community sentiment management. So what we did is to say, how do we measure sentiment? And the tools that you're talking about allow developers to, use Google Smarts to understand all the hidden gems in your ratings and reviews.
That's cool. Developers often ask me, and I'm sure they ask you as well, what's the secret? And coolest thing is you actually recently published the second version of the Secrets to App Success on Google Play, which you should check out and will be linked in the show notes. However, maybe you could give us a highlight. What's one of your favorite kind of insights from that book?
The first thing we did was actually put it out linearly. So the nice thing about the book is that you can always just jump in where you are at the stage of what matters to you. So if you're in design, there is a section for design. If you're in a place where you're building growth, there's a section for growth. If you're thinking about, should I use ads for monetizing, there's a section for that. It goes not just about Android and Play, but also looks at other Google technologies, like ads, for example. So that's a huge plus. So the big insight I would like to point there is to really think about this, what it means to be not constrained by the market that you're in. Android is huge. It's around the world.
Okay.
And you could be a global business no matter where you are. This book gives you interesting ways to tie from everything from how do you design for various markets, how do you localize, but also how you price. So that I think is...
It's really inspiring.
Yes. I mean, think about it. 20 years ago, they would have needed a new management team to figure out how to take a business global.
Yeah.
Now you could do it from your living room.
And sales offices in multiple markets, whereas, again...
Now you can.
That's great. Thanks for joining me today.
Thanks for having me, Timothy. This was fun.
For more information about everything that we talked about, check the show notes for links. And of course, subscribe to this channel for more interviews like this. I'm Timothy Jordan, and I'll see you next time.
Polycast 43, take one.
Hey there, Polycasters. Rob here. Welcome back to the show. Last week, we were doing this thing called Ask Polymer, where we take questions from you and then we try and answer them here on the YouTube channel. And as we were collecting those questions, I noticed a lot of folks were asking, when's the Polymer team going to create a data table? Or what is the roadmap for this particular element and stuff like that. And as we were going through that process, I really started to think that, if web components are going to be successful, we're going to have to scale beyond the Polymer team. Really, it's going to be up to all of us out here in the community to start making cool stuff, sharing it with one another, and also promoting it, right? So one of the things that I wanted to do was, here on this show, I want to start a new segment called Built with Polymer, where I take all the cool stuff that you're building and we just show it off so other folks can get involved with the projects and start using it in their own applications. Now, to do this, we're going to start off by looking at a website called customelements.io. I'm curious, show of hands, how many of you have seen customelements.io before? Okay, I noticed that you did not raise your hand, sir. So for you and for other folks like you, I want to just walk you through how this website works and some of the cool stuff that's on there. So if you haven't seen it before, customelements.io is pretty badass. You can think of it kind of like NPM for web components. It's sort of a registry. It collects all the things that are actually in the Bower registry, and then it displays little bits of info about it. So you can search and you can find the different components that are out there. You go to the website, and the first thing that you're going to see up here are these three sort of main sections. You've got the stuff that is recently created. It's brand new. You got the things that have been recently updated, which I always like to see. That's supposed to be a clock. And then you've also got the stuff that's the most popular elements out there. So the things with the most GitHub stars. All three of these very useful categories to kind of keep tabs on. And one of the things that I also really like is you've got this really huge search field up at the top. Anything that you could kind of imagine needing a component for, you can just go type. So I might say, oh, I want something like a table. So go type in table, and now I've got all of these cool results popping up here for various kinds of tables. Another thing that customelements.io gives you, which is pretty awesome, is at any point if you want, you can click on someone's profile photo. And this will show you not only their profile page, but also all the cool elements that they've produced in addition to that one that you were looking at. So if you think someone's making some really high quality stuff, you can kind of stalk them on customelements.io and see what else they're making. Going back to where we were last week, a lot of folks were asking, when is the Polymer team going to create a date picker in the material design style? Now this is something that is not currently on the Polymer team's to-do list. We have a lot of elements that we've created, and right now what we really want to focus on is sort of polishing those, closing bugs, and making sure that they work really well. So at the moment, no one is actively working on a paper date picker, and that, for a lot of folks, is sort of a dilemma. But if we go to customelements.io, we go to the search field, we can just type in date picker, or just date, whatever, and we can see right here, right away, we've got this paper date picker that shows up by this guy named Ben Davis. So let's scope that out. And looking at the component page on customelements.io, we get a lot of information really quick right here. So I can see, for instance, how many stars this component has. I can see how many people have forked it and how many people are watching the issues on it. I also get the one-liner to install this on Bower. And what I think is maybe one of the most important aspects of the site, I get this activity panel here. And on the activity panel, I can see that the component was created a year ago. And most importantly, I can see that it was last updated 11 days ago, which tells me that this is still being actively developed. People are, contributing to this thing. They're patching it. They're fixing bugs. And it's getting a lot of love right now, which is important for anything that I'm going to add to my application. Also, we've got the list of Bower dependencies down here on the right-hand side. And again, it's really valuable because I want to know that, hey, is this thing depending on the latest version of Polymer, or at least Polymer 1.0 and some version above that? I don't want an element that is Polymer 0.5 or Polymer 0.3 or anything. That's just not going to work in my app. So having all of this information just kind of at your disposal every time you go check out one of these elements is a huge, huge benefit, and one of the main reasons why I think everyone should be using custom elements.io. Now, the other thing that it does is it slurps in the README for this element. So you can see here on the left, I've got kind of the GitHub README that's just been pulled into the website. And if you want, you can go down here and click on the component page. And this is going to give you sort of the classic Polymer docs style, right? You've probably seen these before, where you can see properties that an element supports. You can see the methods that it supports as well. One of the things that I noticed was not showing up here, usually up in the top right corner, there's a little demo button. It's not showing up on this page, but we can just add that by typing demo into the URL bar. And now, we've got our paper date picker showing up. And you can see this thing looks pretty nice, right? I can go click around different dates. Changing the month gives me these sort of cool material design ripple effects. Close it, and then I can click this button again to show you how it reopens. Lastly, one of the things that's really important is making sure that the date picker is responsive. So I go grab the corner of my browser, start shrinking the page, and then boom, you can see that it has changed its layout, which is really, really good for mobile devices. So that is just one element that Ben Davis has produced. If you go back to his profile on customelements.io, you can see that he's got a few other items here. Paper chip, paper time picker, slightly different from a date picker, paper full screen dialog, a lot of really interesting looking stuff there that hopefully we can show off in a future episode. So go find some elements on customelements.io, go find the authors, stalk them on GitHub, don't stalk them in real life, but stalk them on GitHub and on this website, right? So you can keep tabs on all the cool stuff that they're building. Another thing that happened last week was a lot of folks were asking, when's the Polymer team going to create a data table, something that is really sophisticated that I can filter, where I can rearrange columns and do all sorts of stuff like that. Honestly, again, this is one of those things that it's such a big undertaking. No one on the Polymer team currently has it on their to-do list, because building a complex data table, you could seriously just found a company just on making a killer data table. And in fact, there's a group of folks who have done just that. So recently, a team called Vaadin released a set of elements, which they're calling Vaadin elements. And very similar to the product lines that the Polymer team vends, things like iron elements and paper elements, they put out this set. And the Vaadin elements are split into kind of two categories. You've got these business-oriented elements for things like data tables and combo boxes. They've even created an icon set of kind of businessy icons. And then they've also got a bunch of sort of data visualization components, Vaadin charts. Now, the core elements, as they call them, these sort of business layout ones, these are all free and open source. They are Apache licensed, so you can use them in your project today. And then the chart elements, those are a commercial license, which you have to pay for. But since a lot of you were asking about data tables, I thought this would be a really good one to highlight because it's available and you can mess around with it and use it today in your project for free. So if you go to their website, which is at vaadin.com/elements, they've got this little demo button. And if we click that, it's going to show us this cool expense manager application. So I'm going to scope out the live demo for this puppy. And we've got a really, really nice looking experience here. So kind of classic table layout, columns and headers. What I really like about this is there's these filters up at the top. So I can just go and check some of these values. And for instance, checking in progress and reimbursed, you can see over here the amount of items in the table is changing as I'm changing these values, right? You can sort of see them changing over here as well on the left. We can also look for different merchants. So I could say, oh, I just want to see stuff from the taxi merchant, for instance, and we'll just get only the expenses related to that category. Likewise, we can search by min and max values. A lot of cool things you can do here. They've even got this little floating action button down here at the bottom. So you can use that to open a dialog and actually add a new expense to this table. Really, really cool example, really, really cool, powerful element. It's one of those things that, again, it's not on the Polymer team's agenda at the moment to build, but here you've got this awesome community-built project, which we can all start using in our own work. So yeah, that about covers it for today. I know I've only shown a couple elements, but there's actually a big, long list of elements that I want to start featuring on this show. But before I get into that, if you out there, if you've got some stuff that you've built which you would like for us to show off, it can be elements, it could just be cool projects that you've built, please leave me a comment down there in the YouTube comments, or you can ping me on Twitter at #BuiltWithPolymer. That about covers it for today. So as always, thank you so much for watching, and I'll see you next time. Ready? Yeah.
43, take 2, second sticks.
Hey there, Polycasters, Rob here. I'm gonna pause for a second. Oh, Twitter notifications.
If a tree falls in the forest and nobody's there to hear it, does it make a sound? More importantly, if your app gets published to the world and nobody's there to download it, was all that work for nothing? These aren't just philosophical questions. Discovery is a major issue for everybody. It doesn't matter if you're a two-person shop or a big corporation. And while there are many avenues for potential customers to discover your app, one of the most common is through recommendations from friends and family. Developers know this, which is why you see referral codes like this in a lot of apps. It's a good way of enticing users to share the app with their friends. But while these kinds of referral codes can be effective, they're also kind of a pain to use. Is your user really going to take the time and effort to copy and paste a referral code into an email, send it off to their friends, hope those friends then find and install the app, dig up whatever code redemption screen they need to redeem this offer, and copy and paste this code back into your app? Well, maybe, but maybe not. And while you could build your own UI to help this process along with, all those spare engineering cycles you've just got lying around, this is also where Firebase Invites can help. Firebase Invites makes it easy for your users to share all aspects of your app, be it a referral code or an interesting piece of content, across both Android and iOS. It looks something like this. Let's say that your app has a referral code that you'd like your users to share with their friends, and you decide to use Firebase Invites to make it happen. When your user clicks that share button, they'll see a dialog listing all their friends and colleagues with some smart recommendations at the top. They choose which friends to share with, click send, and these invitations are sent, along with a personal message, over SMS or email, depending on the contact. Their friends receive a customized, richly formatted invitation, either one you've designed yourself or one you've let Firebase Invites build automatically from your app's store listing. All this recipient needs to do is click on the call to action button, and Firebase Invites will take them directly to the app if they already have it, or the appropriate app store for their device if they don't. Once they're done installing your app, Firebase Invites can then send the referral code to your app through a deep link. And you can send your new customer the discount that they so richly deserve. And yes, this really does work even if that friend had to install the app first. Traditionally, deep links tend to get lost during app installs, but Invites uses Firebase dynamic links, which are able to survive the App Store installation process. As an added bonus, many developers have found that not only are these kind of invites more successful at driving installs, but that users who join through this kind of personalized onboarding flow are more likely to come back to your app in the future. And Firebase Invites isn't just for referral codes. You can use it to share any content you want from your app. Have a recipe app? Firebase Invites can make sure that killer lemon meringue pie recipe gets the visibility that it deserves. And because Invites is a Firebase product, it works with Firebase Analytics to let you know when a user has opened or installed an app through an invite. So be sure to check out the documentation and give Firebase Invites a try. We can't wait to see what you build.
Should I just go up? Okay. Thanks. Okay. Hi, everyone. Please settle down. Nice to see a full room. I wonder if it's because of the heat outside, or are you? Do you care about application sizes? Who cares about application sizes on Android? Lots of people. Is there anyone who doesn't care? Yeah? Okay, great. I hope I'm going to convince you that it's really important to do that. And I also hope that you especially will go to a session tomorrow that I encourage you to all go and see Anchor and others talk about building for billions. And they're going to tell you all about building apps that will work great on all kinds of devices for all kinds of markets. But today we're going to concentrate on app sizes. And if you think, why is it important anyway? Why should I care about app size? And what is app size anyway? First of all, think about this. We're here in the US, where there's Wi-Fi on every corner, in every coffee shop. We have all those all-you-can-eat data plans. We can download as much as we want. I just want you to remember there are parts of the world where people actually pay for every megabyte they download. And it's not always easy for them to install apps, to keep apps updated. And it should matter to you as developers that people install your apps, for one, and just keep them updated. And the other important thing is that people's phones not always have 16 gigs, 32 gigs of memory. So they just can't keep all the apps installed that they would want. And again, if you want users to actually use your apps, maybe you will help them a little bit by keeping your app just a little bit smaller, so they maybe will be encouraged to leave your app alone and just not uninstall it. So when I was beginning to create this presentation, I was talking with lots of developers at events, and I asked them this simple question: how big is your app? And I wonder if I ask you, just think in your head, how big is your app? Can you answer that in 5 seconds? And if you thought of a number, I'm pretty sure you thought of the raw APK size. So this is the file that is produced by Android Studio. How many people thought about that? Yeah, lots of people. And that's correct. That's a correct answer. It's technically correct, the best kind of correct. But application size is not about the file on your computer. The user doesn't really interact with the file on your hard drive that Android Studio produces. So the other important sizes we can talk about is the download size. So again, if I'm on not a very good network connection, if I have to pay for the data that I use before downloading an app, I have to actually look and think, can I afford downloading this app? Can I afford spending this much money on this many megabytes to download it? And it's not always the same as raw APK size, which we'll find out in a moment. Then there's install size. So like I mentioned, the other important metric is how much space users actually have on their devices, and how much space your app will actually take up. And again, it's not that easy. So it's not always the same as raw APK size, nor is it the download size. And I'll tell you about why in a sec. And third of all, the update size. Again, you might think people download an APK. If they want a new version, they get a new APK, right? So it must be the same as the download size, only with the new APK. Well, that's also not true. Then there's other metrics which are really, really important, like RAM footprint, how much memory your app uses, how many methods are in your app. That's really important for if you have to use multidex or not, and probably lots and lots of other metrics for app size. But we're not really going to talk about those. We're concentrating more on APK size and the 4 metrics that I mentioned in the beginning. Before we start talking about how to optimize for all those 4 scenarios, for APK size, download size, and so on, just a quick primer. Let's look at the internals, what's actually in an APK, so that we can talk about what we can do with it and what we cannot do. And an APK is really just a zip archive. You probably all know that. If you unpack it to a folder or just inspect it in a archive viewer, first of all, you will find the application code. So there's bytecode, there's the dex files. There may be 1 classes dex, there may be more if you're using multidex. That's pretty much all your code that you wrote, all your libraries that you imported, and so on and so on. There's also native code, so native libraries compiled for a specific CPU architecture or ABI. That resides in the libs folder. And under libs, you have all these architectures. So if you have an ARM device, it needs ARM SO files, and so on and so on. Then resources, a pretty big part of your app, usually. And resources are really divided into 2 categories. So in the rest folder, we have all kinds of resources like drawables, PNGs, JPEG files, layouts, and so on and so on. And there's also another file, resources.arsc, which contains mostly styles, identifiers, and strings. And also, this file can get pretty big. So we'll talk about how to reduce that size as well. And then there's all kinds of miscellaneous stuff like other assets, like you put any file that you just use as a binary stream, anything that's not an Android resource. So if you want to have like a font bundle with your app or some game data, some textures, you just put it in in assets and you can open it later in your app. Then there's the meta.inf folder. This contains the app's APK signature. And I'm going to talk about that on the next slide. And then there's the Android manifest. So when you work on Android Studio, when you actually compile your app, Android Studio gets all pieces of information from all the libraries you use, from your own app, and it creates this combined merged Android manifest XML that it finally puts in the APK. And one important thing is, if you actually do what I said and extract the APK and try to inspect this file, you will find that it's in another format. It's actually in a binary compressed format, so you will not be able to inspect it easily. And I will talk about how to do that in a sec. So APK signing. Like I said, there's a whole folder that contains the cryptographic signature for your APK. We all know that's important so that Android can verify that the app was produced by you, it comes from you, it's, it can install it securely. And how APK signing v1 works. The important part to know here is that Android, actually, when verifying the signature, it goes file by file on every file in your archive and actually decompresses the file, then goes over the full file content, checks it against the signature, and if it matches, then the signature verifies it's correct. So one thing that one cool thing that we can do about this is changing compression levels on files is actually allowed. So if you have an APK, if it's cryptographically signed, you can actually change compression on a file inside the archive, and that will not invalidate the signature. Another thing that's useful to know is that removing any files is not allowed. So if you remove a file, you will have to re-sign your app. And after making any changes to the archive, to the APK, remember that you have to run zip-align after any changes. So even if you change something, then sign the image, sign the APK, then you always have to run zip-align. So just a few rules. But we have this new APK signing scheme, version 2 in Android N, which changes things a little bit. So it makes it a little bit difficult, or let's say impossible, to actually change anything inside the archive. It's more secure. The signature is computed over all the bytes in the APK, so all the content in the APK, and then it's appended towards the end of the zip archive. Not exactly at the end of the file, but just before the zip archive central directory. And like I said, no changes are allowed. And what's more, zip-align has to be run before the v2 signing. So that complicates things a little bit. Fortunately, Android Studio has made some improvements, and I'm going to tell you why. But why am I talking about all this? Why did I not go straight to the point and tell you, what you can do to make your APK smaller? I think it's very important to understand those things, to understand the role of every file in this archive. For example, I said that resources.arc can get pretty big. And so lots of developers notice that. They notice that this file in their app takes even 10 megabytes, 15 megabytes. And they also notice that it's uncompressed. So if you create an APK in Android Studio, and you look at the compression level of all the files, you will see that this file is actually uncompressed. So why does it waste all this space? I just said that it mostly contains strings, right? So text is compressible. So many developers, using this knowledge of APK signing v1, they go and compress this file, and problem fixed. APK is smaller. But what I want you to understand from this talk and bring as a takeaway from this talk is some optimizations are actually counterintuitive, and not always actually reducing APK size will help in the long run. So for example, in this case, compressing resources ARC is actually a very bad idea. You should leave it as is. It's optimized for runtime, for running your app, so the framework could actually memory map the file. It doesn't have to decompress it when you launch your app. Even worse, think about that. If the launcher has to read something from this file from your app, and the launcher has to read your application name. If this file were compressed, then just to show your app name next to your icon, this file would have to be decompressed into memory. So that's one thing you just shouldn't do, even though you can. And we're going to talk about all these stages and what magic things happen that make it so that download size is not always the same as raw APK size, and so on and so on. So for example, Play Store serves a compressed version of your APK. So in case, for example, of this resources file, even though we keep it uncompressed, when it's actually sent to users' devices, Play Store will compress the APK beforehand, so we don't lose any bandwidth, we don't use any bytes over the network. So that's good. The only thing is, when installed on the device, the file will take up more space on the drive. But like I said, that's actually working as intended. Some cool stuff is also happening around install time. So first of all, remember how I was talking about the signatures and so on? You can't change anything inside the archive. And so because of that, whenever you install an app, the first and the most important part of what's taking up space on the device will be the raw APK itself. We cannot change it, even if it contains resources for other devices, for devices with different screen densities, with different CPU architectures. There's nothing we can do about it on the device because we have to keep the signature intact. So a little bit of space wasted. We can remedy that later. Then there was a thing that we introduced in Lollipop, and that was the new runtime called Art, which introduced ahead-of-time compilation. So whenever you install an APK, the ahead-of-time compiler will take all your DEX bytecode and actually compile it down into native code and store that on your, user partition. So again, this takes up space. This is a derivative of how big your code is. The bigger your code is, the bigger the compiled code will be. So another thing to be mindful about. One note, with N, we're again getting rid of the ahead-of-time compilation. We're using a JIT compiler. So this is not, let's say, not a concern as much on N devices and going forward. Finally, one curious thing. If you have any native libraries in your APK, they will actually get uncompressed, again, on the user partition and will take up space on the user partition. So that Android can actually load them, access them with better performance. Again, we cannot touch the APK. Even though we uncompress the native libraries, they take up more space, but we cannot remove them from the APK, so that's space wasted. And fortunately, starting with Marshmallow and above, we can remedy that, and that will be one of the techniques I will talk about later. And then there's things that happen at runtime. So if a user looks up the application size and settings and looks at the whole app size, it's not just the things that I mentioned, it's also everything you create during runtime. So databases, cached images, anything you pretty much download from the internet or generate locally. We're not going to cover that as much, but remember this is a very important part to think about too. And finally, update size. So why is the update size different than the download size? Well, I don't know if you're aware, but for many years now, Play Store has supported Delta updates, or in other words, downloading patches. How that works is, first of all, when a developer uploads a new APK on the Play Store will compute the difference, or the delta, between the old APK and the new APK. It's just basically a binary difference. It uses an algorithm to figure out which bytes are similar and how it can send only certain bytes over the network. Then the delta can be additionally compressed. And finally, the client only downloads the difference, the delta file, and reconstructs the new APK on device. So the final result is as if the user had the whole new APK, the new signature and everything, but it's just reconstructed on the device from this patch file. And one thing, we've been a little bit vague about, like I said, uses some algorithm, can be compressed, and so on. And we weren't really telling you what kind of algorithms Play uses for that. And there was a reason for it. So the Play Store team always wants to improve on that. And they've been experimenting a lot. And it wouldn't make any sense to give out this information, and then it would change the next day. But actually, let me talk a little bit about the most recent Play improvements on that field. And we have a new delta algorithms. We are using BSDiff now for computing the deltas. And we've seen some major improvements for reducing this delta size. So for example, a major update to Chrome, so like a big change from one APK to the second APK, from a certain version to a newer one, used to take 22 megs or almost 23 megs on the previous algorithms. With the new one, it's down to 13 megs. With a minor update, the difference is a little bit again, from 15 megs to 3 megs. So imagine instead of downloading, a whole tens of megabytes, a whole package of Chrome, you download only 3 megs and have a new version installed on your device. From other news, we've also introduced patching and compression for the APK expansion files. That's mostly used for games, but it's super important. That's because games usually have lots of textures, huge level files. APK expansion files can be like a gigabyte in size. Imagine if from version to version you have to download and over a gig and a gig and again a gig. Lots of bandwidth wasted, and we're now saving over a petabyte of data per day for our users thanks to that. But you know, I can talk to you developers about that. You will be happy that you have smaller update sizes and so on. But what's really important is to show the benefits to users. So starting now, Play Store will show download size instead of APK size on the Play Store. And in case of an update, users will only see the update size. So users will be more happy. They will see the benefits of all your hard work, of all the work of the Play Store people do. It's great. But Play Store is just one component, right? They can only do so much on the server side, especially with the signing that has to be left intact. So we also have some cool improvements in Android Studio 2.2, which is out in preview now. So they've been working on the whole packaging subsystem and optimizing it to create APK files that are actually better for computing those Delta updates. So first of all, they started sorting files in the archive so that things don't move around a bit, because then the algorithm, the Delta algorithms get confused and can't figure out the most optimal solution. They zero out all timestamps, zero out any empty space, like useless comments and so on. And finally, they're introducing the option to store uncompressed native code, so SO files. And I already told you about that. I will get to that later in the presentation. So what you can do if you want to actually measure if your efforts, if what Android Studio is doing any good for your update size. And I'm happy to say we finally released a tool that will help you estimate, and let me stress that, estimate the update size. Again, there may be new algorithms, there may be experiments that are going on, but this will give you a good estimate on the current algorithms and how they work for your APK. So basically, you run it against an old APK, a new APK, you see the size difference, and you can see if any changes you make sense for that. So now, moving on to the second section, which is kind of like a tips, recipes on how to actually make your APK smaller. And let's go through some of those things. And first of all, how many of you had read my articles on Medium on keeping APK size low? Some of you? OK, so let me first explain one point of contention about using Zopfli compression for APK. So in the articles, I actually wrote that you can reduce the size of your APK just by using a better compression method. It's called Zopfli. It's an algorithm that was created by Google engineers. And yes, it did make your APK smaller by a couple of %. Nothing much changed for like users. They were decompressed just as fast and so on and so on. But currently, we advise against using Zopfli for your APK. So first of all, some users did write to me saying that certain devices and certain versions of Android might have had a kind of problem with Zopfli compressed APK. Like they just threw an exception. So that's one thing. Another thing is they take an awful lot of time to compress on your computer, which, well, you don't make a release every 5 minutes, so it's not that of a big deal. But the next thing is really, really important. So like I said, the Play Store team likes experimenting with stuff. And actually using Zopfli, because it's so resource intensive and it needs so much CPU and memory to compress, it might actually, in the future, it might actually make new kinds of differential updates impossible. So if you read my articles, if you were thinking of using Zopfli, forget about it, just don't. Especially since the new packaging system in Android Studio actually experiments when compressing files in your archive, and it actually figures out the best gzip compression for the files. So that's also something new in Android Studio 2.2. Next, images. How many of you have been to Cold Session just before? Yep. So I'm just going to do a quick recap. Remember that you can always pre-optimize your images. The tools that we currently have in Android Studio in our build tools don't always do the best job of figuring out the best compression for images, the best optimizations they can make. So you are free to use external tools to pre-process images in your drawable folders. They might be a lot smaller from that. And just remember that you used to have to add these lines to your build.gradle. That's simply because, again, the packaging system had its own optimizer, and it wasn't, let's say, smart enough to figure out that if you pre-process an image, then our build tools process it again, they could actually make it a little bit bigger. So this actually disables crunching of images so that your pre-processing is left intact. I'm happy to say I've talked to the people at Android Studio, and they promised me this will be fixed for Android 2.2, so the build tools will be smart enough to figure that out. One very easy win you can have with your PNG images is actually Zoplify them. So again, this better compression algorithm called Zopli turns out it's OK for images. You can use it for PNG files. There's tools that do that for you. It's completely lossless. It doesn't change anything. The images look the same. They work as fast. And it's an easy win for file size. WebP, it's another image format developed at Google. Gives about 30% smaller image sizes than JPEGs, for example. And you can use WebP for your images again. Just remember one thing. Support for WebP was added in Android 4.0, but only to replace JPEGs or PNG images with no transparency. And that's because only Android 4.2.1 added support for new WebP formats, including lossless and transparent. So then you can replace all your PNGs. And also remember to use it server-side. This is really the biggest win, because if your app downloads a lot of images, if you know it's on Android, your server can just generate WebPs instead of JPEGs. You will send your users a lot of bandwidth, and you will save a lot of space on the device if you cache those images. If you can, on Android 5.0, of course, use vector drawables. It's a great text-based format. It compresses very well. It's just amazing for icons. If you're targeting still Android, previous versions of Android before 5.0, there's two ways you can actually use vector drawables. So for some time in Android Studio, we've had support for generating PNGs from your vector drawables. So if you put vector drawables in your drawable folder and add these lines to Android Studio, it will, during building your APK, it will actually generate those PNGs for you, for those older devices who cannot use vector drawables. And after that, we finally got vector drawable compat. So that's a more programmatic way of using it from the support library, where you can actually use vector drawables on your image views in code. It just works. Of course, there's a little bit more to it, but for that, I suggest you go to Chris Bain's session, where he will probably talk about that. And finally, shape drawables. This has been in Android since 1.0, and I think it's really underappreciated. So, vector drawables are great. You can do lots of complex shapes in vector drawables, but they're not always available, like I just said. Shape drawables, however, have been there forever, and they're great for simple shapes like button backgrounds, borders, gradients. They're super optimized, super performant. So if you can use a shape drawable, just please do. And like I said, this was a quick recap of what Colt was talking about an hour ago here on the stage. But since everything is recorded, I encourage you, those of you who haven't been able to attend the session, or those of you watching online, to go and check out this session on image compression. So that's what we can do to resources, right? But what about code? And really, with your code, with the size of your code, there's one thing I want to tell you. Use ProGuard. You will hate it, but use ProGuard. Please do. It's very easy, no, really. It's very easy to add to your build Gradle file, and then things will break. So, yeah, just add this line. There's also a new way of using the built-in shrinker in our tools. So you can, if you do minify enable true, that enables ProGuard. But you can then go and actually say use ProGuard false, and this will use our built-in shrinker. That's a little bit faster, but it doesn't do all the things that ProGuard does. So it just removes classes. It doesn't obfuscate, but it works better with instant run, for example. But anyway, whichever option you decide to use, you then have this notion of ProGuard configuration files. And by default, we have one in the SDK, which has some same defaults for any Android app. So for example, the built-in ProGuard file already has rules that keep all the setters and getters on your view so that animations work and so on, because otherwise they would be optimized away and your app would break. But then if you're not familiar with ProGuard rules, it's a really complex topic. I will not teach you that here. But you can go and look in your build folders in the Android Studio. There's actually another generated file. It's generated by AAPT. And it looks at basically at your Android manifest. It looks at your layouts. And it generates rules for your activities, for your views that you use in your layouts. And again, by looking at those and by looking at the default ProGuard file, you can learn a lot and start writing your own. And there's also another easy way. If you know that you're doing something in your code that will be optimized away because you access it by reflection, for example, there's a new way. Just add an annotation, keep, use the new build tools. ProGuard will just leave it as is. It will not be removed from your code. If you're writing libraries for other users or just libraries that are components in your app, sometimes those libraries just need their own ProGuard rules so that when someone uses them, they don't break their app. And just remember, be a good citizen. If you're writing a library, if it needs ProGuard, you can put your own ProGuard configuration inside your library, and then anyone who imports it, it will just work. But not always you can't always remove code because you don't need it. So sometimes you actually need the things you're adding to your project, but it's not easy to keep track of all the libraries that bring in other libraries and so on. So we call these transitive dependencies. And if you add just one dependency to your build Gradle file, it may bring in lots and lots of those transitive dependencies. So if you weren't aware, there's a cool command line command for Gradle that will let you see a tree of all those dependencies that you bring in with your libraries. And here, the only advice is just be aware of what you're using and what kind of libraries you're pulling in, and make the right decisions by looking at this. And if you're still not sure if what's inside your APK, what kind of classes finally make it through the ProGuard, through the optimizations, through pulling in other libraries, there's a tool that we open sourced recently called Classy Shark, and it's basically an APK explorer. So it will let you go into your DEX files. It will show you all the packages. They're great for debugging ProGuard, and you will do that a lot if you enable it for your app, let me tell you. And I really encourage you to try it. So we have ProGuard for bytecode. But if you go through this, this pain of enabling ProGuard, you actually get one more very important thing, and that's the resource shrinker. And once you have ProGuard enabled, you can get another option called shrink resources true, and that will go and figure out which resources in your app are actually referenced from the code that is left after ProGuard runs its course. And it can remove any resource that is unused in your code, which is pretty awesome. And again, it has a configuration, so you can add this really on any resource file, on any XML resource in your resource folder. Just add this tools keep or tools discard attributes, and you can make sure that if there are resources that you want to have in your APK, or if you explicitly want to remove something from your APK, that's where you configure it. So a little bit like ProGuard rules, only for resources. And then sometimes it happens that if you pull in a library, even like Google Play Services or the support library, we offer translations for many languages in those libraries. But what if you're making an app just for one market, just for one language, or just for 2 languages? If you know that there will be no users of your app, or that you don't manage translations for other languages, then you don't really need all those resources from those other libraries, like the support library, for all those other languages that you do not support. So just use resconfigs. Just put the names of the configurations or the languages in this example that you want to make it to your APK, and the rest will be simply removed. And one side note here, there's a lot of tips on Stack Overflow and other places about using this for stripping resources for other densities. That was supported a long time ago in ancient versions of our Gradle plugin. You can't really specify many densities here, so don't use it for densities unless you specify only one. But that's kind of a very advanced usage. So we have resconfigs for resources. We have shrink resources, ProGuard. But there's one very, very advanced technique that probably not many people are aware of, and that's the problem of sparse resource configs. And so if you notice that your resources.arc file is bloated, it's very big, but you don't know why, it's worth trying to figure out if maybe that is your problem. And let me try to explain that. It's not very simple. So I'm not going to teach you how the resources file format works. Let me tell you, this is a big oversimplification, but hopefully it'll get the point across. So imagine you have an app that has 5 strings. The strings are somewhere in a string pool. They take up some memory. And then you have your default config. Then you have your string, my app, hello, exit, and so on, just labels for things in your app. But then you decide, well, I'm adding a new feature to my app. It's going to be named new feature instead of feature. So you get a new string, right? But this new feature only works for version 21 and above. So you have a config. You create a new folder under your resources with v21, and you're just switching this feature to new feature in that config. Well, it should take up only space for one string, right? But it actually has to keep null entries on all the positions for other strings that you're not using in this config. So you lose a lot of space. It still takes up a lot of space, even though you're just using this to override this one string. And I know these kind of bytes, who cares about bytes? But if you think about that, if you have an app that has 3,000 strings, if you have 50 translations, and there's a lot of apps, like among the top 100 apps on the Play Store, I'm sure lots of them have even more than that. The cost of adding a single string for v21, for example, that's translated for 50 languages, would give you 600 kilobytes overhead. And that's something we can work with, especially if we can have lots of other dimensions than just v21. You can actually shrink your file a lot. But how do you know that you're doing this? It's not very easy to guess, like, which string do I remove? And we just recently open sourced a tool called ARC Blamer. It's on GitHub. I'm going to post those links later, don't worry, on the Spaces application, on our space for this talk. And basically, it's a command line tool. You run your APK through it, and you get a CSV file. You upload the CSV to Sheets or use some other program for that. And it gives you this kind of nice overview of where the resources are in your application. And if you sort that by the null entries column, then you can find which configs are the most sparse in your app. So which configs waste the most space. So in this example, if you look at the rightmost column, I can identify that the string that's called apps list is wasting almost 200 kilobytes in my app. Well, 200 kilobytes is not a lot, right? But the next one, if I remove descriptive text 1, I'm saving 1 megabyte from this file. And you can do this over and over and remove a lot of really unneeded data from your resources. And some of our apps, I want to say, remove 2.5 megs by removing just 3 strings. So that's pretty big savings. So that's that. let me just say that it really works for only big apps. If your app is not really huge with lots of configurations and so on, then probably you won't get anything from that. And finally, getting to the native libraries that I mentioned so many times already. So since Android 6.0 Marshmallow, we have this attribute that you can add on the application tag in your manifest. Extract native libs false. And basically what it does, it instructs the package installer, the system, to not copy out those SO files, the native libraries, at installation from your APK. And the other thing is, things just work. So if you're using system load library, you just don't have to think about it. The APKs will just, the SO files will just stay inside the APK. They will just work. You don't waste this space that's used for decompressing them somewhere on the user partition. But there are conditions. For this to work, the SO files have to be uncompressed in your APK. And the other thing is they must be correctly page aligned using zip align. So up until now, there was no easy way to do that using Android Studio and our tools. It was just not supported. You have to go and manually decompress those files and store them and so on. I'm happy to say that Android Studio 2.2 finally does that for you automatically. So you can enable this option in the Android manifest and see big gains. If you're worried that having an uncompressed SO files will just bloat your APK, will make it really big, that's true. Raw APK size will go up a bit. But remember, the Play Store compresses data anyway, so the download size will not suffer. And the delta sizes will actually be smaller. That's because the BSDiff algorithm will be able to figure out smaller deltas for uncompressed SO files. So win-win-win. Just a little bit bigger file, but we can live with that. And then I mentioned before that there's not much we can do on the device with resources that are not targeted at your device's, let's say, screen density. And if you produce a fat APK, if the resources are all there, there's not really much we can do about that, unless you actually split your APK into many smaller APKs targeted at those devices. And Android Studio supports producing two kinds of split APKs. One of them is density-based, so you can actually, during your compilation, you get smaller files with resources targeted at specific screen densities. Then you can then upload to Play Store and use the multi-APK feature to serve them only to certain devices. And then there's the ABI-based multi-APK. So again, if you have native libraries for all kinds of CPU architectures, that will usually be really big, a really big portion of your APK. So again, you can split those. You can have multiple APKs that you can upload to Play Store, and the users with devices with a certain CPU architecture will get only this file that's suited for their device. The only thing you have to remember is every APK has to have a different version code. So there's some scripts that you need to add to your build APK to make that work. I really encourage you to go and see my articles on Medium where I have the necessary snippets. There's really no time today on this session to go through all the code variants for that. And example density split savings, I just took our Topeka sample app. It's really image heavy. So again, results may vary, but the original FAT APK was 3.5 megs. And then if I split that for different densities, it's almost 2.5 megs saving for everyone. And then you can do a lot more. You can do custom multi-APK. You can split things by min-SDK version. So we have, if you have some features that only work for 21 and above, maybe it's better to start thinking about splitting those up. That's pretty advanced stuff, really. So not everyone wants to do that. Then for games, you split by texture formats. You don't have to ship all textures to every device. You can recreate density and ABI splits using variants in Android Studio and customize it even more. And then for games mostly, you will use APK expansion files to put all this stuff that you can't fit into the APK to a separate file that will be downloaded from Android Studio. And here's an example of this file, of a build Gradle file that kind of recreates the splits using multi-APK. Again, I encourage you to look at my Medium articles, and this will be explained there. better. So what's next? Go through my articles, go through the tools that we have, and since we have only 3 minutes left, let me just mention that some of the tools that I mentioned during this talk, we are actually building those into Android Studio. So you might have heard at the keynote that there's a new APK analyzer in Android Studio. So I'm happy to say you will be able to download that now and play with it. And what this actually does, it shows you the compressed size of your APK. It shows you the compressed sizes of every resource inside your APK. You can browse classes in your DEX files. You can browse resources, a little bit like ARC Blamer. And then you can also look at Android manifest XML as it is in this form that is compressed in the APK. So I encourage you to try it. It's still under development. It's an early preview. If you have any feedback, if you will find you think you'd find some feature that's missing useful, please contact us, and I'm happy to hear your feedback. So thank you very much, and I will be open to questions.
Last episode, we used a decision tree as our classifier. Today, we'll add code to visualize it so we can see how it works under the hood. There are many types of classifiers you may have heard of before, things like neural nets or support vector machines. So why did we use a decision tree to start? Well, they have a very unique property. They're easy to read and understand. In fact, they're one of the few models that are interpretable, where you can understand exactly why the classifier makes a decision. That's amazingly useful in practice. To get started, I'll introduce you to a real data set we'll work with today. It's called Iris. Iris is a classic machine learning problem. In it, you want to identify what type of flower you have based on different measurements, like the length and width of the petal. The data set includes 3 different types of flowers. They're all species of iris: Setosa, versicolor, and virginica. Scrolling down, you can see we're given 50 examples of each type, so 150 examples total. Notice there are 4 features that are used to describe each example. These are the length and width of the sepal and petal. And just like in our apples and oranges problem, the first 4 columns give the features, and the last column gives the labels, which is the type of flower in each row. Our goal is to use this dataset to train a classifier. Then we can use that classifier to predict what species of flower we have if we're given a new flower that we've never seen before. Knowing how to work with an existing dataset is a good skill, so let's import Iris into scikit-learn and see what it looks like in code. Conveniently, the friendly folks at Scikit provided a bunch of sample datasets, including Iris, as well as utilities to make them easy to import. We can import Iris into our code like this. The dataset includes both the table from Wikipedia as well as some metadata. The metadata tells you the names of the features and the names of different types of flowers. The features and examples themselves are contained in the data variable. For example, if I print out the first entry, you can see the measurements for this flower. These index to the feature names, so the first value refers to the sepal length and the second to sepal width, and so on. The target variable contains the labels. Likewise, these index to the target names. Let's print out the first one. A label of 0 means it's a Setosa. If you look at the table from Wikipedia, you'll notice that we just printed out the first row. Now, both the data and target variables have 150 entries. If you want, you can iterate over them to print out the entire dataset like this. Now that we know how to work with the dataset, we're ready to train a classifier. But before we do that, first we need to split up the data. I'm going to remove several of the examples and put them aside for later. We'll call the examples I'm putting aside our testing data. We'll keep these separate from our training data. And later on, we'll use our testing examples to test how accurate the classifier is on data it's never seen before. Testing is actually a really important part of doing machine learning well in practice, and we'll cover it in more detail in a future episode. Just for this exercise, I'll remove one example of each type of flower. And as it happens, the data set is ordered so the first setosa is at index 0, and the first versicolor is at 50, and so on. The syntax looks a little bit complicated, but all I'm doing is removing 3 entries from the data and target variables. Then I'll create 2 new sets of variables, one for training and one for testing. Training will have the majority of our data, and testing will have just the examples I removed. Now, just as before, we can create a decision tree classifier and train it on our training data. Before we visualize it, let's use the tree to classify our testing data. We know we have 1 flower of each type, and we can print out the labels we expect. Now let's see what the tree predicts. We'll give it the features for our testing data, and we'll get back labels. You can see the predicted labels match our testing data. That means it got them all right. Now keep in mind this was a very simple test, and we'll go into more detail down the road. Now let's visualize the tree so we can see how the classifier works. To do that, I'm going to copy-paste some code in from Scikit's tutorials. And because this code is for visualization and not machine learning concepts, I won't cover the details here. Note that I'm combining the code from these 2 examples to create an easy-to-read PDF. I can run our script and open up the PDF, and we can see the tree. To use it to classify data, you start by reading from the top. Each node asks a yes or no question about one of the features. For example, this node asks if the petal width is less than 0.8 centimeters. If it's true for the example you're classifying, go left, otherwise go right. Now let's use this tree to classify an example from our testing data. Here are the features and label for our first testing flower. Remember, you can find the feature names by looking at the metadata. We know this flower is a setosa, so let's see what the tree predicts. I'll resize the windows to make this easier to see. And the first question the tree asks is whether the petal width is less than 0.8 centimeters. That's the 4th feature. The answer is true, so we proceed left. At this point, we're already at a leaf node. There are no other questions to ask, so the tree gives us a prediction, setosa, and it's right. Notice the label is 0, which indexes to that type of flower. Now let's try our second testing example. This one is a versicolor. Let's see what the tree predicts. Again, we read from the top, and this time the petal width is greater than 0.8 centimeters. The answer to the tree's question is false, so we go right. The next question the tree asks is whether the petal width is less than 1.75. It's trying to narrow it down. That's true, so we go left. Now it asks if the petal length is less than 4.95. That's true, so we go left again. And finally, the tree asks if the petal width is less than 1.65. That's true, so left it is. And now we have our prediction. It's a versicolor, and that's right again. You can try the last one on your own as an exercise, and remember the way we're using the tree is the same way it works in code. So that's how you quickly visualize and read a decision tree. There's a lot more to learn here, especially how they're built automatically from examples. We'll get to that in a future episode, but for now let's close with an essential point. Every question the tree asks must be about one of your features. That means the better your features are, the better a tree you can build. And in the next episode, we'll start looking at what makes a good feature. Thanks very much for watching, and I'll see you next time.
So constraints. They're a great way for you as a developer to deal with the ever-expanding number of screen sizes, device rotations, and new form factors like slide over in the iOS world. But one unfortunate casualty in this brave new world of alignment has been the way we animate views. See, it used to be we could go around setting a UI view's position or frame with a fun little UI view animate with duration method and watch our view scoot around the screen. Oh, that was fun. But that's harder to do in a world full of constraints. Constraints don't necessarily play nicely with a view whose frame you're setting explicitly, as you can see here. Well, that leads us to this episode's quick tip sent in by Jacob Cho, a fan of Route 85 and a software engineer at Ensemble, a mobile app developer located in beautiful Vancouver, British Columbia. Jacob notes that many iOS developers forget that in addition to the old way of animating a view's position, you can also animate constraints in iOS. Let's look at how you might do that. Here's my storyboard, and as you can see here, I've got everything set up nicely using constraints. Now to move my UI image view on and off screen, I'm going to want to change this constraint here. the one that sets my image's leading edge to the leading edge of my super view. Right now it's set to -180, so it's off screen. So first I'm going to control drag from this constraint into my view controller to make it an IB outlet of type NSLayout constraint. This allows me to access it in my code. Now I can adjust it with a standard UI view animate with duration call. In this case, I'll change the constant of the constraint from -180 to 0 so that it appears on screen, and now we can give it a try. Well, that's weird. The constant definitely changed, but what happened to my animation? Well, it turns out to get this constant to animate nicely, I need to call layout if needed on my view controller's view within this animation block. We'll give it one more try, and that's much better. I now have a constraint that I can change within an animation block, and everything animates smoothly to its final position, except in cases where I want to adjust something besides my constraint's constant. Let's take a look at another example. Here I want to adjust this center square to expand or shrink to be either twice or half the width of its neighbors. Now I could do that in theory by adjusting the multiplier on the center view's width constraint, but it turns out that changing that multiplier in code doesn't work. See, constraint multipliers are a get-only property, and Xcode will give me an error. So how do I change it? Well, the answer is I don't. Instead, I create two completely different constraints and enable or disable either one as necessary. As long as I'm still calling layout if needed in my animation block, this kind of change will still animate. Now there are two ways I can accomplish this constraint swapping. One way is to create both constraints in Interface Builder, like so. Now Xcode will complain that these are incompatible, and it's right. So first step, we'll uninstall one of them by checking this box here. Next, we'll control drag both of these constraints into our code to make them IB outlets. And then I can enable or disable these as necessary in my animation block, like this. Once again, you'll notice I make sure we're calling layout if needed in our animation block, and we end up with a nice smooth looking animation. Look at that. The other way to accomplish this would be to create a completely new constraint in code. This is useful when I don't know in advance what I'm going to want this multiplier to be, and I need to create it dynamically. So let's see that in action. This time in my animation block, I'll first remove the old constraint. Next up, I can create a new multiplier. Let's make it slightly random just for fun. Ooh, hey, that is fun. Okay, next I'll create a brand new constraint with this new multiplier and assign it to my center view width property. And then I can add it back in again to my view. Finally, I call layout if needed on the super view in the animation block, and I once again have some nicely animating views that use this new constraint that I've created. And because this is all done using constraints, you'll notice this works as intended on an iPhone in landscape mode, or even, say, a slide over view on an iPad. And once you understand that this trick simply involves removing an old constraint and adding a new one, you might discover a whole new world of animation is available to you simply by turning on and off various constraints. For example, on this screen, I can change all my views to be either left aligned or right aligned, simply by adding and removing two different groups of constraints, and then calling our now familiar layout if needed method. Pretty neat, huh? Oh, by the way, one fun little quirk about all this, if you add your new constraints before you remove the old ones, iOS will complain about all the incompatible constraints it has to deal with in those few milliseconds. So always make sure you remove the old ones first before adding the new ones. So thanks to Jacob for the quick tip. Jacob, you're going to get a very stylish Google t-shirt in the mail. But hang on, we're not done yet. You see, now that you know all about constraint animation, I have a couple more quick tips from one of Google's engineers about more efficient ways to implement it. So follow me on to the next video, because we're not done learning just yet. Click here, and otherwise, I'll see you on Route 85. Bye.
People love to use different mobile devices in different ways that suit their situation and lifestyle. Michael uses a phone to play games on the go, while Tony enjoys using a large tablet as he relaxes on the sofa. And Jen carries a small tablet in her purse for reading on the bus. But they all want to use your app on the devices they prefer. So you'll want to make sure they each have a great experience, regardless of screen size, OS version, and the features of the app they use the most. It can be taxing to test each one of these situations so that all your users can be happy. We know you'd rather not have to buy and store stacks of devices and test your app in all these circumstances. That's why we built Firebase Test Lab for Android to make it easy and affordable for you to test your app with a variety of devices and be sure it works great for all your users. Our device lab, hosted in the cloud, offers a variety of physical devices ready to test your app. The selection of devices is always growing, so your tests will stay current with the latest hardware and operating systems. The easiest way to use Firebase Test Lab is to run a robo-test. This is an intelligent, automated test that crawls your app to discover and exercise its features. You won't need to write any additional code to make use of a robo-test. For more advanced testing, you can also script the interactions with your app to simulate specific use cases and verify that everything works as expected. Test results include a detailed report for each device used, including screenshots, device logs, and any crashes that may have occurred during the test. This allows you to verify that your app is working correctly on the variety of devices and configurations you selected. It's easy to make Firebase Test Lab a part of your daily development routine, and we have multiple ways to help you test regularly and spot errors early. First, you can use the Firebase console to upload and test your app. There is also a command line interface for testing with continuous integration servers, so you can automatically test every build. During Android development, you can deploy your app directly to Firebase Test Lab using Android Studio 2.0. And finally, in the Play Store Developer Console, there is a special automated launch test that will run for Android apps published to an alpha or beta channel. To get started using Firebase Test Lab and learn how to regularly test your app on different devices and configurations, you can start with the documentation available right here. Happy testing!
Welcome to the Googleplex. This is an incredible place with lots of great stuff being worked on every single day. Before I worked here, I always wondered what it would be like to come to the Googleplex, meet up with a Googler, and have coffee with them and just chat about what they do, how they do it, and why they do it. And today we're going to do exactly that.
Welcome to Coffee with a Googler. I'm Lawrence Moroney, and I'm here in
Hi everyone, I'm Kobe, a product manager on Google Play.
And I'm Elena, engineering manager on Google Play. We work on Play Apps developer team in London. Today we're here to tell you how you can set your app for success using some of the tools that we provide in Google Play Developer Console. We'll talk about rapid iteration and experimentation, and we'll tell you how some developers are using these services to have success on Play.
The vision of our team is to build powerful publishing tools, allowing you to launch and iterate. We believe that experimentation is the key to success. Throughout this presentation, you'll see a lot of developer feedback. And we'll start with the feedback we have from Michael Reeder, SVP Business Development at SGN, about why they released Genies and Gems Android first. The quick publishing time on Google Play is the key. You can make multiple submissions in a short time, iterating on your product. Rapid iteration and experimentation is the key to success. SGN are power users of tools like beta testing and store listing experiments. We will show you how other developers are using these tools, and we will share some best practices. SGN use our tools, and then they utilize their finding across platforms. This leads to a much more efficient soft launch process. Soft launching is a great way to make sure your app or game deliver value to your users. As a result, their worldwide launch was much more successful, and this is exactly what we have in mind when we're building those tools for you. Our goal is to help you experiment, launch, and iterate fast.
We got a similar feedback from Concrete Software, developers of PBA Bowling Challenge. They've told us that they soft launch on Android first because it allows them to iterate faster and to launch kind of in a better way. This is exactly music to our ears, exactly the feedback we like to hear, and a practice we would like to encourage.
So what are we going to talk about?
OK, so we're going to start by talking about beta testing and some of the improvements we are making to this service to make it even easier to run large beta programs and to get feedback from your users. Then we'll talk about the best way to roll out these rapid changes in a safe and controlled fashion. Then we'll go on to talk about how you can understand your users using user acquisition report and how you can optimize your user acquisition using store listing experiments. We will also talk about the importance of experimentation if you're looking to go globally and localize your app to all the global markets. And finally, we will also touch on how you can keep an eye on the performance of your app on the go using new Play Console mobile app. Throughout this session, we'll mention new features that we've launched recently or the ones that we're launching today or very soon.
OK, so let's start with beta testing. This is a great way to improve your apps and games. 60% of the top 1,000 apps on Google Play are running a beta test right now. And the goal is obviously to test your apps and games with testers and early adopters. It used to be challenging in the past to join beta, so we launched closed and open betas. With open beta, it's as simple as clicking a URL.
Did you know that there are many big apps that are running very large open beta programs? For example, Minecraft, Uber, Google Search app, and many others.
Nice. So here's a great example of a developer that is using this platform in a very correct way. Hopper, an app helping travelers make better decisions. They run an internal alpha testing and then a much larger public beta test. And you can see from their feedback, it cuts their testing and rollout time by half without adding any extra work for them or their testers. This is exactly what we had in mind when we built this model. We're making it even easier for users to discover and join beta testing. Very soon, users will be able to join beta test directly through your store listing page on Google Play. So if you run an open beta, you can just tell users, go to our page, click it there, join our beta, and give us feedback. Feedback. You used to collect feedback through various sources and had to parse a lot of information. From now on, users that are part of your beta test will be able to submit private feedback to you directly through Google Play. This feedback is private. You can see it in the Google Play Developer Console. It doesn't show to other users, and it doesn't impact your app star rating. Now, we believe that apps and games should be launched in open beta even before they go live in production. This is why soon we are going to introduce a new section on Google Play called Early Access. In this section, we will feature exciting apps and games that are still in development and haven't launched to production yet. This will allow developers, you guys, to test your apps early on with early adopters and influencers, giving you private feedback, making sure you can find product market fit earlier or fine-tune your game's KPIs. In our first collection, we are going to introduce 28 apps and games. You can see them up here, pretty cool icons. We have, for example, ReadFeed. It's an Android-first online book club. Or we have Ava. The founder, whose parents and sisters are deaf, created this app to help deaf people and people with hearing disabilities to participate in real-life conversations. Then we have Lego, the kids and family power brand with their first ever in-house mobile game. It's a 3D Lego set. You can touch, twist, just like the brick sets we all grew up with. Now, early access is not going to be just for free-to-play. Never Alone, a gorgeous game developed by Eline Media, who researched together with the Alaska Natives, is coming to Google Play on early access. They chose early access because it's a great way to make sure they get feedback from their fans and making sure the gaming experience is a premium one. We are sure those changes that we're doing to beta testing will help you create larger beta tests, making your apps and games even more awesome.
Okay, Kobe mentioned that users will be able to give private feedback on open beta apps. I know you all know how important it is to listen to user feedback and to act on it. Recently, we have launched a number of improvements to user reviews functionality in Google Play Developer Console, allowing you to, for example, search your reviews by keyword, or, for example, to see various breakdowns of rating aggregates by a number of different dimensions, for example, device, country, app version, and so on. In addition to that, we made it possible to sign up for notifications, for email notifications, if you, when users change their review after your reply. I'm happy to announce that today we launched review analysis. These are further improvements to user reviews functionality in Google Play Developer Console, and they come in several different tools. One of them is benchmarks across a number of fixed aspects, for example, design, stability, or speed. So it basically allows you to compare how your app is doing comparing to other similar apps on these fixed aspects. In addition to this, we also launched unique topics, so analyzing all of your user reviews and trying to extract what are those specific topics that users are talking about just for your app. OK, let's talk about release management tools.
Sounds good.
Cool. So you beta tested your app, you addressed a bunch of user feedback, and now you want to launch a production. In this critical moment in time, we want to be there for you. We want to give you as much support as we can so you can roll out in a very safe and controlled fashion. One feature that I want to remind everyone of is stage rollouts. Stage rollouts allow you to roll out gradually, keeping an eye on the performance of your app so that you can halt in case of any issues. In case issues do happen, and we all know that they do, you will be able to halt, and you will only unhold if you, like, very, very specifically, if you do that action or upload a new set of APKs. And here is one power tip. When you start a stage rollout, we select a random percentage of users who become eligible for this new update. If you increase the percentage, we add more users to the randomly selected set. If you start the next stage rollout, we use a completely different seed, which means it's not always the same set of users getting less stable versions, so you don't have to worry about that. For example, you can see how developers like FTX Games use stage rollouts to confidently roll out and frequently roll out new versions of their app.
OK, so since we're talking about release management, I want to mention another feature we launched recently called time publishing. We know that you appreciate the quick publishing times available on Google Play, but we wanted to do better, meaning giving you exact control on the moment your app update goes live. With time publishing, you can make as many changes, like APK changes, store listing updates, as you wish. We batch all the changes, and they don't go live until you click the Go Live button in the Google Play Developer Console. When you click it, the changes go live within minutes. You also have a changes log showing you exactly what changes are about to go live, which is a great way to manage your release. You can see the feedback from Flare Games here, showing us how this feature is super useful for them.
OK, now let's talk about understanding visits to your store listing page in Google Play. It's very important to understand where your users are coming from. And sometime last year, we launched user acquisition funnel. This funnel allows you to see how many of visitors to your store listing page are being converted to installers, and how many of those installers are then converting to become in-app purchasers. In addition to this, you can further break down this report by, for example, user acquisition source or channel, for example, seeing whether users are coming from Play Store organically or from different channels like advertising. I'm pretty sure that, like Trulia, so far you found this report to be very useful. And since understanding where your users are coming from is so important, a couple of weeks ago we have launched another improvement to this funnel, which allows you to break it down by country. This is very important because it allows you to localize your app in a more efficient way. And to take it one step further, we're happy to announce that very soon we will be launching conversion funnel benchmarks. This will allow you to compare how your app is doing against other similar apps in terms of how efficiently it's converting users from visitors to store listing page to installers. Stay tuned. This is coming very soon. And once you see who's visiting your store listing page, you'll want to optimize, right?
Yep.
Right. OK, so let's talk about getting you some more users. To do that, we want to make sure that your store listing really shows off your app in the best possible light. And in order to get to the best store listing, we need to experiment. This is where store listing experiments come in. This feature has been a very big success with developers in the past year. More than 70% of our top developers are using the feature. We often get feedback from developers, for example, like this one from Good Game Studios, that it drives significant uplift to their conversion rate.
A big opportunity to get more installs is optimizing the top of the funnel, your store listing page. This is where users make their install decision regardless of whether they found the app through search or via deep link. Before we launched it, you had to use a bunch of workarounds and spend some budget. You can see the feedback from Rovio here, how they had to run icon test and spend budget. After we launch it, you can see their feedback about soft launching first on Google Play, as it allows them to better understand their users. Store listing experiments have been seeing great success. In the last year, you can see Flare Games up here, 30% increase in installs. eRepublic Labs running this exactly the way we thought about it, as a rapid iteration and experimentation tools. Expedia, 10% increase of installs globally, and actually their most successful test was reordering screenshots.
Here are some best practices when running store listing experiments. Create a hypothesis first. Make sure you know what you're trying to prove. Next, test one thing at a time. Run your experiments until they have reached statistical significance. We'll let you know when this has happened. Minor tweaks often have minor impact. Consider bold changes, especially if you're early in your startup's life. And finally, keep testing. The next major improvement may be still to come. Here is some great feedback we received from Jamie Berger, head of marketing at Scopely. You can see how this feature encourages testing and validation of new and bold ideas. We're very happy to see how they use this as their go-to tool for market testing and optimization.
OK, so here's some great example of the best practices in action with Instacart. We've learned that an app description that clearly shows your app value to users just works better. So you can see control versus experiment. Experiments is much clearer, plus 14% in installs. And here's a bunch of great examples from Concrete Software. Sometimes you just get lucky. They run an icon test for NHL, hockey, target smash, plus 70% installs. Boom. It's great, right? But sometimes you actually need to launch, iterate, and experiment a lot. So with PBA Bowling Challenge, they ran a series of experiments, and every icon that you see here represents a complete series of experiments. They also iterated on their description, screenshots, and their order, leading to a compound effect of 63%. This is incredible. Now let's see an example from Mixi, a leading game developer from Japan, that will show us how a leading game developer thinks about localization and experimentation. When Mixi wanted to take their big hit, Monster Strike, to the US, they ran a series of experiments. They tested the icon, the screenshots, the description, and the video. In this chart, you can see how they run the experiments methodically and scientifically, leading to a compound effect of 68% in installs. Store listing experiment helped Mixi understand the difference in taste and flavor between users in the US and users in Japan, and help them localize their games much better. And here's the feedback we got from their X-Flag Studio team. This feedback makes us really excited, as our mission is to help you test directly on our platform.
We want you to experiment, we want you to iterate, and we want you to do this fast. This is why I'm happy to announce that last week we launched multiple concurrent localized store listing experiments. We want you to go globally faster and have better tools to test localized versions of your store listing. You can now run up to 5 experiments with different languages at the same time.
Awesome. So you're talking about making things faster, right?
Indeed.
One thing that is not fast today is making price changes in the developer console. This really sucks, actually. Because lots of people have the same price point to many in our products or paid apps. So what are we going to do about that?
I'm very glad you asked, Kobe. We want to make this faster as well. We want to make pricing faster as well. So I'm also happy to announce that earlier this week we have launched pricing templates. With pricing templates, you can define prices across all of the market that Google Play supports. Did you guys know that there are 70 such markets now? Yeah. Once you create a template, you can link it to as many paid apps or in-app products as you want. If you make a change to template, it gets propagated to all of the apps. So, for example, if you're like Toca Boca Games and selling multiple titles at, let's say, $2.99, you only need to make changes to your template once, and it will be propagated to all of your apps. If you're like Wooga, selling in-app products and multiple price points, for example, $1.99, $4.99, and $9.99, you only need to maintain 3 templates. And instead of manually making changes to tens or hundreds of individual pricing points in multiple different currencies. Liking this feedback we got from Toca Boca, we hope pricing templates will help you move faster and get successful.
OK, so it's important for us you're also able to localize your price better. This is why we also launched round pricing. With round pricing, we're not, like we used to do, just converting the price using today's exchange rate. We also apply locally relevant country-specific rounding rules. So a price like 9.73 euros become 9.99 euros. A price like 196 Japanese yen simply becomes 200 Japanese yen. And 25,235 Indonesian rupee simply becomes 25,000 Indonesian rupee. We are sure that this change, like the feedback you see here from Wooga, will help you streamline your pricing structures and make your businesses even better. Now, while we're helping you make price changes faster with templates and more locally relevant with rounding, we're keeping your ability to tweak the prices manually in the developer console. We know that this is important for you when you run short-time promotion or try new pricing strategies. We are sure that the new changes we are making to pricing will help you go globally faster.
OK, last but not least, finally we have a mobile app for Google Play Developer Console. We have to admit it took us a while, it took us much longer than it took all of you guys, but we've made it. And we can tell you this app stuff is pretty sweet. We really like it now. Our new app allows you to follow your app's performance on the go and to do time-critical changes wherever you are. When you're rapidly iterating, you need a power tool that's in your pocket at all times, and we've built Play Console app exactly with those use cases in mind. Whether you want to quickly reply to user review or show off performance of your app to a venture capitalist, Play Console app should be there to support you. Regarding an initial feature set, obviously you can track installs and uninstalls, and you can break them down by a number of dimensions like app version, country, device, and so on. You can also track your crash reports, including hourly data and full stack traces. You can also see ratings and user reviews, and you can reply to user reviews. You can also track the state of your release. For example, is it in beta testing, is it in stage rollout, or has it reached prod yet? Oh, and one more thing, you can obviously get push notifications. Everyone loves those. When there are certain important changes to your app, for example, when your app updates go live. If you haven't installed the app yet, please do. If you're still not convinced, please come to Play Sandbox. We would love to convince you. And if you have any feedback, send it to us. We intend to listen and add more functionality in the next couple of versions.
OK, so today we spoke about launching, experimenting, and iterating on Google Play. With the new changes we're going to introduce to beta test, it will become easier for users to discover and join your beta programs, and for you to build bigger, larger beta audiences and improve your apps and games. Users will be able to send you private feedback that only you can see in the developer console. The new early access section will feature exciting apps and games that are still in development. We also spoke about better understanding your users with our new mobile apps that Milena just mentioned, and a bunch of enhancements, such as benchmark, to the user acquisition report. Finally, we spoke about making things faster with multiple localized store listing experiments and price templates, as well as making prices more locally relevant with rounding. We are really excited to getting developer feedback, like the one you see here from Scott Rubin, SVP of Business Development at Roblox, telling us how features like store listing experiments encourage them to launch their next major update on Android first. We hope that the tools we're building will encourage you to continue to launching and iterating on our platform. We will continue to help building more powerful publishing tools, allowing you to experiment, iterate, and make your apps and games even more awesome. Thank you.
Thank you. Now I would like to invite to the stage Larissa and Aaron.
Thank you.
Thanks, Melina and Kobe. That was an amazing overview of all of the cool stuff launching in the developer console. You can see that Aaron and I are really excited about this talk today, so much so that we decided to dress the part. How you doing there, Indy? My name's Larissa, and I lead business development with the apps team at Google Play. My team and I work with developers to help them build great apps and successful businesses on the platform.
And I'm Aaron. I lead search and discovery on Play. My team is focused on making sure users find great apps.
As much as I love short round, I'm going to take the hat off so I can see you guys. So I talk to developers all the time, and understanding how store discovery works always comes up as an important topic. We know that it can feel difficult to break through the noise and to help users find your app at exactly the right time. More apps are being uploaded to the store every day, making it even harder to break through. And studies show that more users are using the same set of apps over and over again instead of downloading new ones. One theory is that app fatigue is driving this. But what if it's that users simply can't find all the great apps that are out there? And it's not only apps that are growing. The entire Android ecosystem is growing incredibly fast. You heard some of these numbers this morning. The one we're going to talk about here is 1 billion monthly store users. Out of that huge audience, we want to help you find the best users for your app. So that's why you're all here. Today, we're going to walk through how we can work together to improve app discovery in the Play Store. There are a lot of important elements that contribute to discovery, and some of which you've already heard about. But we're going to touch on a few of them again, because they're that important and because they directly contribute to discovery. We've narrowed them down to the most critical, and we're going to go through each of them. Build something great, listen to your users, optimize your presence, and expand your reach. And then we're going to share some insights about how the discovery mechanisms in the store actually work, some of which we've never shared before.
So as Larissa mentioned, it all starts with building something great. We want users to find the apps they will love. So 1/4 of installed apps are used only once. Wow, that's scarier than a pit of snakes.
All right, Aaron, let's tone it back.
Anyways, I promise no more. So this is why we want to start with building something great. So based on some internal analysis, we found that permissions, footprint, and design were all key components when it came to a user's perception of a great app. So starting with permissions. Excessive permissions can actually deter a user from installing your app in the first place. It's important to remember, if you don't need it, don't ask for it. Users may be wary of installing apps where the permissions don't seem to align with the app functionality. For example, why does a child's game need to access my phone's call logs? Second is footprint. Some users may be scared off by the footprint of your app. These users may be on poor internet connections or have limited phone memory. This is especially true in emerging markets where there are both phone and network limitations. So it's helpful to be mindful of SDK compatibility, APK size, and memory usage. Sometimes less is more. Third is design. So the user has installed your app. Now you want to ensure a great experience. So remember to limit the cognitive load. A well-designed app is intuitive and consistent and does not require a user to hunt, guess, remember, or otherwise strain their brains trying to figure out how to interact with your app. One tangible solution for making a highly usable app is implementing Google's design spec, known as material design. Here are 2 examples of apps that invested more in quality by adopting material design, which led to the benefit of more user engagement. It's pretty impressive, for example, that Trello saw 41% increase in activity per session by implementing material design. So you can do your best to build a great app, but how can you be sure it's actually great? More than half of poor user reviews are quality related, and a third of those are just about bugs and crashes. It can be difficult to get it right in the first iteration, so we recommend following the earlier advice of Milena and Kobe and using beta testing and staged rollouts to ensure that your app is great when it launches. So we've covered building and launching a great app. Now, just because your app is launched, it doesn't mean you need to stop engaging with your users. Listening to your users is important for continued success, and I'm going to explain why. You have a unique opportunity in Android to engage with your users directly by replying to the reviews via the developer console, and building an even more loved app as a result. One example is Aviary, who created a dialogue with their users by engaging with feedback. This responsiveness led to a 50% of reviewers revising their scores higher. It's crazy, right? User feedback can help make your app better, leading to higher ratings and a boost in discovery opportunities.
So after building a great app and listening to your users, it's important to create a Play Store listing that quickly and accurately reflects what your app is about. You're all familiar with the different elements of your listing. These really require some thoughtful attention. We've provided multiple ways for you to communicate the value of your app, and it's up to you to ensure they capture the most important and interesting information. And each of them, from the title to the description to the images, provide metadata that help us understand what your app does and who's most likely to use it. It sounds easy, but no one gets it right the first time. And this is why we created store listing experiments, to help you refine each of these elements. You already heard from Kobe and Milena about how these have helped developers over the last year. And the stat that 70% of top developers are using experiments is really incredible. Developers of all sizes are seeing real impact. And iteration is key for store listing experiments. In this example from Rovio, they focused on the icon and finding which one would most impact conversions. Here are 12 different treatments they explored with various outcomes. And they kept iterating. This is what we see from developers who are finding the most success. They continue to test and refine and understand user preferences. Ultimately, Rovio saw significant uplift as a result of their experiments. And back to discovery. Higher conversion rates from your listing to installs are an important signal, and they help us understand when a user has successfully gone from searching for an app to finding one that they think they'll love. So now you've built a great app, you've implemented important feedback, and you have a strong Play Store presence. What's next? There are different opportunities to expand your reach, depending on the type of app you have and the type of experiences that your users are looking for. Going global and finding audiences in new markets is a strategy that's worked extremely well for many developers. So we're going to explore a few tips and tools that can help you find success in new markets. So earlier we talked about the massive reach of Android. We've actually looked at the growth rates of apps that are available globally and those that are only available in specific markets. Global apps grew 2.4 times faster than non-global apps. Now, this makes intuitive sense. If you're in more markets, you have a larger addressable audience. But the data really proves it out. There are a few specific things to consider when you're planning to localize your app. First, you should use the Dev Console reports that we talked about to understand where new user bases are growing and prioritize localizing for those markets. Second, don't just translate, actually localize. This means ensure that you're culturally aware of local market expectations and be ready to support your new users. Last, always be prepared to test and iterate. New users means new feedback. A developer who did incredibly well with this is 1Password. They localized their store description, their screenshots, the content, and the messaging inside their app. And we looked at those signals to understand when the app was ready to be shown to local users. For 1Password, the investment really paid off. After 2 weeks of work, they saw 100x install growth in Korea. It was really pretty incredible. By focusing on local market users, it made a real difference, And in most cases, it's worth the effort if your plan is to grow through market expansion. And we have powerful tools to help, like the localization checklist, access to translation services, and the new pricing features that Kobe shared. So, we've reviewed the most important ways that you can directly affect the discoverability of your app, and some key actions that you can take right away. For Build Something Great, limit permissions and focus on beautiful design. Listen to your users. Feedback is a gift. Use it to get better. Optimize your presence. Experiment your way to improve conversions. And expand your reach. Go global and localize. We've also mentioned that all of these impact discovery within the store. So let's unpack how the store actually works and why each of these elements matter.
Uh-oh. There we go. I'm back. Great. So how are users actually discovering apps in Play? And what matters to those discovery mechanisms? So let's start with how users are actually finding apps today. The top discovery channels on Play are number 1, Play Search, 2, Recommendations, 3, Top Charts. So starting with search, about half of searches are specifically for an app title. This is where it's especially important when naming your app to be unique, keep it short, and make sure that it is not easily confused with a similarly named app. A well-named app also has the benefit of appearing within Google Play Search Suggest, which makes it even easier for users to find your app. By using Google Play Search Suggest, they don't even need to type in the full name to find the app. Half of searches are also by category or keyword. This is where it's important to make sure you select the right app category. Also, when you're writing the description of your app, it's great and important to be thorough and complete, making sure to include key functionality and features. You may have noticed there's actually a third way that an app can appear within given search results, and this is ads. Play Search ads are already part of AdWords app ad install campaigns and provide an additional placement within Play Search. So recommendations. Whether on the homepage or right after a user installs an app, Google Play recommends apps personalized for each user. Although there are a lot of components that go into those smarts, I just want to highlight a few for you today. These include metadata, app quality, user store activity, and web knowledge.
So charts are a common way for both new and returning users to gain a quick understanding of which apps are popular in the store and which apps are on their way to becoming popular. So we're going to share some insight into how these charts are put together with specific details on key components. Top free and top paid charts are primarily determined by installs within the last 7 days. We've kept this timeline fairly short because we want the charts to stay fresh and interesting week over week. Top new free and top new paid also look back at installs over the previous 7 days, but they're biased towards new apps, those that have launched on the store in the previous 30 days. This is important to make sure the charts aren't dominated by established titles. We want to help users find new and interesting apps wherever they look for them. Trending, on the other hand, identifies fast risers that have the potential to make it onto the top charts. Typically, this means that their installs have seen accelerated growth over the previous 30 days, but their absolute installs might not be as large as those on the other top charts. And finally, top grossing uses the same 7-day trailing approach, but is instead determined by spend. And of course, we're always tuning our algorithms to produce the best user experience. So these are subject to change. But hopefully, you have a better sense of what drives placement in the top charts and how we look at user preference to determine which apps to surface. Featuring. Everybody loves featuring. So we define featuring to mean the collections that appear across the store, either manually curated or algorithmically generated. Quality is the key driver for inclusion, and that's why we spent the first half of this talk focused on tools and strategies to help drive important quality signals. In addition to quality, we also want to surface trending apps to keep the store fresh, and we definitely want users to find apps that are using the latest Android features, things that truly make their experience and their phone special. If you meet the necessary quality bar, your app is eligible for appearing in certain collections where it makes contextual sense, fits a category or a topic, or where users have installed similar apps. With an even higher expectation of quality, we have collections showcasing new and updated apps, so users know they're getting great experiences that are hot off the presses. For seasonal collections and special promotions, our BD and merchandising teams work together to identify which apps to include. And we also use a healthy dose of machine learning to scale our efforts across categories and markets. It's important to note that within each of these collections, the recommendations engine helps determine which users see which apps. The most important thing is not that millions of users see your app, it's that millions of the right users see your app and go on to install it.
So now that we've revealed the holy grail of app discovery, we want to leave you with 4 recommendations that you can do right now. Number one, for building a great app, we recommend reviewing Android's design principles. Does your app measure up? 2, for listening to your users, we recommend addressing user feedback, especially when it comes to bugs. Squash those bugs. Number 3, for optimizing your presence, why not try a store listing experiment? And finally, number 4, for expanding your reach, we recommend reviewing the market report in the developer console. So that's our talk for today. We're so excited to have you all here. We know we shared a lot of content with you, but the great news is that you can find everything you need in our new app, Playbook by Google Play. It replaces the business guide that some of you have seen called The Secrets to App Success on Google Play. There are a ton of great features, but it's brand new, so we would love your feedback. If you get a moment, please hop over to the Google Play Store and try it out. And of course, we want to leave you with a few helpful links. And again, thank you so much for coming from all of us.
Thank you. Okay. Cue the music.
That's necessary. Instead, your app simply tells GCM that you're interested in subscribing to, say, the weather 94043 topic. Then, next time there's rain in California, for us that counts as extreme weather.
Oh my gosh, there's something coming down from the sky. I don't know if it's water or if it's acid. I can't go out. I don't know how to drive anymore.
Yeah, that seems about right. So yeah, with topics, your server simply tells GCM to send notifications to all devices subscribed to the weather 94043 topic. And I will get notified along with all other devices subscribed to that topic. So there's no database required. Go ahead and throw it out. Oh, as long as you weren't using it for anything else, I guess. I probably should have mentioned that earlier. GCM has other useful features too, like upstream messaging, which allows your app to communicate to your server through GCM. This can be helpful in cases where you might want some lightweight communication from your clients to your server, but don't feel like dealing with the hassle of setting up and maintaining a full-blown server open to the entire world. Or read receipts, where in some, but not all situations, you can be notified that a user has received your message, something you can't normally do through APNS alone. Oh, and in case you're wondering, all this is free, as in please send us $0, and it's using much of the same infrastructure that Google uses for its own apps, so it'll probably scale for yours. So there's a lot to learn when it comes to notifications, and I encourage you to get started here with our Google Cloud Messaging documentation for iOS. We also have a couple of sample applications for you to look at. There's Friendly Ping, our cross-platform chat app powered entirely through Google Cloud Messaging, as well as the GCM Playground, which lets you easily experiment with sending calls through the GCM service. And keep watching Route 85. Maybe you'll see another Google Cloud Messaging video pop up in the future. If only we had some way of letting you know when that happened. Well, I'm stumped. Consider the simple URL. A few years ago, these were pretty straightforward. You clicked on one, and 9 times out of 10, you went to a web page. Then things changed. People started using their mobile devices for, well, everything. And these devices in turn started supporting the idea of deep links. Click on one of these deep links and it could take you not just anywhere on the web, but anywhere in an app as well. So you could use a deep link to point directly to a specific restaurant inside a reservation app, or give your new customers a personalized welcome based on the link that brought them to your app in the first place. At least, that's how they worked in theory. In practice, deep linking had issues. The same link wouldn't necessarily work on an iOS or Android device, and they behave very differently, or didn't work at all, for users who didn't have your app installed. And for people who did install your app through a deep link, all of that great link info was typically lost during the installation process, leaving your personalized warm welcome out in the cold. So while deep links were great in theory, their uses were a little more limited in practice. Enter Firebase Dynamic Links. Firebase Dynamic Links are deep links that work the way you want them to. So you can create one single link that behaves one way on iOS, another on Android, and even a third on a desktop browser, and it will take you to a place that's appropriate to that platform. You can also set up dynamic links to change their behavior depending on whether or not your user has your app installed. For users who don't have your app installed, maybe you send them to your website, maybe you take them to the Play Store, or maybe you show them an interstitial describing the benefits of your app before you take them to the App Store for a smoother transition. More importantly, these links can survive the App Store installation process. So if your user installs your app when clicking on a dynamic link, all of that information is still available to you when your user opens up your app for the first time. So what does this mean? It means you can use dynamic links the way you've always wanted to use deep links. You can use them in marketing campaigns, from email to social media to banner ads to, heck, even QR codes. And in addition to install attribution tracking, the kind that lets you know which campaigns are getting you the highest quality users, you can also give your users a customized first-time experience based on the campaign that brought them there. So if a user installs your music app because you showed them an ad for classical music, you can make sure your app takes them right to Chopin's latest hits when they first open it up. Dynamic links are great for sharing too. Your users can use them to share recipes, links to their favorite level in your game, or even coupon codes. In fact, dynamic links are the technology that powers Firebase Invites. And because dynamic links are a Firebase product, you can see their stats directly through the Firebase console. Find out how many people clicked on a link, or use Firebase Analytics to find out which of your users first opened your app through a particular link. To find out more about dynamic links, check out the documentation here and give them a try. And deep link away.
Bitcoin represents a way to transfer money anonymously and at almost no cost. And since it's an arbitrary currency with no nationality attached to it, you're free to exchange it with anyone in the world. What is money? Resources are limited, and they hold explicit value to people. Most resources are physical, and such needed to be traded in a physical form: diamonds, gold coins, chickens, or bikes. At some point, it becomes too difficult to physically transact those objects, and it's easier to agree, collectively, on the value of cash instead of gold. As we know today, this has many advantages. Credit cards and the modern banking basically gave us another abstraction layer on top of cash. There is a centralized system which defines who owns what resources. All of these trades are made virtually. This is the backbone of why Bitcoin is a valid idea. What is Bitcoin? Bitcoin is decentralized, anonymous, digital-only currency that recently received public attention. Bitcoin was originally developed in 2008. Like in any good mystery, someone using the alias Satoshi Nakamoto published a paper describing how Bitcoin could work. There's a very interesting story about this guy too. He must be very smart, but he never came forward to claim ownership or any part of the revenue. Just 1 year later, in 2009, Bitcoin started being traded. Where do they come from? Think about gold. You could buy it or mine it, and it's the same concept with Bitcoin. You do this by using your computer to hunt for 64-digit numbers. By having your computer repeatedly solve complex mathematical puzzles, you're competing with other miners to generate the number that the Bitcoin network is looking for. If your computer generates it first,
you receive bitcoins. The Bitcoin system is programmed to generate a fixed number of bitcoins per unit of computing time. It is also self-sustaining, coded to prevent inflation, and encrypted to prevent anyone from disrupting its code. In the year 2140, the total number of bitcoins in circulation will be capped at 21 million. So how much is a bitcoin worth today? You'll need to Google it. Just type Bitcoin in US dollar, for example. You could also check it out at priv.com. Why are they anonymous? Bitcoin are pseudo-anonymous because they are built upon this centralized system. The bitcoins themselves are anonymous. The wallets are not. Here is why. The base algorithm creates anonymity, but as the recent court cases show, if your Bitcoin wallet is identified and attached to a person, then someone can go through and track every transaction you've made. Bitcoins exist entirely on their own because there's no central infrastructure to shut down. You are identified by nothing more than your Bitcoin wallet address, a string of randomized letters and numbers. There are absolutely no identifying characteristic beyond that. For the paranoid dude, you can simply create a new wallet for each transaction. Here are some interesting startups that push the technology forward. We are still in the initial phase of Bitcoins, and there are many challenges and opportunities ahead. Exchanges, wallets, merchant services, security, and more. But this is something for another episode. Until next time, eat your vegetables and listen to your partners.
One word that's the bane of both the novice and expert programmer alike: threads. I'm Joanna Smith, and threading can be one of the greatest perf improvements you make, but it will also likely drive you crazy. Tom Sawyer illustrated threading perfectly a long time ago when he needed to paint that fence, because when you've got a large chunk of work to do and it's the same work over and over again, you call on some friends to get it done quickly. So for computations that are taking a long time, consider calling in reinforcements with threads. By allowing multiple threads of execution to operate on your dataset in parallel, you reduce the overall time required to complete the task. With Android, threading becomes especially important because the entire app runs on the main thread, which is also called the UI thread because it updates the UI. And when the UI stops responding, users stop using your app. So, when you want to perform some complex action in response to a button being pushed, for example, you'll want to move that off the main thread until it is finished so that the user can continue to interact with your app. Because there are few things worse than the dreaded application not responding dialog. However, integrating threads into your system is not for the faint of heart. You're going to have to rethink your entire approach to computational complexity and to your memory model in order to properly integrate threads. So, to avoid the rabbit hole, take advantage of the Android framework, which has been built to help you out. Careful thought and planning about your app's structure and flow will enable you to determine whether a thread should affect the UI or be entirely hidden. APIs like Async Task and Thread both help you manage the work and keep your app from hanging, but Async Task will also allow you to affect the UI, like when you want to display a progress dialog. So take a walk through your own app and see if there are places where it stops responding or gets exceptionally slow in response to a user action, and then move all of that extra work off the main thread. But, thoughtfully. Don't just change things willy-nilly. Because while threading may be intimidating, it shouldn't scare you. What is scary, though, is bad performance, which is why you should check out the rest of our Android Performance Patterns content and consider joining our G+ community for tips, tricks, and help. But most importantly, keep calm, profile your code, and always remember, perf matters.
Hello and welcome to Supercharged. Now this is a kind of TLDW. Last week I did a live stream with Surma where we made some swipeable cards. Now you probably recognize swipeable cards from things like Google Now, where you just kind of take a card and you dismiss it. And you can actually see what I've got on screen. This is what we ended up making. There you go, you see? Dismiss it and all that kind of good stuff. Now the idea is, if you've not got an hour to watch that live stream back, although if you can, I would recommend it, and you can find the link to that below. If you can't, that's exactly what this is for. I want to step through the things that we learned, the things that we did, and just so you can get an insight into what actually went into it. So, before we actually get started, what I want to do is I want to step over to Theory Corner. Oh yeah, theory. Love theory. And what we can do in Theory Corner is discuss what we need to do. Join me. Welcome to Theory Corner. You can tell it's Theory Corner because there's some theory in a corner. Now, this is what we have. We've got the cards. You can tell it's a card because it says card. The cards have will, change, transform on it. The idea I have here is that we want each card to be transformed around the screen. And so we want to give each card its own layer. The compositor then can move those around with the help of the GPU. So long as we stick to transform, opacity, and we set will change, we should be good. So we move the card as you touch and swipe. But as you get across to this side, we have this marker of like 0.35. Now I picked that at random. You could pick a different number. 0.35. If you go past that point, we basically say, well, this card is being dismissed. So we slide it off to the side. The other thing that we're going to do is we're going to change the opacity. So the further you go across, the lower the opacity in both directions. So that works there. Okay, so we're going to put each card on its own layer, and shift it side to side, and fade it out. Let's go back to reality. What we're going to do here is we're going to step into the code so you can actually see bit by bit what we actually did. Here's the cards, and what we do first of all is we basically create an array from the cards that we've got in the document. So we'd have to have some kind of code that adds or removes those cards later on, but don't worry about that. We'll just get on with what we've got here. The next thing to notice is that I've got these named functions on start, on move, on end, and update. Now the first three are our input events, and I choose to do it this way. What I do is I take a copy of it by calling .bind on this, and that takes it from the prototype into the actual instance. But it does another thing for me as well. It means that it's bound to the instance so that in those functions, when I say this dot whatever, it's actually applying to the instance and not to the target's event. No, wait, the event's target. Oh, one of those two. So it also does something else for me. It means that I can do add event listener and remove event listener, and I can call it by name. I can say like this dot on start, for example. You can see that down here in the add event listeners. So I do add event listener for touch start, touch move, touch end, mouse down, mouse move, and mouse up. All of them. Yay! And I can just basically say on start, on move, on end, and so on. And if I wanted to do the remove event listeners, I could do that, and that would just work out fine for me. So we've got our event listeners, and we have a bunch of variables here that are just sort of housekeeping, things that we need to keep a track on. The other thing I do is I start a request animation frame where I busily sort of kind of do an update. Now, if you're doing this in production, I would suggest you don't do it quite like this. I would start the request animation frame when the user starts interacting, and then when the animation's finished, I would stop doing the request animation frame loop. But for the case of this, just to keep things simple, I just start it right at the start, and I do a kind of busy loop through. So what do we actually do in the on start, on move, and on end event listeners? Wow, saying event listeners over and over and over and over and over again, that's not confusing for me. No. What do we do in those? Well, first, in the on start, the main thing is this. We basically take a marker for the start position of the interaction. Where does the user put their finger down on the screen? And then we get that with page X. The other thing we do is we take a copy of that for the current position, because as we move our finger, we're going to update the current position so we know where we started and where we currently are, and the difference is how far we want to transform the card. The other things that we do in this is we set the dragging card to say true, but as we discussed in Theory Corner, we set will change to transform. Now we can check that that actually works by going back to the code, bringing up DevTools, and in the rendering settings, we're going to show layer borders. Anything that's got its own layer is going to go orange around its border. You ready? So when I click, you can see that immediately the card gets its own layer, which is really cool. That means that we can transform and move it around cheaply, like we discussed over there in the Theory Corner. Here's what we've got in the on move. It's fairly straightforward. All we do is we take the current position of the input and we basically say that's the current X. Now inside the update, what we can do is we can say if they're dragging the card, the screen X, which is basically the position of the card on the screen, is the current minus the start. That's basically how far they've moved. And we can apply the transform to account for that. Ta-da! Now when the user stops interacting, we actually have to make a decision. If you remember over in Theory Corner, we said if the user is past that 0.35 marker, so it's a sort of a 0 to 1 range, 1 being the full distance of the card, 0 being not at all. If they go past 0.35, which is what I've chosen, but you could choose a different number, what we want to say is they are dismissing the card. And we do this by setting a target X, which we use later on in the update. And here we do screen X plus equals the target minus the current screen X over 4. What this is going to do is it's going to ease the card to that final position, which will either be the center or it'll be off to the side, depending on whether we've decided that they've gone past the point of dismissal or not. Then there's a little bit of tidy up that we do here. We basically normalize the drag distance, and we use that to set the opacity so that the further across you get, the more fadey the card is. So far, so good. So the last little bit is what we do when you dismiss the card, because what we want to do is we want to slide all the other cards into place. And we do that with this animate other cards into position function. Let me show you what it looks like without that. Let's switch off the layer borders. Okay, here's what it looks like without that. You see all the other cards just snap into place, which you could do, but doesn't look quite so nice. So what we need to do is we need to transform them down quickly to where they moved from, which will be the height of the card plus the margin. And you can see that here. So we take every card that's after the current one, which is this, and we basically say translate yourself the height of a card plus 20 pixels, which is the margin. And again, this is hard coded, so you'd probably make this more dynamic in production. And then we basically go from that to no transform at all, and we use an easing of this cubic Bezier and a duration of 150 milliseconds. And all we need to do is just say card.animate with those settings, and then when you've finished, we say the animation's complete, at which point we can just reset the target and call it a day, and the animation's done. So with that switched on, you can see we get a nice smooth animation. So the only other thing to notice is when I'm dismissing the cards, you can see that the other ones get their own layer temporarily. This is because we're using element.animate and we're using a transform, and that means that those get temporarily promoted to their own layer. Cool. That means that it's also doing the same thing that we had over in Theory Corner. We're getting its own layer, which means it happens nice and performantly, and then when it's finished, the browser automatically demotes them back, and we're all good. So there you have it, that's swipeable cards. If you've got time, make sure you watch the live stream. There's loads in there. There's us finding and fixing bugs. There's just chatting about the general approach. All sorts of goodies in there. Hopefully you've enjoyed this little TLDW. Don't forget to subscribe to the channel, and I will catch you on the flip side.
Over the steps, hopefully, but. That's fine. Yep. All right. All right, hello everyone, and welcome to What the Fragment. So, I'm Adam Powell. I'm a member of the Android framework team, specifically on the UI toolkit. But I've spent a fair amount of time with fragments over the years here, and hopefully we can go over some interesting information here. So, the first thing that people tend to ask is why fragments? There's a lot of information out on the web as people have used the API, gotten kind of familiar with it, and in some ways kind of gotten bitten by it. There's a lot of complexity there. And in fact, some members of the community have put together a few diagrams of just how complex the fragment lifecycle can be
if you combine it with the full activity lifecycle as well. So you can start up at the top here, and we keep going. And there's some more. Whew, OK, well, we got to the end. So the blurriness that you're seeing here isn't just because it's a low-res version of the image. It's just your eyes glazing over as you try and take all of this in. And this is kind of your reaction after reading over it. So why fragments? If this is kind of the reaction that everybody's had over the last few years out in the developer community, why is it still something that we're pushing or promoting as a way to build your applications? Well, to start with that, we'll go over just kind of a little bit of history about where fragments came from. So some of you might have seen a Google Plus post by Diane Hackborn this past weekend, where she went into some detail about the Android component model and how it's really not intended to impose a lot of higher level architecture on your applications. Instead, it's really just meant to be a series of smarter entry points. So in a traditional program that you might have seen in classes or so on and so forth, you start from a main function and you run to the end, and you might start a message loop in the middle there. And what activities really give you to start with is just kind of a smarter entry point, a place where the system can send you other messages about what's going on to your application, and these are just turned into callbacks on an object instead. So there were some other goals kind of in the design of activities as well, which one of those is that apps always stay in the state where you left them. So in order to do that, you have this well-defined activity lifecycle and a compact state representation that you can use so that the process can die, come back later, restore from that state. All of this is stuff that you're probably familiar with. Also, apps can call other apps to complete a task in the form of activities called with intent. And each one of those flows is represented as one of these encapsulated units in the form of these activities. So over time, activities just started getting big and complex. And basically, the way that you deal with complexity is that you factor out smaller pieces so that you can compose them. Back in the pre-Android 3.0 days, we had this thing called Local Activity Manager that could work in concert with a tab host widget that you can see here in the old Gingerbread Dialer app. So each one of these pieces and each one of these tabs actually contained a full activity. So that kind of gave some weird pieces of the code there in terms of how the code would interact. There are ideas in the activity lifecycle that just really don't make sense in this kind of composed model. And then this happened, and we're not going to talk about that. So larger screens happened, and larger screens mean larger problems. So we have this idea of how do you want to present these multiple small screens worth of UI that you may have already built in an existing application, and then sort of scale that out across other screens. Is there sort of a smaller unit of composition that you could use for that? And so that other unit of composition, spoilers, is fragments. So this was introduced around Honeycomb to try to solve some of these problems. The first one of these goals, though, was really just to break up these giant activity classes. And this is a problem that happens whether you're dealing just with small phone screens or if you're trying to scale across many different screen sizes. And it's just kind of natural that as app complexity grows, so does the complexity of these kind of big entry points that can kind of grow to be these God objects if you're not careful. We also kind of wanted to fix some of these problems with Local Activity Manager for when you do compose them in these smaller constructs. So you have lots of these abstractions at the activity level that just don't work well when you start composing it this way. These are usually things that aren't quite as well covered as like the core activity state diagram, but they're all cases that still need to be handled in a general purpose solution. One of the other things that we wanted to do with fragments was to encapsulate navigation state. So the state of your fragments can represent the full state of your activity in a way that can be preserved through state save and restore through a process death. So we have things like an activity local backstack, which some people find useful and some people don't. But manage dialogues was one of the other things that this really tried to address. Dialog fragment is something that a lot of people do use at this point, and it's because you basically get the state restoration for free if you rotate the screen or go through any other sorts of config changes. Back before Fragments, this was handled by just kind of this first-class facility that was provided by Activities, where you refer to a dialog by its ID. There's this whole other creation process involved in terms of like, yes, I want to create the dialog with this ID. We would persist that ID and try to build everything back up from scratch. And that ended up just being very one-off and kind of awkward to work with. And the final goal that was probably the most obvious in terms of how we pitched the API when it was first released is this idea of decomposing these master detail UIs. So if you have two screens that on a phone might look something like this, where you've got a list of conversations as well as the actual conversation itself as you drill down by tapping into it, use the back button to get back to where you were before. In another configuration, you could take what's essentially the same code and have it look like this. So this is something that you might be familiar with from a lot of UIs that you've seen here. And since then, we kept building on it. So we had View Pager and the Fragment Pager adapter, which a lot of people still kind of think is the way to use a View Pager, just because we don't have a stock adapter for dealing with just bare views. So we've got loaders, which allow you to do similar things of persisting some sort of a request across configuration changes, keep it going whether or not the lifecycle might otherwise interrupt. Ian Lake has a great post up on Medium about this that all of you should go read if you haven't as well. And then we also had this idea of child fragments. So, I mean, if you can nest one level deep in terms of putting fragments inside an activity, well, why can't you put fragments inside a fragment? So that was an idea that had a lot of support in terms of a lot of developers were requesting this, both within Google and external developers as well. And it got added, I think, sometime around the Jelly Bean timeframe. So how did it work out? I mean, some of you kind of already know the answer to this question, but these are sort of what we took as stewards of the API as some of the lessons from Fragments. So the first problem is that fragments are so general that they become really difficult to explain to people. So is it just a pane of a UI, like in the Gmail example? Is it something like dialogue fragments and something meant to deal with managed dialogues? Or is it something different altogether, like you can still have headless fragments that can act completely independently of anything else? And we didn't give a whole lot of guidance in terms of how to use these things because we kind of felt like we didn't want to be too prescriptive about it, and that ended up really hurting us. So, of course, the idea of even more lifecycle to manage was really kind of the killer here, and the bugs really didn't help. This is really what killed a lot of people. Whenever I've talked to developers about what they would change about the Fragment API or what problems they have in using the Fragment API, a lot of times what happens is that you build up a Fragment transaction, you commit it, and then something works completely differently from how you expect. It's not particularly intuitive, some of these things, and it might kind of remove the entire point of a bunch of code that you just spent a lot of time writing. So this was another thing that caused a lot of misconceptions. I mean, fragments, they're just kind of like views, right? I mean, you can stick this fragment tag in one of your layout files, inflate it, and you get a fragment for free. In hindsight, the fragment tag was this great piece of syntactic sugar that really confused people a lot more than it helped in terms of just general education. So this immediately made people think that fragment equals view, and that this is on the same level of abstraction. So if we kind of know where things went off the rails, then how might we start trying to use fragments a little bit more effectively? Well, the first thing to keep in mind here is that fragments are roughly equivalent to an activity in terms of the level of abstraction that they act on. They're composable entry points, and their lifecycle and inputs are really controlled by their surroundings. They optionally manage a UI presentation, and they're really kind of part of the whatever in model view whatever in terms of the architectural patterns that you may be using within your application. They're not views themselves, and they're really not meant to be. Seriously, they're not just fancy view groups. Fragments implement UIs just by using views. They compose views. They wire things up to views in order to do something more interesting. And this really kind of comes down to a core idea that isn't communicated all that widely, that we kind of keep this idea of an abstraction hierarchy across the different packages in the framework. The higher level packages are things like Android.app, whereas the views and widgets are further down the stack. And what this means in practice in terms of the organization of code within the Android framework is that anything at a higher level can import anything from a lower level, but not the other way around. And if you go looking through AOSP, you'll probably find a couple of places where we messed this up, and yes, we know it, we're sorry. But overall, it's managed to be a pretty good way of organizing some of this stuff and making sure that things keep a level of responsibility that's kind of appropriate for that type of component. So an example of this is that you might have a fragment that depends on view on click listener in order to implement that interface. This is an example of a fragment just kind of applying policy to a series of views that it's using. Emma. So while fragments can depend on views and implement the interfaces exposed by those views, it's important to remember that the views have no knowledge of fragments. That fragments really kind of sit as the policy layer above whatever UI that you've built visually and out of the structure that is used to generate input events, so on and so forth. So really, they're kind of a glue component in this case. They provide coordination of these different view components or even of other components within your app. They allow you to wire up the view events, the input events that you may be generating from those views, and tell them something interesting to do. And all of that ends up being driven by a knowledge of the external lifecycle. What's going on outside the app? What's going on outside the context of that particular fragment or activity? So this is something that others have definitely said, and I will totally echo here. Don't use a fragment when just a composite custom view group or even just a layout resource that you can use in an include tag will do the job better. A lot of times people use this as a point of where they can pivot, where they can decide what type of UI to show based on other conditions. And between the resource system and custom view groups, you can solve that problem without getting into lifecycle constructs. The real question to ask when you're talking about using a custom view group or a fragment in these cases is, does it implement mechanism or does it implement policy? Is it an isolated widget that generates its own input events? And these might be really complex as well. I mean, we've got some things in more recent versions of the support library like coordinator layout that are able to impose very complex behaviors on their child views. Things that you can push and pull and move around, swipe to dismiss, so on and so forth. But all of those essentially are still just the user acting on the UI. You might be able to swipe a snack bar away. You might be able to click an apply button on a snack bar in a coordinator layout or something. But what that actually means to the application is policy that's imposed by some other component. And that's more where fragments sit in the layering. So we also can't talk about fragments and dealing with some of the associated complexity without talking about saved state. So the navigational state of your application is partially composed by the fragments that are currently attached to it. These may have changed over time. Contents may have shifted during flight, so on and so forth, where if you have something like master detail UIs, then you might have a very different fragment that you're showing if you were drilled into item A versus drilled into item B in that list. And that's something that ideally you don't want to have to track yourself in terms of other state as it gets restored, as your process dies, you come back into it, so on and so forth. So that means that setup of fragments is conditional. And this is another one of those kind of weird things that everybody sees when they first start working with fragments. Well, why am I doing this extra check here when I'm setting up this initial state? And that's partially because the fragments are going to be restored as part of that onCreate call. Now, this has historically gotten a little bit weird in that if you're dealing with child fragments, when that reinflation happens, really wasn't consistent with the way that it happens with fragments that are attached to activities. Now, over the last several months, we've really kind of we've dived into the fragment APIs and tried to clean up a lot of these cases where the behavior was just unexpected or inconsistent, because these are the things that really made everybody hate the API to start with. So as of Android N and support library version 24, which is available as part of the preview SDK right now, child fragments are, just as with activity-attached fragments, they're consistently reinflated during the super.onCreate call that you make within your own code. So that way, after you make that call, you know that those fragments that were restored from instance state are attached to your activity. You can do find fragment by tag and actually expect to find it there. You won't end up with duplicates when you try to deal with that case. Thank you. So that alone makes things a whole lot easier to deal with. The illegal state exception? Which one? We'll get to it in a minute. Okay. So again, we keep coming back to this idea of fragment states and that giant diagram. So how do we just stop worrying and love the life cycle here? Because every one of these stages of the life cycle really does represent a significant event that can happen to your application. And just because we have a lot of them there doesn't necessarily mean that you have to care about all of them all the time. A lot of fragments that you'll write will only implement a couple of these methods, but just having all the options there can be really overwhelming when you're just looking at documentation. So, you know, that big flowchart, like I couldn't tell you everything on that big flowchart at once off the top of my head either. But the nice part about this is that you really don't have to hold all of that in your head at once. Because even though those interactions look very complex, really the fragment lifecycle is driven by what's essentially a single integer value. So this is straight out of the fragment source code, where we have these 6 states that fragments move between. And the nice thing about these states is that this isn't like a completely connected graph of states. This is linear. So when fragments move from one state to another, they move through all of the other states in turn, dispatching the appropriate methods to the fragment to deal with those life cycle events. So this leads to something really kind of convenient, which is that all you need to think about is what invariants do I need to enforce for my new state? You can keep your thinking very much constrained to each one of these individual lifecycle methods so that you don't have to worry about the state of the entire application in aggregate when you're dealing with this. More importantly, you can say, what minimum state will this component be in, or what can I count on? Since, again, the fragment states are linear, so if you know that you're up all the way at the resumed state, you know that you've been through all of the other methods. And this is one of those things that kind of seems obvious in hindsight, but again, as you're looking through the smorgasbord of methods that you can override on fragment itself, sometimes this kind of gets lost in the noise. So let's go ahead and talk about a few other things. Talked about one bug fix that was pretty significant, which is that the child fragment manager state is guaranteed after the super.onCreate call. Now this is subtly different from what I said earlier about restoring fragments from instance state, because there was this really kind of a fun bug that happens. So how many of you use execute pending transactions for some part of your work with fragments or have tried in the past? Okay, keep your hand up if you ended up regretting doing that during a debugging session later. Okay, yeah, that's a pretty close match for some of that. So execute pending transactions is this really handy method on the fragment manager that tells it, okay, all of those things that you've queued up with fragment transaction.commit, do all of them right now, all of them that you've got pending. And that's got a couple of kind of interesting issues with it that we'll get into in a minute. But one of the interesting things about that is that you have expectations after that call. Specifically, if you've committed one or more fragment transactions before that, then you expect those fragments that you've committed in that transaction to be brought up to a particular state in the lifecycle, usually matching the container. Well, it turns out that that wasn't actually how things worked. Some of you probably found this out, and this, again, came down to this idea of what happens with child fragments. You're probably noticing a bit of a theme here. So what would happen instead is that the child fragment manager itself wouldn't be brought up to the new state until long after the parents on create returned. So all of these invariants that should make it a lot more easy to reason about your program, especially when you're saying that, hey, resolve everything right now, execute pending transactions. Well, all that just kind of went out the window. So that made things a lot more difficult. That's now fixed. So again, you know that you don't have to worry about that after the call to super.onCreate. So execute pending transactions had another kind of problem as well, which was that it makes everything happen right now. And the issue with that is that different parts of your program might be committing fragment transactions at different times. So as soon as you say execute pending transaction in one piece, you may have just caused a side effect that affects some other library that you imported that uses fragments and you didn't even know about it. So we went ahead and we added a commit now method to fragment transaction, which basically does the same thing, but really kind of what you wanted instead, which is no, just this transaction, commit this one right now. This does have one particular limitation, which is that you can't deal with fragments on the back stack if you use commit now. Just because if you have other fragment transactions pending, you don't kind of want to create inversions in your back stack in terms of when those really apply. We also added a fragment on attached fragment method to match the fragment activity and activity on attached fragment method. This is kind of useful when you want to go ahead and configure a fragment as it's being attached to its parent. If you want to do any sort of injection of dependencies, if you want to do any sort of wiring up of listeners within that local activity for other events that it might publish, this is a pretty good time to do it, except there really wasn't a good place to do this with child fragments before. This was something that was entirely skipped. You couldn't even do it in the parent activity if you wanted to, because it was only ever called on the parent activity if and only if the fragment was attached directly to the activity, not any of the children. So a few other notes that are kind of useful here. This is one that some developers ran into fairly recently as we fixed some other bugs around fragment transitions, which is that to obtain the state of a fragment transition, we have to interrogate the fragment. We have to call a method on the fragment to get the transition values and what it should do. But in order to make that make sense to that fragment, we have to bring the fragment up to the created state before we ask it about the transition. So what that means in effect is that we have to bring some fragments up to the created state before they become fully attached or before they replace whatever fragment that they were replacing before. So this is one of those things that's good to be aware of. Don't assume that just because your fragment goes through the attach and create steps that all of the other surrounding state about a fragment transaction has necessarily happened yet. Again, this is something that you want to make sure that you keep your thinking within a fragment implementation scoped just to that fragment. Make sure that it's not trying to take on responsibilities outside of itself. And again, they really work best when they can behave as isolated from their surroundings. One of the things that I see people do a lot is that when a fragment becomes attached, and again, just because you have problems with state restoration of more complex objects, it's pretty common for people to say, okay, well, when I get attached to my activity, I'm going to go ahead, grab the activity, and go fishing. I'll go ahead and check out if I can find other fragments, other sibling fragments by tag, grab any other sort of associated information from that activity, downcast it to a specific type, so on and so forth. And while this ends up being pretty convenient, it also means that those fragments suddenly become a whole lot less reusable elsewhere. And while you may not care about that right from the outset, it is one of those things that tends to come back and bite people later on. And then they wonder, why didn't we have some other facility to do this, to do a cleaner injection of the dependencies, so on and so forth. Okay, so that was a lot of information really fast. And some of it probably didn't answer a lot of the core questions that you may have had coming in here, which is, I really don't like this API that I've used. Why should, change my mind? Why should I go back and give it another chance? And really the core issue here is that apps aren't getting any smaller. So when you start working, especially across large teams and across code bases that have lasted for a very long time, architectural patterns don't end up being universal. And this is part of what Diane was trying to get to in her post over this weekend as well. If you have a very long-lived code base, then what was popular and the obvious way that everyone should build their apps back when the code base was started isn't necessarily true when you're maintaining it years down the road. So one solution to that is to try to create standard, smarter components. So how many of you have taken a look at integration steps for some library for Android, and you see something that looks kind of like what's on the slide here? Okay, go ahead and add this snippet to your onCreate, this other thing to your onStart, this one to onStop. I'm pretty sure that some of our own libraries from Google have these types of instructions as well. Things where you need to call some particular method from some part of your lifecycle. And really that just makes these integrations really kind of messy. So instead of that, well, we could just have, well, add this fragment instead, and we'll go ahead and take care of those extra lifecycle steps. And that suddenly makes that a lot more reusable and a lot less error prone. And the nice thing about this is really that, or even better, you can just use one of these tags. I mean, even though we had issues around kind of general education around fragments on what they could do, it's really powerful to be able to say, here's a piece of my UI, I just want to drop this completely self-contained component here and then not think about it. To be able to just configure it, possibly from other XML attributes as specified there, and then just let that component do its thing. So the idea here is to really try and provide these single points of high-level integration that everyone can use. And that last part is really key. Again, not everyone is going to be using the same architectural patterns that your app does, and your own app may not use those patterns the same way over time either. But fragments are kind of uniquely positioned here. And that's because fragments really closely mirror that activity lifecycle. There are a few differences here and there, but by and large, like as you're thinking about invariants to enforce within a fragment, they really match what you do with activities as part of that core entry point idea for Android components. So that means that essentially they can sit below that level of abstraction of your higher level architecture that you impose upon your application. And that makes them reusable as components in the same way that views are reusable to fragments. So when fragments are communicating with the rest of the world, you really need to be careful about the types of configuration dependencies that you end up creating. Again, this comes down to that issue of, are you going fishing in your parent activity or in your parent fragment for that matter for other dependencies, and is that fragment going to blow up if those things aren't there? Are those dependencies documented? How is someone who's using that fragment necessarily going to know that that's a requirement? Now, in a code base within a particular team, again, this may not be a problem, but as things grow over time, we tend to see a lot of these patterns show up. And that means that you really do need to consider your audience as you're building these things. If you're building libraries, the answer to this is going to be a lot different from if you're just building another screen within your own application. In your own application, sure, go ahead and take a dependency on some internal component. I mean, it might help, it might hurt, but at the very least, you're not passing this out to the rest of the wider world. And also, if you are offering the ability to use fragments that are these standalone drop-in components, the onInflate method is sorely underused in some of these. So this lets you do the same thing that you do with views. Specify some configuration attributes. It might be something like an API key. It might be something like any other sort of information that you need to pass to that fragment as arguments. But you can do it without having to muck around with it in code necessarily during that initial startup phase of your application. Because again, you want to try to have one integration point with these things. All right, so this talk really wouldn't be complete if I didn't open myself up to the mic here for other questions and answers. So come on up. Sure.
Hi, two questions. First one, where it's going to be part of the support library, like commit now, there are other stuff?
Yes, those are coming into version 24 of the support library, so you can use that now in Developer Preview 3. The on-attach fragment for parent fragments I don't think quite made the cutoff for Developer Preview 3, but that'll be in the next release.
Great, and the second question, what about dialog fragments? Are still using the old commit behind the show?
What about what now?
Dialog fragments. Like if you look in the source code, you find that actually the show is using the old commit.
Dialog fragments.
How am I going to fill it out? I need a framework. Which one do I use?
That is a problem I have with frameworks, that they have a way of starting projects. Like there's a kind of expectation to use them from the offset. And yeah. I think if you're thinking, what combination of frameworks should I use to render this blank page, then I think something has sort of gone wrong. Yeah. For me, it's entirely from a performance point of view. Well, no, it's not actually. But OK, step one, performance. If your page has to load a ton of JavaScript in order to make a request for the actual data it's going to display, yes. you've lost performance. Yes. And you can sort of say, oh, but next time it's going to be cached. It might not be. You might have changed the code, busted the cache.
And it's an assumption that somebody's going to come back again. Right?
Well, it's your goal, I would say.
It's your goal, but you don't know that somebody's going to. It's like paying a big, fat, hefty tax on the assumption you're going to get a repeat view. And
That's
you
true.
might not.
That is
you
true.
might not.
Yep. And stuff falls out the cache all the time.
Yeah, exactly. So
not the service worker cache though.
Oh, you and service worker. Here we go again.
Service worker.
Da, da, da. One trick pony, Jake Archibald.
Come on, but it's got a cache. You can rely on it.
All right.
Yeah.
Okay, performance that notwithstanding, I think for me, it's about code ownership somehow. It's about a level of trust that I don't necessarily feel. And what I want to do is I want to be able to feel like my application code is the thing that's running, that I'm not running through something else that I don't necessarily understand.
Running through something else is fine because that's what a library is, right? Like you've got you've got hold both ends and you're running through bits of library that you don't understand.
Yeah.
But that's fine because if one of them starts misbehaving, rip it out, either code it yourself or find a replacement library.
But when you're going through something else.
Well, you're in something else, I think, with a framework. And the framework will vend you little bits of, it'll give you scraps, and then you do something.
Can I have some more? I'd like to work with this application.
Can you please send this data over
here? Get out.
But then the frameworks, you're sat in a tiny bubble of the overall application with a framework, and I feel like to get the most out of a framework, you need to understand how the framework is built, And these frameworks are huge, so it's really difficult to do that.
I actually feel maybe this is wrong, but it feels to me like it's a kind of, the decision is an ergonomics one. Like a developer's saying, my ergonomics trumps the user's requirements. I want to feel like, my job is easy, and what the user gets is what the user gets. And my whole approach is very much the other way. I'd rather go the extra mile, and all my users benefit, than my life is a bit easier, and I'll take some of the bad performance or the tax of using that framework. So I don't think that frameworks are inherently evil and to be avoided, but I think you want to be able to transition to one and say, yeah, now it feels like we're getting to the point where we're going to reinvent that. And I think you can only do that when you've got to a certain point with the build.
So for you, it's start light, start with libraries as when you need them, and then make the jump to frameworks only if you have to.
Agreed.
Dion, how you doing?
How's it going, Timothy?
I'm screaming to the I/O gods. You want to try it with me?
Okay, let's do it.
Ah! We're here at the ground floor of Google I/O 2016. I'm here with Dion Almer. Dion, how are you doing?
I'm doing really well. Yourself?
I'm doing fantastic.
It's go time.
We are T-minus 2 days.
Yes.
As you can tell from the forklifts and the array of things yet to be put in their place.
We're going to make it, right?
I think we're going to make it.
Okay,
I'm told we're going to make it.
Good.
We're going to sneak around and take a look at the I/O grounds right before it gets done, so you get a behind-the-scenes look at how I/O 2016 came together.
Let's do it.
Oh, now this is a completely different microenvironment. It's cool. It's very nice, and it's huge too. I think there's going to be a lot of Android and some Firebase talks in here.
Yeah, even some improv comedy.
Is that in here too? Okay, let's go find some people. Okay, so Chet Haas is here to tell us about the cool stuff that's getting set up. Have you had a chance to walk around at all?
I walked into the tent where I was supposed to be.
And did you get set up?
I did for 3 different sessions that I'm involved in this week.
Excellent. Is there anything that you're going to announce that you don't want to tell our audience right now?
Yeah, we're going to need to bleep out the following phrase and this next one too.
Android.
Not yet.
Okay. What do you hope for this I/O outside of your sessions?
Really good developer engagement. Was that the phrase you were looking for?
Yes, thank you.
Excellent.
And how are you going to achieve that engagement?
So there's actually tons and tons of really good technical sessions that are going to be presented live in rooms where we can fit a bunch of people, as well as streamed live, most of them, as well as recorded. So they're available usually every year within about 24 hours of doing the talks, which is pretty amazing. So the thing I'm looking forward to is tons and tons of sessions and content out there.
Yeah. And you are doing your usual session this year again. What's new in Android?
Yes, I am, with Romain Guy and Dan Sandler.
And any surprises there that we can look forward to?
We're going to talk about Android and let me see. I'll try to build suspense for it, but no, I think you know generally what the kind of thing it's going to be in there.
All the new stuff.
Most of it. As much as we can fit in 45 minutes.
Tell me about the dinosaur.
Yeah, so have you used Chrome before? It's a web browser?
Yes, I've used Chrome before.
Have you ever been offline before?
Once, in 1998.
Nice.
Yeah.
So there's this fun little feature of Chrome where if you're offline, a little dinosaur comes up and there's actually a game that's in there and you start hitting the spacebar and it jumps around. And this year, we want to kill this dinosaur. We want to kill it.
But no, I totally know what you're saying, though. It's like every time I'm on my mobile device and the service cuts out and my experience stops because of it, it's a bummer.
Yeah, exactly.
And it doesn't have to.
It doesn't have to. And like, we always think of the offline use case of like, oh, what if we make it so when Timothy's on a plane, it still works? But in reality, with cell networks and the like, it's going up and down all the time. Yeah. So you don't want to just be in that second where you've got poor network capability, oh, it stops responding. Now you can take ownership of that.
I think, we're going to explore this in some detail again later, too. But the cool thing is it's got an NFC, and you can just tap your Android phone, and it keeps score for you.
So what would the score be right now if we'd...
You'd be winning. Decisively.
I'm British, so, table football is in my blood. Thanks for hanging out, man.
Hey, Dion, thanks for hanging out with me as well. It was really fun to explore behind the scenes at Google I/O 2016 with you.
Yeah, I hope the developers have a great time this year.
I think that they will.
Firebase makes authentication easy for end users and developers. Most applications need to know the identity of a user so they can provide a customized experience and keep their data secure. Firebase supports lots of different ways for your users to authenticate. If your users want to authenticate with their email address, you can build that for them. Firebase Auth has built-in functionality for third-party providers such as Facebook, Twitter, GitHub, and Google. It can also integrate with your existing account system if you have one. You're given the choice about how to present login to the user. You can build your own interface, or you can take advantage of our open source UI, which is fully customizable and incorporates years of Google's experience in building simple sign-in UX. No matter which one you use, once a user authenticates, 3 things happen. Information about the user is returned to the device via callbacks. This allows you to personalize your app's user experience for that specific user. The user information contains a unique ID which is guaranteed to be distinct across all providers, never changing for a specific authenticated user. This unique ID is used to identify your user and what parts of your backend system they're authorized to access. Firebase will also manage your user's session so that users will remain logged in after the browser or application restarts. And of course, it works on Android, iOS, and the web. That's Firebase Auth, allowing you to focus on your users and not the sign-in infrastructure to support them.
Hey there, Polycasters. Rob here. Welcome back to the show. As we've been working on Polymer, one of the probably biggest requests that comes in from developers is when are we going to get a CDN for Polymer and for web components? Because it's kind of a pain in the butt every time you want to sort of like hack on an idea and you've got to use Bower and install a bunch of packages and wait for everything to download just so you can, play with stuff. So recently, the Polymer team has put out a brand new project, which is called PolyGit. It is a development CDN, which I'll talk about what that word means in just a second. But basically, it is a CDN that includes Polymer, all the Polymer elements, and the web components polyfill. So if you want to hack around using something like JSBin and Polymer, you can totally do that. So if you go to the website polygit.org, you see that it bills itself as the Polymer Magic Server. And what it's actually doing under the hood is it's just using GitHub's rawgit CDN and extracting things from there and pulling them into, JSBin or wherever you want to use the CDN. So what I want to do here is just sort of like show you some examples of how you can use the CDN, how you can configure it to actually pull in your own packages as well, and basically just get hacking really quick. So Over on jsbin.com, I've already set up this little sample bin. And the main thing to notice here is I'm using this base tag right here. And if you're not familiar with a base tag, in HTML, a base tag or a base element, it just allows you to set a URL. And then any sort of subsequent URLs that you use, like for script tags or imports, they will all be relative to that base. So what we're saying here is we want the base URL to be polygit.org/components. This components directory is where Polymer and all the Polymer elements and all that good stuff lives. And from here on out, if we have any relative URLs, it'll just pull stuff from that directory. So I'm pulling in web components.js. It's coming from that directory. I can import polymer.html. That'll also come from that directory. And so since we've got all this working off of our CDN, now we can actually sit here if we want. We can just create our own Polymer element right on JSBin. So I'm going to do that, write out a DOM module here. I'll give it an ID of like xfoo. And I'll give it a template that just says like hello from xfoo. And I'll also give it a little script tag. And inside of here, we will call the Polymer constructor. And we're going to say it is an xfoo element. And then the last thing we want to do is we want to just make sure that we use our xfoo tag somewhere in the page. And now you can see it showing up over there in our output. So this is really great if you're hanging out on the Polymer Slack channel. You run into a bug or some issue, and you're not quite sure how to explain it to folks. You can just go throw together a JS bin using polygit, and then share that JS bin with people so they can help you get unstuck. Now, I also mentioned that all the Polymer elements that we built are included in this CDN as well. So what you can also do if you find maybe a bug or an issue with something like paper tabs is you can go over here and you can just write an HTML import for paper tabs. So instead of just Polymer, I'll also pull in paper tabs. And then you can just start using that element in your page here. So I'll say I want a set of paper tabs. And then inside of here, I will write out maybe like 2 or 3 paper tabs. So we'll say this first tab is called foo. Second one is going to be called bar. And the last one will be baz. Foo, bar, baz. And there we go. Now over here in our output, I've got these 3 paper tabs working just as I was expecting. And if I had some issue, I could then take this. I could save this JS bin. I could go file a GitHub issue and point the engineer at this particular JS bin. And that way, it's going to help them triage that issue a lot faster and help them debug the actual problem that you're running into and hopefully get things fixed. Now, one of the coolest things about polygit is that it is configurable. So not only does it pull in Polymer and the elements that team has created, but you can add your own GitHub repos to it as well. So if you go back to the polygit.org website, you scroll down here to the bottom, you can see that there is this sort of interesting configuration syntax. And it might look a little weird when you first see it. It took me a few times kind of working through it to understand what it's doing. But basically, what you want to do is when you are defining that base URL, you can configure it by saying, oh, I would also like to include this component. And this component might live like inside of some particular org. And maybe you want a particular version, like version 1.2.3. Or maybe you want a branch, right? Maybe you want like the master branch. That's some good handwriting right there. Or maybe you want just the latest tag. So if you include an asterisk, instead of pulling a particular version or a branch, it'll just give you whatever the latest tag happens to be. So to show you an example of that, I've again got a little JS bin here. And I'm just going to paste in a better URL here. So what I've done is I've configured polygit to pull in 2 additional dependencies. The first is the markdown.js library, which is in the chjj org on GitHub. And I've told it to grab the latest tag. And I've also told it to pull in the mark-down element, which is something that I wrote myself. That lives in the Rob Dodson org on GitHub. And again, I've just told it to pull in the latest tag there. So now both of those are available in that CDN components directory. So I can just go ahead and write an HTML import to pull in the markdown element. And then over in my body, I can just start using it. So I can have a markdown tag. And we'll just drop in like a hello world for the header there. And we can see we're getting this sort of like huge H1 rendering over there in the output. So if you're working on an element or a project or something like that, and you want to show that to folks on JSBin, you can absolutely do that using Polygit as well. The one caveat there is that it has to have been published for at least 1 hour for it to be picked up by the rawget caching CDN. But once it's been published for about an hour, it should be available to you on Polygit. Now, the last thing I want to mention here is at the very beginning of the show, we said that this is a sort of development time CDN. And what I mean by that is it's not a CDN that you want to use for production. And the reason is because we're not doing any sort of like vulcanization or anything like that to optimize the elements that we're sending down. Instead, you're getting an individual dependency for everything that you import, which is actually pretty expensive in terms of HTTP requests. So it's great for development time. It's great for hacking on ideas. But when you get to the point where you want to launch something into production, you still want to use a package manager like Bower. You still want to use a process like Vulcanize to make sure you're sending down the absolute smallest payload possible. But if you just want to mess around with some ideas, it's perfect for that. So that about covers it for today. If you have any questions, please leave them for me down in the comments. Or you can always hit me up on a social network of your choosing at #AskPolymer. As always, thank you so much for watching, and I'll see you next time.
Welcome back. We've covered a lot of ground already, so today I want to review and reinforce concepts. To do that, we'll explore two things. First, we'll code up a basic pipeline for supervised learning. I'll show you how multiple classifiers can solve the same problem. Next, we'll build up a little more intuition for what it means for an algorithm to learn something from data. Because that sounds kind of magical, but it's not. To kick things off, let's look at a common experiment you might want to do. Imagine you're building a spam classifier. That's just a function that labels an incoming email as spam or not spam. Now say you've already collected a dataset and you're ready to train a model. But before you put it into production, there's a question you need to answer first. How accurate will it be when you use it to classify emails that weren't in your training data? As best we can, we want to verify our models work well before we deploy them. And we can do an experiment to help us figure that out. One approach is to partition our dataset into two parts. We'll call these train and test. We'll use train to train our model and test to see how accurate it is on new data. That's a common pattern, so let's see how it looks in code. To kick things off, let's import a dataset into scikit. We'll use Iris again because it's handily included. Now we already saw Iris in episode 2, but what we haven't seen before is that I'm calling the features X and the labels Y. Why is that? Well, that's because one way to think of a classifier is as a function. At a high level, you can think of X as the input and Y as the output. I'll talk more about that in the second half of this episode. After we import the dataset, the first thing we want to do is partition it into train and test. And to do that, we can import a handy utility, and it makes the syntax clear. We're taking our X's and our Y's, or our features and labels, and partitioning them into two sets. Xtrain and Ytrain are the features and labels for the training set, and Xtest and Ytest are the features and labels for the testing set. Here I'm just saying that I want half the data to be used for testing. So if we have 150 examples in Iris, 75 will be in train and 75 will be in test. Now we'll create our classifier. I'll use two different types here to show you how they accomplish the same task. Let's start with the decision tree we've already seen. Note there's only 2 lines of code that are classifier specific. Now let's train the classifier using our training data. At this point, it's ready to be used to classify data. And next we'll call the predict method and use it to classify our testing data. If you print out the predictions, you'll see there are a list of numbers. These correspond to the type of iris the classifier predicts for each row in the testing data. Now let's see how accurate our classifier was on the testing set. Recall that up top we have the true labels for the testing data. To calculate our accuracy, we can compare the predicted labels to the true labels and tally up the score. There's a convenience method in scikit we can import to do that. Notice here our accuracy was over 90%. If you try this on your own, it might be a little bit different because of some randomness in how the trained test data is partitioned. Now here's something interesting. By replacing these 2 lines, we can use a different classifier to accomplish the same task. Instead of using a decision tree, we'll use one called k-nearest neighbors. If we run our experiment, we'll see that the code works in exactly the same way. The accuracy may be different when you run it because this classifier works a little bit differently, and because of the randomness in the train test split. Likewise, if we wanted to use a more sophisticated classifier, we could just import it and change these two lines. Otherwise, our code is the same. The takeaway here is that while there are many different types of classifiers, at a high level, they have a similar interface. Now let's talk a little bit more about what it means to learn from data. Earlier I said we called the features X and the labels Y because they were the input and output of a function. Now of course a function is something we already know from programming. Def classify, there's our function. As we already know in supervised learning, we don't want to write this ourselves. We want an algorithm to learn it from training data. So what does it mean to learn a function? Well, a function is just a mapping from input to output values. Here's a function you might have seen before, y equals mx plus b. That's the equation for a line, and there are two parameters, m, which gives the slope, and b, which gives the y-intercept. Given these parameters, of course, we can plot the function for different values of x. Now in supervised learning, our classify function might have some parameters as well, but the input x are the features for an example we want to classify, and the output y is a label, like spam or not spam, or a type of flower. So what could the body of the function look like? Well, that's the part we want to write algorithmically, or in other words, learn. The important thing to understand here is we're not starting from scratch and pulling the body of the function out of thin air. Instead, we start with a model. And you can think of a model as the prototype for or the rules that define the body of our function. Typically, a model has parameters that we can adjust with our training data. And here's a high-level example of how this process works. Let's look at a toy dataset and think about what kind of model we could use as a classifier. Pretend we're interested in distinguishing between red dots and green dots, some of which I've drawn here on a graph. To do that, we'll use just two features, the x and y coordinates of a dot. Now let's think about how we could classify this data. We want a function that considers a new dot it's never seen before and classifies it as red or green. In fact, there might be a lot of data we want to classify. Here I've drawn our testing examples in light green and light red. These are dots that weren't in our training data. The classifier has never seen them before, so how can it predict the right label? Well, imagine if we could somehow draw a line across the data, like this. Then we could say that dots to the left of the line are green, and dots to the right of the line are red. And this line can serve as our classifier. So how can we learn this line? Well, one way is to use the training data to adjust the parameters of a model. And let's say the model we use is a simple straight line like we saw before. That means we have two parameters to adjust, m and b. And by changing them, we can change where the line appears. So how could we learn the right parameters? Well, one idea is that we can iteratively adjust them using our training data. For example, we might start with a random line and use it to classify the first training example. If it gets it right, we don't need to change our line, so we move on to the next one. But on the other hand, if it gets it wrong, we could slightly adjust the parameters of our model to make it more accurate. The takeaway here is this. One way to think of learning is using training data to adjust the parameters of a model. Now here's something really special. It's called TensorFlow Playground. This is a beautiful example of a neural network you can run and experiment with right in your browser. Now this deserves its own episode for sure, but for now, go ahead and play with it. It's awesome. The playground comes with different data sets you can try out. Some are very simple. For example, we could use our line to classify this one. Some data sets are much more complex. This data set is especially hard, and see if you can build a network to classify it. Now you can think of a neural network as a more sophisticated type of classifier, like a decision tree or a simple line. But in principle, the idea is similar. Okay, hope that was helpful. I just created a Twitter that you can follow to be notified of new episodes, and the next one should be out in a couple of weeks, depending on how much work I'm doing for Google I/O. Thanks as always for watching, and I'll see you next time.
So in a previous video, you learned that you can use GCM to send notifications through APNS to iOS devices. But to many developers, APNS is a bit of a black box. And come to think of it, so is GCM. Put them together and you've got a black rectangle, I guess. Well, personally, I find having a little background on how things work underneath the hood can help out a lot when stuff goes wrong. So let's shine a light on half of this big old rectangle on this episode of Route 85. So APNS is a service that sends notifications to iOS devices, whether the target app is in the foreground or in the background. So how does it work? Well, for starters, you need two important configuration bits to make this happen. First off, the device token. You can basically think of this as the address of the device you want to talk to, but one that's unique for your app. It's also not really the address of the device. You know how when rock stars check into a hotel, they use a fake name? Well, the device token is kind of like having that fake name. It lets the hotel manager know that, hey, it's cool for you to visit your rock star friend because you know the alias that they're checked in under. That Matt and Kim kind of looks like them, right? Yeah. So when your app gets permission from your user to receive notifications, iOS talks to APNS and requests a device token, basically a fake rock star name, which is then given to your app. Now, if you were just building an iOS app using nothing but APNS, you'd need to pass this token back to your server somehow. We'll get into what GCM does at a later point. When your server passes this device token back to APNS, it's your way of both identifying the device you want to talk to, as well as proving to APNS that you're allowed to notify that device in the first place. The next bit you need is the APNS certificate. This basically allows your server to talk to APNS securely. And hang on, we've got some massively oversimplified explanations coming your way. One common way for two devices to talk to each other securely is to use public and private key encryption. Alice encrypts messages using Bob's public key, which only he can decode on his side using his private key, and then, vice versa. So let's imagine your server is Alice in this scenario. And if you want to talk back and forth to APNS, you're going to need your own private key and APNS's public key. In some cases, like the OpenSSL tool that you can run from the command line, you pass these two keys in separately. But for many third-party tools, including GCM, these two keys are combined together, along with some other information, into a P12 file that we colloquially refer to as the APNS certificate. So with all that background, let's look at what happens when we send off a notification via APNS using, say, a little server that you might have. For starters, we'll use that certificate we just talked about, containing your private key and APNS's public key, so that you can talk securely to the APNS service. Yes, I know APNS service is redundant. Shut up. Now, when you send off a notification, you're going to need to include things like the notification message, badge count, or any associated data, and you're going to send all of that along with the device token. Now, when APNS receives that token, it's going to do some verification. It'll make sure it's a valid token, it hasn't been revoked, and that it actually belongs to your app. At this point, if everything looks good, it will go ahead and schedule the delivery of that notification at some point in the future. When does it actually deliver it? Honestly, that's kind of up to Apple, and they're not super explicit about the logic they use. There are a lot of different factors involved, though. But you can influence this by labeling your messages as high priority, which has a priority value of 10 here, or normal priority with a value of 5. A high priority message would be for something where the user might get upset if they don't receive their message on time. A chat message or a calendar reminder is a good example here. A normal priority message is for something less time critical. APNS will often group these messages and send them all at once as a way to conserve the user's battery, and they may even get throttled and not sent at all. But still, it's a good way of respecting your user's battery, so if it's not an urgent notification, consider sending it normal priority. Now, what happens when your device receives the notification? It depends a lot on what's going on with your app at the time. If your app is in the foreground, iOS will simply hand the notification off to your app. It won't show any kind of display at the system level. That's completely left up for your app to deal with. If your app is in the background, iOS will commonly show a notification, usually as a banner up on top here, but it depends on your settings, and it'll probably be listed in the notifications panel as well. If the user selects that notification, your app will come back into the foreground, and at that point your app has a chance to handle the notification. Now, there's one other attribute of notifications you should be aware of, and that is the content available flag. The purpose of this flag is to tell iOS that this would be a good time for your app to do a little background work. For example, you might want to tell your news app that you have some breaking news available, and your app should go and download and refresh the day's top headlines. Now, these notifications always need to be sent as normal priority, and developers typically send these as silent notifications. That is, they're usually sent without an associated alert message or sound, so the user doesn't notice them. When iOS gets these kind of content available messages, it will pass the notification along to your app, and your app will have up to 30 seconds, but it might be a little less depending on certain factors, to do whatever background work it needs to do, and then let iOS know that it's finished. Now, how you actually handle these notifications and what methods you use are all very good topics that I am going to leave to another video. Honestly, you're troopers for sticking out with me this far. So there you go, that's APNS in an overly simplified nutshell. But wait, this is a video series on GCM, right? How does GCM fit into this whole scenario? Well, we will take a look at the second half of our black rectangle in a future video. In the meantime, feel free to check out our documentation, and we will see you soon on Route 85.
These are really good. How much is one of these if I want to buy it? No idea. You don't even buy them. You buy like segments of them, right?
Yeah, you can kind of see the seam. It's where there's right about here.
Ooh,
in a grid.
Feels weird.
So you buy as many of those squares as you want, and you just glue them together to get whatever size and even like dimensions.
Right.
You don't have to live in the 16:9
Wow.
world. You can kind of do whatever you want. But then there's the box that drives them on top of the panels themselves.
I see.
And they're definitely, like, not all those light you see on their faces when you go to one of the darker ones.
Yeah.
It's these things lighting up most of this room.
I'm going to go and say hello to some people. Hello, hello. Hello, welcome. Hello, welcome. Welcome, hello, hello. Loads of seats on the other side. Welcome, welcome, hello. Hello, welcome, welcome. There's loads of seats on the other side. Welcome, hello. Huh?
2 minutes out.
Ah, okay, cool. I think the queue has mostly arrived. All set?
Almost.
Is he going to put his arm down?
Yep, there you go.
Okay, great. All right. Hello. Hello, everybody. Welcome. My name's Peter, and I am the product manager for Eddystone and the Google Beacon platform. And I am uncomfortably excited today to be talking to you about location and proximity superpowers. So we're going to cover a whole bunch of stuff, and it's going to be awesome. So if my clicker works, oh, that was the laser pointer. We're going to get into some code, but before we do that, I want to introduce you to my dog. This is Oscar. Oscar is like my sidekick, I suppose, if we're talking about superpowers. He is a 4-year-old Papillon, and one of my favorite things is taking him up to Hampstead Heath in London, near where I live, and taking him for a long walk amongst all the trees and the bushes. And while I'm walking along, he's constantly sniffing, discovering all the interesting smells, like, is this an important bush? Is this a stick I should be playing with? He has a fantastic sense of all of the important places and objects that are around him. And this session is about to make your users' devices almost as awesome as Oscar. So today, I want to talk to you a bit about a few sort of location-based experiences. So here are a few examples from within Google Apps. In the Photos app, I can search for photos I took when I was at Google in New York. There's Timeline for helping users to rediscover places that they've been to and experiences they've had there. And then there's sort of popular times for one of my favorite restaurants here in London that reminds me it's been 2 months, I should probably go again. And these kind of location-based experiences make apps really compelling. If you can provide services to your users that take account of the important places and objects to them, then you can build engagement and be much more successful. So all of these are powered by a complicated array of sensors in the user's device, but the experience at the end of it is really simple. They use Wi-Fi, cell tower location, GPS to produce this kind of thing. But what we want to do is to provide really simple APIs to be able to develop your own apps, and even in cases where you don't have an app, on top of this platform. So today, we will cover Eddystone. Eddystone is the open beacon format from Google. And we want to make it so that the beacons you have on your desk actually become useful quite quickly. We're then going to talk about how to link your beacons with the cloud so that you can think of them much more like cloud objects. That is, we're going to talk about attachments, subscriptions in Nearby, and sharing those beacons with others, so that this physical widget gets all of the power of the cloud. And then last up, we're going to talk about something new that was announced an hour ago in stage 1, I think. Powering experiences at your venue through Google. So even in the case where you don't have your app installed, how can you use beacons to bring awesome experiences to your users? So what is the technology we're going to use? Well, we're going to use beacons. And in fact, beacons are not new at all. If I can advance the slide. Yes, beacons are not new. So here is an example of a beacon, a lighthouse. And all of the components of the Google Beacon platform are similar to a lighthouse and a ship at sea. So you have the lighthouse itself. That's the Eddystone beacon. It just sits there, and it broadcasts an identifier to the world. Meanwhile, out at sea, the captain of the ship has got their telescope. They're looking out for all of the beacons that are around the coastlines of countries. That's like the Nearby API in Android and the CocoaPod for iOS. But just citing the beacon is not that useful. You're also going to need a chart with all of the beacons mapped out on it to look up exactly where you are. And that chart is provided by the Proximity Beacon API, which is the cloud service that you can use to register beacons with Google. So we're going to go through each of those parts, but with the Google Beacon platform rather than lighthouses and ships. And by the end of this session, you're going to be able to build awesome beacon-powered experiences in your app. And also, we're going to give you some ideas for how to use beacons in the cases where your app is not yet on the user's device. So what is a BLE beacon? Well, I have one just here. They're sort of simple, typically battery-powered devices that you can use to mark important places and objects in the world. You stick them on the object, and they just broadcast an identifier. They do exactly one thing. The identifier that they broadcast is only 31 bytes long. And by the time you've got rid of all the headers, there's not really very much space left for content. So by placing an abstract identifier in your beacon that you mark, you make devices that come near it aware of that place. Because beacons only accept connections from devices when they're being configured, they're really good for deploying in public places. So you don't want users' devices to have to connect to these Bluetooth things all the time. You just want your user's device to have a great idea about the important places and objects around it. So beacons have been around for a little while, and Bluetooth beacons have as well. And in the olden days, we sort of had this model that you would deploy a beacon, it would talk to a particular app, and it would probably power a particular feature in that app. We're taking a slightly different approach with Eddystone and the Google Beacon platform. We're interested in having one beacon, or many beacons, with many uses. So you deploy your infrastructure once, and then you can reuse it multiple times in different apps from different people, all coming to your venue. So what is step one? Well, we've provided an app for you to get started. It's called Beacon Tools, available on the Play Store and the iOS App Store. Download this app, and you'll be able to talk to beacons. It's an app that allows you to register beacons with the Google Cloud Platform. So it sits between the beacon and Proximity Beacon API. You can register beacons that have a number of different frame types. This is the complete Eddystone specification. There are 4 frame types in Eddystone. There's Eddystone UID, which is the abstract marker for a particular place. For cases where you're interested in controlling who has access to your beacon signal, there's Eddystone EID. I'll talk a bit about that in a minute. Then the 3rd frame type is a telemetry frame. This reports on a beacon's battery level, which makes it easy to monitor a fleet of beacons once they're deployed in the wild. And then finally, you can put a really tiny URL into the beacon frame itself. An Eddystone URL forms the backbone of the physical web. So I want to talk a bit more about Eddystone EID. And you can see I've made a beacon with a pretty colorful center just here. What that represents is that the beacon frame itself is continuously changing. So I have a beacon, it's broadcasting one frame, and then a few minutes later, it's broadcasting a different frame. And your beacon generates those frames based upon a cryptographic key that's stored within the beacon itself. That key is also shared with another service, which is able to resolve a sighting of that particular beacon to a stable ID so that you can make use of it in your app. It's particularly good for cases where you want to control who has access to the beacon signal that you're deploying. And the good news is that all of our APIs support UID and EID transparently. So you don't have to bother thinking about EID. You can deploy mixed networks of UID and EID beacons and still talk to them both through the same nearby API in Android. So that's Eddystone. We've got static identifiers, which are, in a sense, the simplest way to get started. And we've got ephemeral identifiers. And these are the ones that are ideal for controlling your beacon signal. But that's just the beacon itself. The real power comes from the cloud service that you associate where you put that beacon. And that is fronted by Proximity Beacon API. Proximity Beacon API is an API that fronts Google's beacon registry that allows you to register beacons, associate information with them, and add attachments which can be used by your own app. So a beacon object looks a bit like this. I've represented it as a box. And within the box, we've got 3 attachments represented by these 3 colors. So let's have a look at the beacon registry entry itself. Here is the list of properties that you can associate with a beacon. First up, you can assign the beacon a description. The description of the beacon is your human-readable name for that particular beacon. And we'll talk a bit about how you can search for things like that later. You can add properties to a beacon, so it's sometimes useful to remember the transmit power that you associated with a particular beacon, or some other properties that are relevant to your particular venue. Then the next set of objects is to do with place and location. When you register a beacon with Google, you can associate a place ID with it, which goes into the heart of Google's location infrastructure. So all of the at-a-place functionality that I showed earlier just gets better when you have a beacon signal registered with a place ID. As well as that, beacons enable new kinds of precise locations. So in particular, you can associate an indoor level with a beacon, which makes it much easier for your app to detect which level a user is on in a building. This last field, expected stability, allows you to distinguish between beacons that you deploy in a static place, sort of marking important places in a building, and those perhaps that are on a bus or a food truck or move around. Finally, we have the ephemeral ID registration object, which keeps all of the records necessary to support Eddystone EID. So if you're using Eddystone EID beacons, you'll need to talk to this part of the API. And finally, when you provision a beacon using the Eddystone GATT service, there is a key that you can use to unlock that particular hardware, and we can store that for you to make beacon administration easier later on. So what's next? We have a beacon, we have a cloud service. On a user's device in the middle, we have the Nearby API. And I want to take you on a sort of brief tour of the Nearby API, showing how you can use it to fetch attachments back to your beacon, back to your user's device. So this is what you need to put in your manifest. It's important that you put your API key to talk to the Nearby Messages API. You also need a service running in the background for if you want background beacon scanning. And you can also put intent filters in your manifest as well. And that's something you should do because of a reason I'm going to tell you about in a bit. Once you've connected to the API, once you've connected to Google Play services in your Android activity, then this is the meat of your subscription. So this is where you tell the Nearby API that I'm interested in attachments of a particular namespace and a particular type. It's that line under set filter. So what happens next? Well, the Nearby API takes all of the information that you've given it, and it does beacon scanning for you. Notice that you don't have to care about the actual bytes that the beacon is broadcasting. You've created a subscription to a cloud object, and Nearby is going to hide all of the sophistication in the background. So Nearby goes out looking for beacons. And when it does beacon scans, it shares them across all apps that have active subscriptions. As well as that, when the Android platform does scans, they're also shared to Nearby. So you get a lot more scans for a lot less battery use. When Nearby comes out and finds a beacon, it will query the Proximity Beacon API to say, hey, I found this beacon. I don't know what it means. And Proximity Beacon API will return attachments that were the ones that you had subscribed to. So let's take a look at what an attachment looks like. They're pretty simple objects. They have these 2 important fields. The first one is the namespace type for the project. The namespace is owned by your project. So you have a namespace for your particular developer console project. After that, you can put a type for each attachment. That could be platforms at a station, or it could be different types of vehicle. It can be anything you want. And then the second field is the data that you associate with that beacon under that namespace type. So this is where you put the information that you actually want to get back in your app when your user cites that particular beacon. If you're calling the API directly, remember to base64 encode it. But our tools take care of that for you. So Nearby had this subscription to a particular namespace and type. Proximity Beacon API decided if there were any attachments on the beacon that had been seen that correlated with your particular subscription. And then those attachments are returned to your app so that it can behave as you would expect. Launched this morning, if you don't care about sort of integrating with APIs and so on, you can use the Beacon dashboard. This is a web dashboard that actually uses the JavaScript client library to Proximity Beacon API and allows you to visualize all of your beacons and edit the information associated with them. So for a particular beacon object, registering a beacon just becomes filling in a bunch of fields on here. We think this is really cool. You can also add attachments. Here is an example of an attachment that I added this morning. And you can see it's a simple matter of filling in 2 fields on a web dashboard. You now have a registered beacon and an attachment associated with it. So where have we come? Well, we started with a beacon. We provisioned it using beacon tools, which you can get from the Play Store or the iOS App Store. Then we associated that beacon in the cloud with Proximity Beacon API, which allowed us to create this beacon object and add attachments to it. If you didn't want to call the API, we had the dashboard. And then down in the bottom right, we've got the model of what happens when a user's device comes across a beacon. And as I said earlier, it doesn't matter whether you're using Eddystone UID or Eddystone EID, Nearby will behave exactly the same. You just create a subscription to the namespace and type of attachment that you're interested in. So I mentioned earlier that there are sort of good reasons for registering beacons in the cloud. And one of those is that you can create a beacon network and share it with many different developers. So launched recently, Proximity Beacon API is one of the first APIs to use Google Cloud's identity and access management roles, giving fine-grained control over which developers can make use of your beacon network. So here we go. Here is a picture of the Google Cloud Platform Developer Console. And under Identity and Access Management, you can add members to your project. So these are adding developers who can sort of do things with resources that are in your project, things like compute engine instances or data store and so on. And Proximity Beacon API is one of these. So once you've enabled the API, you can add a developer and choose from the roles that we have available. So these are the new roles. And I want to just go through them a bit and tell you about what they allow developers to do with your beacon network. So first up is Beacon Editor. If you grant a developer this role, then they're able to add beacons to your project. It's important if, for example, the person who's writing the app is not the person who's going and sticking up the beacon. The person who's going and sticking up the beacon, you want them to be able to register beacons to your project, but you don't want them to be able to fire up compute engine instances. So Beacon Editor is a role that you can assign to a user or to a group to enable them to add beacons to your project. And it's important to note that beacon IDs are universally unique in Google's beacon registry. So once a beacon has been registered, it can't be registered by a different project. Next up, we have Attachment Editor. Now, I mentioned earlier that attachments have namespaces associated with them, and the namespace belongs to your project. Attachment Editor allows you to say, I want this developer to be able to add attachments to my beacons in my namespace. So that means that they can add attachments that can interact with your app. And they can do this in combination with Beacon Editor, so they can register a beacon to your project, and they can add attachments to it as well, without all of the other permissions that come as a result of being an owner of a project. Finally is Attachment Publisher. What this allows, you can say that developer can create attachments in their own namespace on my beacons. So I have a beacon network, and I can say, my friend here, I want them to be able to add attachments in their own namespace that will talk to their own app on my beacons. And these roles and these new sharing paradigms allow a bunch of useful things. So here we have 3 different phones belonging to 3 different users with 3 different active nearby subscriptions, all talking to the same beacon. And these attachments can be added by different developers. So there's a lot of flexibility in the way that you can use a beacon network. You don't any longer just deploy one beacon for one app. We have one beacon with many uses. Great. Yeah, it's awesome. Right, so interacting with Google products. Sometimes people come to me and they say, Peter, PM for beacons. This is fantastic, but my app has to be everywhere in order for it to be useful. This is not true. So what I want to talk about now is how you can take your beacons and interact with Google products at the heart of Android, like nearby notifications. So nearby notifications was announced just an hour ago and is available in the next version of Google Play Services. But what I want to tell you today is how you can register beacons today and add attachments that will interact with nearby notifications. Nearby notifications allows you to prompt notifications in Android in 3 different categories of cases. You can associate web URLs with your beacons. So you've registered a beacon, you can associate a URL with it. You can associate app intents. So remember earlier, I said make sure that you've put intents in your Android manifest. You can point to those intents with a beacon attachment, and if the user doesn't have your app installed, you can have a URL as the fallback. So if I have your app installed, I come near the beacon, it intents into your app. If I don't have your app installed, it says, here is a website. And then last up, there's direct app installs. So this is an early program, and we're holding it behind a whitelist at the moment. So if you would like to apply to have your app whitelisted for direct app installs associated with beacons, then you can go to developers.google.com/nearby/notifications, and it'll tell you how to get started. So let's have a look at what these things look like. Here are 3 examples of nearby notifications. Right up at the top, we've got an app for a coffee shop. And this passed our whitelist because of a particular reason, and that was that a user could take an action if they had the app installed right at that place. So it's very much about, is a user going to install your app and then do something immediately with it? That's a really good candidate for nearby notifications. In the second case, this is an example where at Kim's Vitamins, a web URL was associated with the beacon that pointed to a particular website managed by that business. And then at the bottom, we've got everybody's favorite example in San Francisco, apparently, paying for parking. Finding an app where you can pay for parking and actually use it right then to pay for the place where you've just parked is another good candidate for nearby notifications. So let's go back to the beacon object and have a look at it. We have 3 attachments on this beacon. The bottom 2 are attachments that you added. So they're things that interact with your app. Maybe you've got some kind of beacon functionality baked in. But we want to focus on the top one just here. And what you'll notice about it is that the namespace for this particular attachment is not your project. This is com Google Nearby, a namespace that is reserved for nearby notifications. Any developer can write attachments in this namespace, but they can only attach those attachments to their own beacons. So if you register a beacon with Google, you can write into this namespace. If this other person registers a beacon with Google, I cannot write into that namespace on that beacon. So you have to own a beacon in order to take part with nearby notifications. So let's have a look. We have the nearby attachment, and you can see that it's in this com Google Nearby namespace. In the type field, we've put en-debug. So en is a language code. We only want to show your nearby notifications to users who have set the default language on their device to the notification that you want to show. And then in the data, we've got some nearby attachment data. This is exactly the same pattern that you would build if you were putting functionality in your own app. So what does this data look like? Well, it's just some JSON with a title, a description, and a URL. You can create this dead easy, and the URL is the part that's interesting. So there's a little bit of subtlety here. I'm going to go through it quite carefully. So here are the 3 different categories of nearby notification that I mentioned before. Up at the top, this is a URL that we would associate with a direct app install. You can see it points to a particular package in the Android Play Store. In the middle, this is a URL that we would associate with if the user has the app installed, intent into it. If they don't have the app installed, then we'll fall back to a website. And then at the bottom, you've got the simple case, just a web URL. The gotcha with that one is that you have to remember it's HTTPS. So HTTP URLs are filtered out. Right. That is the end of the content for this talk. I'm now going to do a demo for your entertainment and amusement. That is possibly the most dangerous demo that's ever been done. I'm going to use 2 different kinds of radio. I'm going to use an unreleased product. I'm going to use a product that we launched this afternoon. And I'm going to use 2 different devices. So, before your very eyes, here is my beacon. It's broadcasting. And in Beacon Tools, I can search for it just like this. Excellent. It's shown up. So I provisioned this beacon earlier, and there it is. I'm going to register it. I'm glad that nobody got there before me. If somebody else had registered that beacon, this would not have worked. Right, so what I just did was I took this beacon that was broadcasting an Eddystone UID, and I registered it with my project. You can see that I tested this, maybe 7 times before I got in here. And this is the beacon dashboard that I was talking about earlier. So if I refresh it, fingers crossed, here is my new beacon that I just registered right now. By the way, if this all works, I want you guys to give a cheer that is loud enough to wake the engineers in London who made it. So I can associate some information with my beacon. So the I/O beacon. This is the human-readable label that I want to associate with the beacon so I can find it later. I can associate a place with it. So I can put it in Amphitheatre Parkway. And this will plug into the rest of Google's location infrastructure, as I mentioned before. And this particular beacon, this is not going to move around, so I'm going to make it stable. Now, here are some sort of useful administrative labels for me. So I can add in things like the TX power, the transmit power of this particular beacon. So maybe it's broadcasting at -20 dBm. Great. So I've now registered this beacon with Google. I've added a description so that I can sort of find it again. And I put a place ID with it as well. Next up, I can add attachments to it. So here is the namespace that's associated with my project, and it is very easy to add an attachment. There we go. I just press plus, and I now have a beacon registered with an attachment to it. So I can use nearby messages to get that attachment back in my app. Tomorrow, probably, you should go to the Code Labs tent, and there is a Code Lab specifically on nearby subscriptions from nearby messages. So make sure you go there in order to get some of these attachments back. And we've created a zoo of attachments around I/O. So if you do it on your own phone, you'll be able to collect all of those animals. Finally is this category, nearby notifications. So I said earlier that you have this like JSON object that you can construct, but what we decided was that we could make it easier than that. So we just have a web form that you can fill in. I can put a title in here. I can put a description for the notification that I want to show. Can somebody give me a random word? Bacon. Perfect. The bacon. This is going to prove that I'm doing this live. I'm going to put it in English. And how about we just point to www.google.com. Great. So I can check all of the details I put, and I can create the attachment like that. So what this has done is created a nearby notifications attachment on that beacon that I registered on the stage live in front of all of you. Let's go back to the device over here. And on this particular phone, I have nearby notifications running. So when I screen on, and I pull down the notification shade, and I screen on again, I am going to see a couple of websites that are not the ones that I was thinking of. Third time lucky. Boo. It looks like it might not work. So what's happening is it actually does a beacon scan when the screen comes on, and I'm hoping that it can see this beacon that is sitting right next to it. Ah, there we go. The bacon. I select that, and Google.com appears. So we registered a beacon, we added a nearby notifications attachment to it, and that took us straight to that link when the user's device came. So that is the Google Beacon platform. One beacon, many uses. I will take some questions. Thank you.
Two questions.
Sure.
One, do you get range information as in how many meters approximately? Second, how does this function offline? If you've been there before and you come back and don't have a connection, will it be cached?
The answer to your second question is
receive performance.
Yeah.
So the first time your app loads, you're going to have to render the shell itself. You'll cache that in your service worker, and you might show like a toast just to let them know, hey, this application now works offline.
Yep.
And that means that when they come back another time, like let's say they're in airplane mode, that shell will load up really, really quickly, and then it might go to the network to fetch the rest of the content. You can then cache that content so that that entire view is then available whenever they try accessing it without a network connection.
Yeah, exactly. Spot on.
We've got some performance testing we've done with the application shell model. This is using web page tests. So on first visit, we've got a relatively fast time to first meaningful paint.
And this is super important because I think that there can be scenarios where someone might take advantage of Service Worker to be like, don't worry about your first load, but I'm just going to serve up like megabytes of stuff that I'm going to cache. Afterwards, you'll be super fast. But that first load, if that takes so long to the point where the Service Worker doesn't even get registered, that's pointless. And plus, for other browsers that don't support Service Worker, you're then kind of
just damaging yourself.
Yeah, that's going to make your users go and cry in a corner.
Exactly.
You don't want that.
So you still want to be serving up just that static render of your site, just so then it just loads up as fast as humanly possible, and then progressively enhance with Service Worker to then use the app shell model.
And if you are using the app shell model, as you can see here, we've got really good, we've actually slashed our load times for first meaningful paint on repeat visits. Speaking of actually taking a look at what impact server-side rendering has on this, you don't have to use Service Worker to actually be able to get good gains. If you're building with the app shell model in mind, with server-side rendering in mind, you will get a really good first paint, even in Safari and mobile Safari on iOS.
Yeah, all the other browsers that just don't have Service Worker.
Yeah. Now, if you're wondering, okay, well, should I be using the application shell model on all of my applications? There are going to be types of apps, super simple apps. This might be overkill.
Yeah.
But if you're building something that's a little bit more complex, a little bit more dynamic, this type of model makes a ton of sense. At Google, we're using it for things like Inbox, and it's working really well there.
Yeah, I think it's one of those things you end up falling into the sit there and figure out whether it makes sense for your site or not. But I think it's a good overall model that works for a lot of different scenarios.
There's a whole ton behind this model that we way too much to explain in just one video, but we wrote up a pretty amazing article on this, if we do say so ourselves.
Well, you wrote it up and I just read it. So
you just added your name to the end of it.
Yeah, that's how I
pretty
roll.
much. Impact. That's worth checking out.
That's the format of this
It's
show,
a mediocre article at best, but it's got pretty graphics.
Yes, it does.
People should go check that out.
Yep.
Learn more about App Shell.
And then there's also the Getting Started guide for your first progressive web app, where it actually talks about the application shell model, how you can take advantage of it, as well as how it applies to the demo app that you can build in this lovely code lab.
Yep. And in that article, we also link out to tools that can help you get started with the application model really quickly that we're working on. So check that out.
Yeah, build a weather app.
So what if I told you there was a way you could compress nearly any stream of data by a factor of 10x or more? Wouldn't that be something you'd be interested in? Yeah, I thought so. Let's find out more on this episode of Route 85. So I want you to take a look at this array of numbers here. Imagine that we wanted to send this array of integers from a server to your user's device. Looks like just a bunch of random numbers, right? Well, that word random is actually the key to compressing these in an incredibly efficient manner. As you probably know, a random number generator isn't truly random. Supply a random number generator with the same seed, and you'll get the same results out every time. And we can take advantage of that fact to recreate that list of integers using a random number generator. You see, all I need to do to regenerate that array on a device is to supply 3 parameters: the seed for an agreed upon random number generator, an upper bound to apply to these results, and the length of the list. I simply supply those numbers to a method that looks a little like this, and I can recreate that original number stream. Just like that, I've built my array of 30 integers using just 2 integers and an int 32. That's a 92% compression rate. Now granted, finding that initial seed did take some work, but you know what? That work can happen in the cloud, so it doesn't really matter. What's important is that on the device, I'm able to decompress that number stream in order and time. And then, of course, once you start looking around, you can see that there's a ton of data you can compress this way. I mean, need to compress a text string? Well, what's a string but a stream of encoded integers? Once I have my stream of integers, I simply figure out what seed I need to generate them, and voila, I've compressed my string down into just 3 numbers. It's a pretty amazing savings, right? Anybody with the username of stidjexmisdizixgoodquibpubpa will be singing your praises in their reviews. And my gosh, if you think about it, an image is really just a stream of numbers broken out into several channels. Take a look at this image here, and you can see how, using our random number generator, I've been able to replace it with just 3 sets of integers for the red, green, and blue channels, respectively. Now, once again, finding the right seed can take some time, and I haven't found the perfect seed just yet. So if you look at the results carefully, you can see that this is not quite a lossless compression scheme. But I think you'll agree that for this kind of savings, these trade-offs just might be worth it. Anyway, I hope you consider using this technique the next time you have data that needs to be compressed. Remember, the more efficient you are with your users' data, the more they'll love you. Thanks again for watching. Be sure to check out other episodes of Route 85. And remember that, as my coworkers on the Android team like to say, perf matters. All right, thanks, guys. I think we're done.
Who let him into the studio again?
I couldn't say no to Elijah Wood.
But that's...
Elijah Wood.
Last episode, we used a decision tree as our classifier. Today, we'll add code to visualize it so we can see how it works under the hood. There are many types of classifiers you may have heard of before, things like neural nets or support vector machines. So why did we use a decision tree to start? Well, they have a very unique property. They're easy to read and understand. In fact, they're one of the few models that are interpretable, where you can understand exactly why the classifier makes a decision. That's amazingly useful in practice. To get started, I'll introduce you to a real dataset we'll work with today. It's called Iris. Iris is a classic machine learning problem. In it, you want to identify what type of flower you have based on different measurements, like the length and width of the petal. The dataset includes 3 different types of flowers. They're all species of iris: setosa, versicolor, and virginica. Scrolling down, you can see we're given 50 examples of each type, so 150 examples total. Notice there are 4 features that are used to describe each example. These are the length and width of the sepal and petal. And just like in our apples and oranges problem, the first 4 columns give the features, and the last column gives the labels, which is the type of flower in each row. Our goal is to use this dataset to train a classifier. Then we can use that classifier to predict what species of flower we have if we're given a new flower that we've never seen before. Knowing how to work with an existing dataset is a good skill, so let's import Iris into scikit-learn and see what it looks like in code. Conveniently, the friendly folks at Scikit provided a bunch of sample datasets, including Iris, as well as utilities to make them easy to import. We can import Iris into our code like this. The dataset includes both the table from Wikipedia as well as some metadata. The metadata tells you the names of the features and the names of different types of flowers. The features and examples themselves are contained in the data variable. For example, if I print out the first entry, you can see the measurements for this flower. These index to the feature names, so the first value refers to the sepal length and the second to sepal width, and so on. The target variable contains the labels. Likewise, these index to the target names. Let's print out the first one. A label of 0 means it's a setosa. If you look at the table from Wikipedia, you'll notice that we just printed out the first row. Now, both the data and target variables have 150 entries. If you want, you can iterate over them to print out the entire dataset like this. Now that we know how to work with the dataset, we're ready to train a classifier. But before we do that, first we need to split up the data. I'm going to remove several of the examples and put them aside for later. We'll call the examples I'm putting aside our testing data. We'll keep these separate from our training data. And later on, we'll use our testing examples to test how accurate the classifier is on data it's never seen before. Testing is actually a really important part of doing machine learning well in practice, and we'll cover it in more detail in a future episode. Just for this exercise, I'll remove one example of each type of flower. And as it happens, the dataset is ordered so the first setosa is at index 0, and the first versicolor is at 50, and so on. The syntax looks a little bit complicated, but all I'm doing is removing 3 entries from the data and target variables. Then I'll create 2 new sets of variables, one for training and one for testing. Training will have the majority of our data, and testing will have just the examples I removed. Now, just as before, we can create a decision tree classifier and train it on our training data. Before we visualize it, let's use the tree to classify our testing data. We know we have one flower of each type, and we can print out the labels we expect. Now let's see what the tree predicts. We'll give it the features for our testing data, and we'll get back labels. You can see the predicted labels match our testing data. That means it got them all right. Now keep in mind this was a very simple test, and we'll go into more detail down the road. Now let's visualize the tree so we can see how the classifier works. To do that, I'm going to copy-paste some code in from Scikit's tutorials. And because this code is for visualization and not machine learning concepts, I won't cover the details here. Note that I'm combining the code from these 2 examples to create an easy-to-read PDF. I can run our script and open up the PDF, and we can see the tree. To use it to classify data, you start by reading from the top. Each node asks a yes or no question about one of the features. For example, this node asks if the petal width is less than 0.8 centimeters. If it's true for the example you're classifying, go left, otherwise go right. Now let's use this tree to classify an example from our testing data. Here are the features and label for our first testing flower. Remember, you can find the feature names by looking at the metadata. We know this flower is a setosa, so let's see what the tree predicts. I'll resize the windows to make this easier to see. And the first question the tree asks is whether the petal width is less than 0.8 centimeters. That's the fourth feature. The answer is true, so we proceed left. At this point, we're already at a leaf node. There are no other questions to ask, so the tree gives us a prediction, setosa, and it's right. Notice the label is 0, which indexes to that type of flower. Now let's try our second testing example. This one is a versicolor. Let's see what the tree predicts. Again, we read from the top, and this time the petal width is greater than 0.8 centimeters. The answer to the tree's question is false, so we go right. The next question the tree asks is whether the petal width is less than 1.75. It's trying to narrow it down. That's true, so we go left. Now it asks if the petal length is less than 4.95. That's true, so we go left again. And finally, the tree asks if the petal width is less than 1.65. That's true, so left it is. And now we have our prediction. It's a versicolor, and that's right again. You can try the last one on your own as an exercise, and remember the way we're using the tree is the same way it works in code. So that's how you quickly visualize and read a decision tree. There's a lot more to learn here, especially how they're built automatically from examples. We'll get to that in a future episode, but for now let's close with an essential point. Every question the tree asks must be about one of your features. That means the better your features are, the better a tree you can build. And in the next episode, we'll start looking at what makes a good feature. Thanks very much for watching, and I'll see you next time.
So constraints. They're a great way for you as a developer to deal with the ever-expanding number of screen sizes, device rotations, and new form factors like slide over in the iOS world. But one unfortunate casualty in this brave new world of alignment has been the way we animate views. See, it used to be we could go around setting a UI view's position or frame with a fun little UI view animate with duration method and watch our view scoot around the screen. Oh, that was fun. But that's harder to do in a world full of constraints. Constraints don't necessarily play nicely with a view whose frame you're setting explicitly, as you can see here. Well, that leads us to this episode's quick tip sent in by Jacob Cho, a fan of Route 85 and a software engineer at Ensemble, a mobile app developer located in beautiful Vancouver, British Columbia. Jacob notes that many iOS developers forget that in addition to the old way of animating a view's position, you can also animate constraints in iOS. Let's look at how you might do that. Here's my storyboard, and as you can see here, I've got everything set up nicely using constraints. Now to move my UI image view on and off screen, I'm going to want to change this constraint here, the one that sets my image's leading edge to the leading edge of my super view. Right now it's set to -180, so it's off screen. So first I'm going to control drag from this constraint into my view controller to make it an IB outlet of type NSLayout constraint. This allows me to access it in my code. Now I can adjust it with a standard UI view animate with duration call. In this case, I'll change the constant of the constraint from -180 to 0 so that it appears on screen, and now we can give it a try. Well, that's weird. The constant definitely changed, but what happened to my animation? Well, it turns out to get this constant to animate nicely, I need to call layout if needed on my view controller's view within this animation block. We'll give it one more try, and that's much better. I now have a constraint that I can change within an animation block, and everything animates smoothly to its final position, except in cases where I want to adjust something besides my constraint's constant. Let's take a look at another example. Here I want to adjust this center square to expand or shrink to be either twice or half the width of its neighbors. Now I could do that in theory by adjusting the multiplier on the center view's width constraint, but it turns out that changing that multiplier in code doesn't work. See, constraint multipliers are a get-only property, and Xcode will give me an error. So how do I change it? Well, the answer is I don't. Instead, I create two completely different constraints and enable or disable either one as necessary. As long as I'm still calling layout if needed in my animation block, this kind of change will still animate. Now, there are two ways I can accomplish this constraint swapping. One way is to create both constraints in Interface Builder, like so. Now, Xcode will complain that these are incompatible, and it's right. So first step, we'll uninstall one of them by checking this box here. Next, we'll control drag both of these constraints into our code to make them IB outlets. And then I can enable or disable these as necessary in my animation block, like this. Once again, you'll notice I make sure we're calling layout if needed in our animation block, and we end up with a nice smooth looking animation. Look at that. The other way to accomplish this would be to create a completely new constraint in code. This is useful when I don't know in advance what I'm going to want this multiplier to be, and I need to create it dynamically. So let's see that in action. This time in my animation block, I'll first remove the old constraint. Next up, I can create a new multiplier. Let's make it slightly random just for fun. Ooh, hey, that is fun. OK, next I'll create a brand new constraint with this new multiplier and assign it to my center view width property. And then I can add it back in again to my view. Finally, I call layout if needed on the super view in the animation block, and I once again have some nicely animating views that use this new constraint that I've created. And because this is all done using constraints, you'll notice this works as intended on an iPhone in landscape mode, or even, say, a slide over view on an iPad. And once you understand that this trick simply involves removing an old constraint and adding a new one, you might discover a whole new world of animation is available to you simply by turning on and off various constraints. For example, on this screen, I can change all my views to be either left aligned or right aligned, simply by adding and removing two different groups of constraints, and then calling our now familiar layout if needed method. Pretty neat, huh? Oh, by the way, one fun little quirk about all this, if you add your new constraints before you remove the old ones, iOS will complain about all the incompatible constraints it has to deal with in those few milliseconds. So always make sure you remove the old ones first before adding the new ones. So thanks to Jacob for the quick tip. Jacob, you're going to get a very stylish Google t-shirt in the mail. But hang on, we're not done yet. You see, now that you know all about constraint animation, I have a couple more quick tips from one of Google's engineers about more efficient ways to implement it. So follow me on to the next video, because we're not done learning just yet. Click here, and otherwise, I'll see you on Route 85. Bye.
People love to use different mobile devices in different ways that suit their situation and lifestyle. Michael uses a phone to play games on the go, while Tony enjoys using a large tablet as he relaxes on the sofa. And Jen carries a small tablet in her purse for reading on the bus. But they all want to use your app on the devices they prefer. So you'll want to make sure they each have a great experience, regardless of screen size, OS version, and the features of the app they use the most. It can be taxing to test each one of these situations so that all your users can be happy. We know you'd rather not have to buy and store stacks of devices and test your app in all these circumstances. That's why we built Firebase Test Lab for Android to make it easy and affordable for you to test your app with a variety of devices and be sure it works great for all your users. Our device lab, hosted in the cloud, offers a variety of physical devices ready to test your app. The selection of devices is always growing, so your tests will stay current with the latest hardware and operating systems. The easiest way to use Firebase Test Lab is to run a robo-test. This is an intelligent, automated test that crawls your app to discover and exercise its features. You won't need to write any additional code to make use of a robo-test. For more advanced testing, you can also script the interactions with your app to simulate specific use cases and verify that everything works as expected. Test results include a detailed report for each device used, including screenshots, device logs, and any crashes that may have occurred during the test. This allows you to verify that your app is working correctly on the variety of devices and configurations you selected. It's easy to make Firebase Test Lab a part of your daily development routine, and we have multiple ways to help you test regularly and spot errors early. First, you can use the Firebase console to upload and test your app. There is also a command line interface for testing with continuous integration servers, so you can automatically test every build. During Android development, you can deploy your app directly to Firebase Test Lab using Android Studio 2.0. And finally, in the Play Store Developer Console, there is a special automated launch test that will run for Android apps published to an alpha or beta channel. To get started using Firebase Test Lab and learn how to regularly test your app on different devices and configurations, you can start with the documentation available right here. Happy testing!